Are you aware that majority of corporate level applications are programmed in Java? If you are new to Java and have been hesitant to explore it, then you have come to the right place. Hi, my name is Imran Afzal, and I've been working in IT field for over 2 decades now. I have been teaching for the last 10 years, and I have taught some of the best-selling and highest-rated courses to over 500,000 students worldwide. In this course, I will lead you through a comprehensive step-by-step journey of Java coding. We will start from the basics and move to more advanced concepts using straightforward and accessible approaches. With over 30 hours of instructional content, including tutorials, coding exercises, quizzes, you will have ample opportunities to practice and reinforce your training. Whether you are a complete beginner or already have some programming knowledge, this course is tailored to accommodate learners of all levels. And if you already possess a programming experience, imagine how quickly you will be able to breeze through the course and enhance your skills. Also, I have partnered with another instructor in this course named Kashif Ali, who possesses extensive expertise in Java coding. All right, one last thing, and most important thing. If you are someone who wants a job in Java or wants to level up their career, then this is the perfect course for you. You have 30 days to cancel and request a full refund, so you got nothing to lose. So let's go ahead and enroll. Hello, everyone. Please spend a couple of minutes with me to know what exactly you're going to learn in this entire course. I have broken down this entire course in 15 different sections. That includes quizzes as well as practice exercises. Then starting with section 1, which is about the introduction. We'll go through the computer languages and what are the different type of computer languages out there before you actually jump into Java. Then we'll get into the object oriented programming. Why do we use that? What's the difference between a regular programming and object oriented programming? Then we'll talk about programming application examples. Like what are the applications that are built using all these different type of programming languages and codes. Then we'll talk about the programmer and developer. This is one of the questions that I get asked many times. Can you tell me the difference between a programmer and developer? So I am adding that for you so you will know from the get-go the difference. Then moving on to section 2, which is starting right on to Java. We'll go into the introduction to Java, the importance and how to succeed as a Java developer. We'll talk about the tools like JDK, GRE, JVM, and IDE. Then we'll jump into section 3 where we will design our lab. So we'll get our hands dirty and start the work and start writing the code. So together we'll design the lab and do the installation of JDK in Windows as well as in Linux. So I have given you both options to pick from. Then we'll go through the JShell introduction. Moving on to section 4, which is Java basics. Always start with basic to make sure that you know everything just from the get go. First, Java code. This is where we will write hello world, the first very code that we'll do it together. Then getting into Java variables and expressions, types in Java, primitive data and types example, typecasting in Java, float versus double primitive data types, characters, strings, operators, and much more. Moving on to section 5, which is IDE, which stands for Integrated Development Environment. We'll start with introduction, then we'll get into the installation of IntelliJ IDEA. And again, I am not taking anything for granted. I'm covering Windows as well as Linux, so you could cover both. Then getting into the functionality, conditional statements, operators, so many different operators that we'll cover one by one. Then getting into section 6, expression and statement, keywords, white space, indentation, control statements. Then we'll talk about concept, different concept as a nested, then methods, overloading exercise, return statements. Coming to section 7, control statements. There are many statements we're going to go through. We're going to go through loops, debugging, local variables, classes, input, scanners. Then section 8, object oriented programming, more detailed into advanced level. Classes and objects, getters, setters, constructors, reference instances, handlers, inheritance, overloading and overriding in strings. Then section 9, pillars of object-oriented programming. We're going to go through composition, encapsulation, and polymorphism. You will learn more about this when we get through this. So right now, I'm just setting your expectations. And in this part, we will also cover arrays in detail. Everything on utility array, cloud reference, value types, runtime, multi-dimensional arrays, and much more. After arrays, we will move into advanced concepts. In section 11, you will learn array list and a linked list in detail with multiple exercises to practice. We will also work on queue, stack, iterators, autoboxing, unboxing, and enumeration. This ensures you build a solid foundation in Java collections. In section 12, we will learn abstract classes and interfaces. We will go step by step, starting from abstraction, then moving into interface concept, and finally bringing them together with summary exercises. In section 13, we will introduce generics. You will understand how generics make your code flexible and type safe. Exercise will also include comparable and working with interfaces in generics. After that section, section 14 is a practice test section where you can test your overall Java skills. Finally, section 15 provides you with a complete Java training ebook. You can revise everything offline and always keep it as a reference. Now, you at this time ask yourself, is this the course that you're looking for? I'm telling you, and I bet you this is the course. You will get everything you need to know about Java. So let's go ahead and enroll right away. What is computer language? Before we explore the topic of Java programming, first it is very important that we understand what is computer language. Computer does not know any human language. So they don't know English, French, Chinese, or any language for that matter. It only understands zeros and ones. Computer language, that zero and one language, it's called binary. Computers store all characters as numbers on hard disk because computer don't know what is hello or how are you is. Computer converts that into these numbers, zeros and ones, and that's how it stores that into the hard disk. The process of converting that data into binary code is called encoding. Now, to better understand, let's visualize it. Now, where is that 0 and 1 comes from? Your computer runs on electricity. If you unplug the power or if your battery runs out of your laptop, your computer will shut down, right? So computer to transmits the data to save that data, it actually uses 0 and 1, and that 0 and 1 concept came from the electricity. 0 means off, and 1 means on. So this I or 1 that you probably see on your switch. If you go to your switch right now, or if you have an older switch, probably newer switch don't have those 0 and 1 anymore. But if you find one in your house, you're gonna look at it closely and you're gonna see 1 on top or at the bottom, depends which country you are in. So the 1 means that turn on. 0 means to turn it off. Similarly, the computer sends or saves the data on the computer or transfer the data through these zeros and ones. Now, moving on, let's put it in an example of how it could translate a word into zeros and ones. There is a chart that's called a binary chord chart. Each letter that we have has a number or a binary number associated with it. So like A has 1000001, B has 10000010, and so on. So now let's say if you type it in hello on your keyboard. Now, how your operating system or your computer is going to translate that into its processor or memory that, hey, this hello means these digits, so process it. So the first thing it will do is will take the first character, which is H. And by looking at the chart, you will see the H translates to 10001000, meaning on, on, off. Same thing, E translate to 10000101. L, L, and O 1001111. So that's like a cheat sheet the computer has, and computer knows that when the letter H comes in or E comes in, I'm gonna have to translate into binary. And again, the binary is on and off. So when the computer puts all these numbers together, it actually sends these signals as on off, on off, on off, on off, and that's how it actually move the data from one computer to another or from your keyboard to the hard disk. I hope now you have a better understanding of computer language. You might be wondering why programming languages like Java, Python, Ruby, and so on are necessary if computer already has its native binary language. That's an excellent question. Now, allow me to clarify one thing. It is indeed possible to write programming code directly in binary language, but it would be very tedious and time consuming. The reason we use these programming languages is that they enable us to write code in a manner that is more accessible for humans to understand, debug, and of course troubleshoot in case there is an issue. So ultimately, regardless of the programming language that you use, the code you write is executed by the computer hardware in the form of binary instructions. In addition, binary language is commonly known as low-level language, while other programming languages are referred to as high-level languages. It is important to note that the term low or high level do not imply any kind of ranking. Binary language is considered low level because it directly interacts with the computer hardware, while the other programming languages operate on top of it. When a higher level language communicates with a computer, there is an intermediary component that translates it into machine or binary language. This essential bridge that you see, that middle piece between them, is known as a compiler software. So, I hope this clarifies the concept of a computer's native language and why we utilize other programming languages. In the next video, we will cover some of the commonly used programming languages available. Types of programming languages. In this lecture, we will provide an explanation of the various types of programming languages. As discussed previously, programming languages are commonly categorized into two types: low level and high level. Low level languages are designed to be understood directly by the machine and executed by the CPU. On the other hand, high level languages are more user friendly and resemble human language. By utilizing these high level languages, programmers can write code more efficiently and effectively, reducing errors and saving time. Also, high level languages are designed to be closer to natural language and allow programmers to express their intentions. So, coming back to the topic, there are various types of programming languages, each designed with different purposes and applications in mind. Here are some of the main categories. First one is procedural programming languages. In procedure programming languages, a program is divided into a series of procedures or functions that are executed in a sequential manner. These procedures contain a series of instructions that are performed step by step to solve a problem or complete a task. Examples include C, Pascal, and Fortran. The next one is object-oriented programming language, which is the primary focus of our course. The OOP, which is in short of object-oriented programming, organizes the code around objects. Now, what is an object? An object can be anything that you see around you. For example, a table, a chair, a phone, a glass, or even a cat, a game player, or even a button. It describes what a thing is and what it can do. Examples of these languages are like Java, C++, Python, C Sharp, Ruby, PHP, and so on. I will cover the object-oriented programming in more detail in the next video. The next one is functional programming. Functional languages see computation as performing calculations just like a math. They focus on making things unchangeable and avoiding actions that can cause unexpected consequences. Examples include Haskell, Lisp, and Erlang. Then there are scripting languages. These languages are designed for scripting and automation tasks. They are often understood and processed as they are read, and they can handle different types of data without strict rules. Examples include Bash, shell scripting, or C shell, JavaScript, Perl, Ruby, and so on. Then going to the next one, which is the markup language. These languages are used to define the structure, presentation, and behavior of documents. They are not traditional programming languages, but are essential for web development. And examples of markup languages include HTML, XML, and CSS. Then we have query language. These languages are designed specifically for querying and manipulating database. SQL, which stands for Structured Query Language, is the most well-known example of such language. And there are some other ones, for example, domain-specific language, concurrent programming language, and logic programming languages. Object-oriented programming. In this lecture, we will discuss object-oriented programming in more detail, and I will try my best to explain it in a very simple way. In object-oriented programming, we mainly deal with objects. An object can be anything like a person, place, or a thing. It has a specific structure and can do certain things. If you think about things that are not considered objects, we're talking about entities that don't have a clear shape or form and don't do anything specific. Examples of such non-object entities are emotions like happiness or abstract ideas like freedom. These things are not classified as objects because they don't have a physical structure and don't show actions in the same way as concrete objects do. Let me explain you the object-oriented programming through an example. Going back to the basics of programming, which is the procedural or sequential programming. In this type of programming, you write a code in a sequence, right? For example, we want to write a code which will have a set of instructions. And for that, we will use an example of driving a car and pick up groceries. So the code will look something like this. Unlock the car, start the car, check your rear view and side view mirrors, fasten your seatbelt, then of course drive to the nearest grocery store, buy a loaf of bread and a dozen eggs, and of course come back to your car and unlock the car, start the car, check your rear view and side view mirrors, fasten your seatbelt, and then drive back home. Now, if you notice that actions 1, 2, and 3, 4 are similar, to actions 7, 8, 9, and 10. Imagine if you have to stop off at another store as well, then you are repeating these steps again and again, which is, of course, not efficient. So, what we do is we define an object and its functions in something we call a class. So, it will be something like class of an object, and the object will be the car. So, for example, we define car as an object and its class that will have functions of unlock the car, start the car, check your rear view and side view mirrors, fasten your seatbelt. Now, if we write our code again, it will become a lot easier to manage. Look at that. Object is the car, then, of course, drive to the nearest grocery store, buy a loaf of bread and dozen eggs, then again, define object, which is the car, and drive back home. You see, now our code suddenly became from 11 lines to 5 lines. See, that's why the object-oriented programming became so popular. So object-oriented programming is a way of writing computer programs that focuses on organizing and managing data by grouping it together with the code that operates on the data. Or in simple word, it treats everything in a program as objects that have their own unique characteristics and behaviors. It helped programmers to create modular and reusable code by breaking down the program into smaller, self contained objects that interact with each other. Just like we created the car as an object which has its own smaller self contained program. This approach allows for easier understanding, maintenance, and of course, expansion of your program. So I hope this example that I have given you is enough and clear enough to make you understand what is an object and why we use object oriented programming when we write a program. So far, we have learned all the different type of programming languages. Now let's spend some time to understand which language is best suited for which application. I want to start off with C++. C++ is a powerful and versatile programming language that was developed as an extension of C programming language. It was created in the late 1970s with the intention of adding object-oriented programming features. All right, so let's take a few examples of C++ applications that are available today. The very first one is the operating systems. Yes, most of the operating systems that you use or build on your computers nowadays are built using C++, and examples are like Windows, Mac OS, and Linux. Then there are many games that are built using C++, such as Grand Auto Theft, The Witcher, World of Warcraft, Doom, League of Legends. Moving on to graphics and multimedia applications, such as Adobe, Autodesk, Blender, and DirectX. Then there are financial systems that are built using C++. Some of them are like trading systems, risk management software. Then there are database management systems that uses C++ language. And those database management system examples are like MySQL, PostgreSQL, and MongoDB. And then the embedded systems are also built using C++, and those systems are automotive systems, medical devices, and smart home automation. All right, that's about C++. Now let's talk about our main focus of the course, Java. Java is programming language that can run on different computer systems without needing changes. Examples of Java applications are big business software such as customer relation management system, human resources management system, supply chain, and so on. Also, Java is heavily used on websites such as banking system, e-commerce platform, content management system. Mobile apps are also built using Java, primarily in Android. Mobile apps examples are WhatsApp, Facebook, Instagram, Spotify, Airbnb, Uber, and the list keep goes on. Then other applications such as scientific applications are used or are built using Java. And examples are image analysis, processing, computational chemistry, bioinformatics, astronomy, and so on. Then, not to forget the games. There are many games that are built using Java, such as Minecraft, Runescape, and many other puzzle and game or card games that are used using Java language. All right. The next one is Python, which is easy to learn and understand. Example of Python applications are web development. Now you probably notice web development is something that can be done using many different languages. It depends the purpose of your website. You could use different languages to build it. The examples of Python web applications are Instagram, Pinterest, Dropbox, and Reddit. Data analysis and visualization is another form of application that is built using Python, and examples are Jupyter Notebook, Pandas Data Frame, Seaboard. Then moving on, machine learning and artificial intelligence applications are built using Python, and some of them are image classification, virtual assistant, healthcare applications. Moving on to the list of applications using Python is scientific computing. Then we have automation and scripting application. We also have desktop GUI application that can be built using Python, and examples of those GUI applications are like calculator, text editor, music player, spreadsheets, and so on. All right, then not to forget games. Game development can be done using Python as well. And the example of games are Snake Game, Tic-Tac-Toe, Hangman, Sudoku, and many other applications. Then moving on to C Sharp. While C Sharp is a programming language made by Microsoft, it is used to create different type of applications such as Windows desktop application, like text editor, media player, file compression. Then there are web applications such as e-commerce website, real estate listing platforms, booking and reservation system, online learning management system. Other applications are like mobile application, which are fitness tracking, expense tracking, news feed, task manager. Then games, 2D platformer, racing games, adventure simulation games can be built using C Sharp. Then moving on to Ruby. All right, Ruby is a dynamic object-oriented programming language known for its simplicity and readability. Examples of Ruby applications are web applications mainly used for social networking websites, online marketplaces, and blogging platform. Then we use command line tools or we build command line tools using Ruby. And those tools are like backup utility, password generator, network monitoring tools. Then there are automation scripts that are built using Ruby, mainly used within the operating system for tasks such as scheduler, database maintenance, deployment. Then other applications are like testing and quality insurance. And the last one, and not to forget the most famous one that is coming nowadays, really famous, are the chatbots. Those chatbots used for customer support, travel assistance, job search, and language learning. So now I'm sure you understand why we have so many different programming languages and which one is best suited for your needs. In this lecture, our focus will be on understanding the distinction between a computer programmer and a software developer. We will explore the unique roles and responsibilities associated with each profession. A computer programmer is defined as a person who has expertise in programming languages and uses such languages to create code for applications. Additionally, they might help write tests for these applications. A software development, on the other hand, is more involved in the application design. They spend a lot of effort ensuring the usability and behavior of the application, including how users interact with it, the application flow, and its accessibility. Software developers frequently collaborate with clients to fully grasp their needs and choose the best possible solution to include into the application. The primary focus of a software developer is to prioritize understanding the customer needs and finding effective solution to address those needs. They place a strong emphasis on creating user-friendly application that effectively solve customers' problem. Let's consider a scenario where ABC Bank is well-established financial institution, recognizes the increasing demand for mobile banking services among its customer base. To meet this demand and provide customers with convenient and secure access to their account, ABC Bank decides to develop a mobile banking application. The project begins with a team of software developers in this scenario. They work closely with ABC Bank's product managers, business analysts, and user experience designers. They conduct a user research, gather insights, and analyze customer needs and expectations for that mobile banking application. Based on the information, the software developers create wireframes and design mockups of the application user interface. They focus on designing an intuitive and visually appealing interface, ensuring easy navigation and smooth user interaction. They incorporate user-friendly features such as Touch ID or facial recognition for quick and secure authentication, as well as options for personalized notification and account alerts. Throughout the development process, software developers maintain a constant feedback loop with stakeholders and customers, conducting usability testing sessions and gathering feedback to iterate and improve the application's design and functionality. They prioritize understanding customer needs, designing a user friendly interface, and ensuring an optimal user experience. While the computer programmers in this scenario collaborate with the bank's IT department, software architects, and software developers, they are proficient in programming languages. Their primary responsibility is to implement the technical requirements and architecture defined by the team. The programmers start by creating an authentication module, enabling users to securely log into their accounts. They implement encryption protocols and establish secure connections with the bank servers to safeguard sensitive information. They then focus on developing the core functionalities of the mobile banking application, such as displaying account balances, transaction histories, and e-statements, as well as integrating secure payment gateways for fund transfers. They ensure that the application adheres to industry standards and best practices to mitigate security risk. The computer programmers also work closely with quality assurance team to write comprehensive test cases and conduct rigorous testing, including functional and security testings. They prioritize the technical implementation of the application's features, ensuring reliability and accuracy. In this lecture, we will start with our primary focus of Java. Previously, we covered high-level and low-level programming languages and the purpose of each language and its applications. So now, let's start with the definition. As per Wikipedia, Java is a high-level, class-based, object-oriented programming language that is designed to have as few implementation dependencies as possible. It is a general-purpose programming language intended to let programmers write once, run anywhere, meaning that the compiled Java code can run on all platforms that support Java without the need to recompile. Now, that was the exact definition out of Wikipedia. So now let's put it in a very simple words. Java is a programming language that allows you to create software and applications for various devices like computers, smartphones, and a lot more. Whenever you go find the purpose of Java, one advantage of Java will be repeated and highlighted in all of its purposes that our Java is a platform independent language. Because of this advantage, Java is also called a two-stage system. This means that Java source code is converted to machine code in two steps. In the first step, the code is translated into a special format called bytecode by a program compiler. And in the second step, the bytecode translated into machine code by a program called interpreter. This special process makes Java more secure because the code runs in a controlled environment, preventing any harmful actions. So, thanks to this Java feature, which made Java more secure and gave it the ability to run on different devices without any changes. Java was also designed to be easy to learn and use and to be efficient and reliable. These characteristics have contributed to the popularity of Java and have made it a widely used language for building a variety of applications. Now, let's talk a little about the history of Java, which is quite interesting. So, Java was originally developed by James Gosselin, Mike Sheridan, and Patrick Norton at Sun Microsystems in the early 1990s. The project was initially referred to as Oak, after an oak tree that stood outside James Gosselin's office. However, the name Oak faced some legal challenges when Sun Microsystems realized that another company already had the rights to that name. Now, as a result, they had to look for an alternative name. Eventually, in 1995, the name Java was chosen as a replacement for Oak. Now, the name Java is said to be inspired by the coffee beans from the Java island in Indonesia, reflecting the team's passion for coffee. That's why, if you see the logo of Java, it's a coffee cup because it is connected to coffee beans from Java Island, Indonesia. In the logo, the rising steam adds a fun and lively element, representing the language energetic and dynamic nature. So, Java was seen as a unique and catchy name that could be trademarked without an issues. So, using Java, James Gosselin, Mike Sheridan, and Patrick Norton initially wanted to make a system for interactive television, but later they changed it to work on the World Wide Web. So, Java was designed for one purpose but ended up being used for something else and became so popular on the internet. Java became available to the public in 1995 and became very popular because of its special features called Write Once and Run Anywhere. Then in 2010, Oracle Corporation bought Sun Microsystem, and that's when they got the Java programming language. Nowadays, Java is super famous and liked by many programmers all over the world. All right, I hope you learned something useful in this lecture as well, and I will see you in the next one. In this lecture, we will discuss the importance of Java. Java is an important programming language that has a significant impact on the software development industry. Java has gained widespread adoption and is considered one of the most popular programming language in the industry. It has a large community of developers and extensive usage across various domains. Therefore, Java is also known for its flexibility, which allows developers to adapt and extend the language to suit various programming needs. Some of the key aspects highlighting Java's flexibilities are libraries and framework, compatibility with existing system, development tools and ecosystem, community support, platform independence and backward compatibility, robustness and security. Let's go over them one by one and discuss them in more detail. The first one is libraries and framework. Java benefit from an extensive collection of libraries and framework that enhances its flexibility. These libraries cover a broad range of functionalities such as database connectivity, networking, web development, machine learning, and a lot more. Then the next one is compatibility with existing systems. Java's compatibility with legacy systems is another factor contributing to its flexibility. Java supports various integration mechanisms such as the Java database connectivity, remote method invocation, and Java message service, allowing seamless interaction with existing databases, systems, and services. Development tools and ecosystem is another important feature of Java. Java offers a robust ecosystem of development tools, including powerful integrated development environment like Eclipse, IntelliJ IDEA, and NetBeans. These tools provide features such as code completion, refactoring, debugging, and profiling, empowering developers to work efficiently and adapt their code as needed. The next one is the community support. Java benefits from a large and active community of developers who contribute to its flexibility. The community actively develops and maintains open source projects, libraries, and frameworks that extend Java's capabilities. This community support ensures a constant flow of new ideas, innovations, and solutions, enabling developers to adapt Java to their specific programming needs. Moving on, one of the most important features of Java is platform independence. So Java's platform independence is a fundamental feature that distinguishes it from many other programming languages. It allows Java programs to run on any platform that supports Java, regardless of the underlying operating system or hardware architecture. This means that a Java application developed on one platform can be easily executed on another platform without requiring any modification to the code. The key to achieving platform independence in Java is the Java Virtual Machine, in short, JVM. The JVM is an integral part of Java runtime environment, responsible for interpreting and executing Java bytecode. This eliminates the need for developers to rewrite or recompile their code for different operating systems, of course, saving time and effort. Then Java has another valuable feature called the backward compatibility. This means that newer versions of Java are made to work seamlessly with older versions. Applications built using older versions of Java can still run smoothly without needing significant changes when upgrading to newer versions of Java. Then moving on to the next one, which is robust and security. Java was designed with a strong emphasis on reliability, robustness, and security. Its strict compile time checks, exception handling mechanism, and memory management, which contributes to creating stable and bug-free applications. Additionally, Java security features such as sandboxing, strict access control, and cryptography libraries help protect against potential vulnerabilities and threats. All right, in conclusion, all these Java features makes it a versatile and reliable programming language for the for a wide range of applications in the ever evolving software development landscape. In this lecture, we are going to talk about how to succeed as a Java developer. One of the primary reasons to consider learning Java is its extensive adoption by top companies. With a history spanning over 20 years, Java has established itself as stable and reliable programming language favored by prominent IT corporations. Now, according to StackShare, around 10,000 companies include Java in their tech stack, including industry leaders such as Google, Netflix, Facebook, Airbnb, Uber, and many more. While these companies also utilize other emerging technologies, but Java remains a key component in their software development ecosystem. It is no surprise that highly trained and skilled Java developers are in high demand with attractive salaries, of course. According to Indeed.com, the average base pay for entry level Java developers is around $70,000 per year, with potential for significant growth as experience and skills increase. Now, salaries can reach up to $150 to $200,000 per year for experienced Java developers. According to Stack Overflow, that conducted a survey in 2022, Java consistently ranks among the most popular programming languages. All right, so now let's get back onto the topic how to succeed as a Java developer. It is important to stay up to date with the latest advancement frameworks and best practices through continuous learning. Explore online resources. There are many online resources where you could get your training, documentation, tutorials, and participate in forums to expand your knowledge. Apply your knowledge by working on real world projects. Then engage with the Java community. Join developers forum and participate in open source project. There are many that you will find online. So collaborating with other developers exposes you to diverse perspectives, fosters learnings, and helps you stay connected with the latest trends and opportunities. Okay, then familiarize yourself with powerful Java development tools like Eclipse, NetBeans, and IntelliJ IDEA. Now, these IDE offers a wide range of features that streamline the development, debugging, and code maintenance, ultimately boosting your productivity. Then, not to forget, write clean, efficient, and well structured code. Follow coding conventions, use proper naming conventions, and leverage design patterns to ensure your code is maintainable and scalable. All right. Then another advice is invest time in understanding the core concept of Java, including object oriented programming, inheritance, polymorphism, and exception handling. A strong foundation will empower you to tackle complex projects with confidence. Then actively seek feedbacks from peers, mentors, and experienced developers to enhance your skills. Embrace constructive criticism, learn from your mistakes, and strive for continuous improvement in your coding practices. All right, by following these guidelines and continually refining your skills, you can position yourself for success as a Java developer, opening up a world of opportunities for you in a language known for its versatility, industry support, and robustness. In this lecture, we will talk about the Java software tools such as JDK, JRE, JVM, and IDE. To write and run a Java program, we first set up Java environment. Now, what is an environment? In general sense, an environment refers to the surrounding or conditions in which something exists or operates. In the context of setting up a Java environment, it specifically refers to the configuration and preparation necessary for running Java programs either on your local machine or on a server. Setting up a Java environment involves installing the necessary software and tools that are required to develop and execute Java programs. So, the first thing that we install is JDK. which stands for Java Development Kit. It contains all the tools required to run Java programs. JDK includes a Java compiler, which is used to translate Java code into a form that can run on a computer, as well as a set of libraries and tools that are needed to develop Java applications. Now, JDK includes a component called JRE, which stands for Java Runtime Environment. JRE includes libraries as well as Java Virtual Machine, in short, JVM, which is the most important Java component. JRE is a software package that provides a runtime environment in which applications can be executed. So JVM, which is a part of JRE, is a program that interprets Java bytecode and executes it on a computer, as well as a set of libraries and tools that are needed to run Java applications. Then we must have a code editor. We will use an IDE IntelliJ in our course, which stands for Integrated Development Environment. You can use other code editors such as Eclipse or Visual Studio Code, but we'll stick around with IDE throughout this course. An IDE typically consists of a source code editor, build automation tools, and a debugger. Some IDEs also include a compiler or interpreter. So, to put it in simple words, JDK, JRE, and JVM are stored one inside the other, level by level. Now we discuss the how Java code is actually run. Our Java code executes in two steps. The first step is compilation and the second step is execution. Let's talk about the first step. The code we write in Java is called source code. The source code is stored in a file with the extension .java. All of this source code is sent to the compiler, which is included in the JDK, and the compiler converts it into bytecode with the extension .class. This bytecode can be run on any other system that has JRE installed. If you write Java code in Linux, Windows, or Mac, we simply convert it to bytecode, which can then run on any systems. Therefore, Java is called a portable or multi-platform language. The first step, compilation, is covered now. Now come to the second step, which is the execution. In this step, the JVM takes this bytecode and converts it into native code. So the native code is the code that a machine can understand. Now tell me, what is the name of the native code that we talked about earlier? What is it called? It's called binary. Yes, if you guessed it right, excellent job. Once your bytecode has been converted into that binary or native code, your machine will be able to understand it regardless of which operating system it is running on. So, in summary, we write Java code and save it in the .java extension, and it's gonna be known as source code. Then JDK has a compiler that converts this source code into bytecode with the .class extension. This process is known as compilation. Then this bytecode is given to the JVM that is inside the JRE. This bytecode is converted into the native code by the JVM. This is called execution. So, I am sure by now you have a better understanding of each Java components and how they work together. I will see you in the next lecture. In this lecture, we will go through our lab design, the lab that you will be practicing Java throughout this course. So the first thing you need to do is download and install the JDK. Don't worry if this feels a bit technical. We'll guide you through the process on both Windows and Linux. Just follow along and you will be all set in no time. Yep. Okay, so let's first identify what kind of computer you have. Also, check if your system has enough resources. Resources are like memory, CPU, and disk space. And again, don't worry, these are basic checks to ensure everything runs smoothly on your computer. So, if you're installing the JDK on Windows, remember that most modern computers use the 64-bit version. So, installing the 64-bit JDK ensures compatibility and lets your system perform at its best. For Windows, the minimum system requirements are pretty manageable. At least 2 gig of RAM, a processor with a speed of 1 gigahertz or higher, and around a 200 meg to 500 of free disk space. So once you have confirmed, then you're ready to install. Here's some good news for you. When you install the latest JDK, it also includes the JRE. That means no extra downloads or installation. You get everything bundled in one convenient package. Cool, right? Okay, after the JDK is installed, you will also find a handy tool called Java Shell, or in short, JShell. This tool is like a simple helper that lets you easily try out Java features without writing the full program, and it's perfect for Java beginners. The minimal system requirement for JShell are the same as JDK. If your system meets these, JShell work perfectly. Then move on to installing IntelliJ IDEA or IDEA, which is an integrated development environment IDE that makes programming in Java a breeze. Yep. Okay, IntelliJ IDEA helps you create well documented programs and projects efficiently. So trust me, you're gonna love this. The minimal system requirement for IntelliJ IDEA is 4 gig of RAM, a modern multi-core processor, and about 2.5 gigabit of free disk space. And I'm sure you will have it. All right, now let's talk about Linux users. We will run a few installation commands in the terminal to get the JDK up and running. The system requirement for JDK installation on Linux are pretty much the same as Windows. So there is no need to worry about extra hardware resources. Once the JDK is installed, you will get the J shell here and which will give you the same experience as Windows. So to install IntelliJ IDEA on Linux, we will write some simple installation commands or execute commands on the terminal. So once that's done, both your Windows and Linux system will be equipped with powerful Java environment. All right. In the next lecture, we will actually go through the real installation. So I'll see you in the next lecture. In this lecture, we will learn how to install JDK on Windows. So you ready? Okay. So if you're using Mac, Linux, or have already installed JDK on Windows, you can simply skip this lecture. Okay, now let's begin our JDK installation on Windows. So for that, open your favorite browser and go to the URL java.sun.com, or you could simply Google it. Then click on Java SE, the version which is right now is 17.0.5 LTS version. Okay, so now you should see three tabs: Linux, Mac OS, and Windows. Select the Windows tab and click on x64 installer. That's a download link. This will download the installer file on your computer. Once the download begins, of course, let's wait for it to finish. After the download is complete, open the installer file where it has downloaded and follow prompts to install the JDK by, of course, double clicking on it. So make sure to remember the installation location as you will need it later on. Here is my installation location for reference. Okay, after the installation is complete, you need to set the Java underscore home environment variable to point to JDK installation folder. All right, for this, follow these steps. I want you to go to the Start menu and search for Environment Variables. Click on the Edit the System Environment Variables button. Then click on the Environment Variables button. Under the System Variables section, scroll down and find the Path variable. Click on the Edit button. Then click on the New button and add the path to the JDK installation folder. Here is my JDK installation path for reference. Paste your path here, then click OK to save the changes. All right, it's all done. Let's test it to verify the JDK installation. So for that, I want you to open your command prompt and enter the command java space dash version. And of course, then hit enter. This should display the version of the JDK you have installed. If you see an error message, check the JDK installation location is correctly set in the path environment variable. All right, it's all done. Congratulations. Your Java setup is now complete on Windows. I hope you found this lecture useful and I'll see you in the next one. In this lecture, we will learn how to install JDK on Windows. So you ready? Okay, so if you're using Mac, Linux, or have already installed JDK on Windows, you can simply skip this lecture. Okay, now let's begin our JDK installation on Windows. So for that, open your favorite browser and go to the URL java.sun.com, or you could simply Google it. Then click on Java SE, the version which is right now is 17.0.5 LTS version. Okay, so now you should see three tabs: Linux, Mac OS, and Windows. Select the Windows tab and click on x64 installer. That's a download link. This will download the installer file on your computer. Once the download begins, of course, let's wait for it to finish. After the download is complete, open the installer file where it has downloaded and follow prompts to install the JDK by, of course, double clicking on it. So make sure to remember the installation location as you will need it later on. Here is my installation location for reference. Okay, after the installation is complete, you need to set the Java underscore home environment variable to point to JDK installation folder. All right, for this, follow these steps. I want you to go to the Start menu and search for Environment Variables. Click on the Edit the System Environment Variables button. Then click on the Environment Variables button. Under the System Variables section, scroll down and find the Path variable. Click on the Edit button. Then click on the New button and add the path to the JDK installation folder. Here is my JDK installation path for reference. Paste your path here, then click OK to save the changes. All right, it's all done. Let's test it to verify the JDK installation. So for that, I want you to open your command prompt and enter the command java space dash version. And of course, then hit enter. This should display the version of the JDK you have installed. If you see an error message, check the JDK installation location is correctly set in the path environment variable. All right, it's all done. Congratulations. Your Java setup is now complete on Windows. I hope you found this lecture useful and I'll see you in the next one. In this lecture, we will learn how to install JDK on Linux now. So we are going to install JDK version 17 LTS on CentOS Linux. If you're using Windows, check out the relevant lecture that we did for Windows operating system. Now let's proceed with installation. First, we log into our CentOS Linux machine as a root user. Next, we use the command java space dash version to check if JDK is installed. Nope, it's not there. So now it's time to download the Oracle Java JDK, the version LTS. For this, let's run wget command with the download link. Of course, the wget command will go out on the internet, and if you have internet, only then it will download. So make sure your CentOS Linux machine has access to the internet. So then, of course, this will download the JDK along with all the required dependency. This step may take some time, so let it finish and come back to it once it's done. All right, once it's completed, install Oracle Java JDK 17 is using the RPM command and then press enter. All right, the installation process will take some time as well, and let's wait for it to finish. All right, excellent. Now it's completed. So let's verify it. So for this, I want you to run that command again, java space dash version. All right, perfect. This should display the version of JDK that you have installed. All right, beautiful. Again, congratulations on this. Your setup for Java in Linux is now complete. I'll see you in the next lecture. In this lecture, we will learn about JShell. So, what is a JShell? JShell is a command line tool in Java that allows you to execute Java code snippets and commands. It is included in the Java Development Kit, in short JDK, of course, starting from version 9. So now the question is, why do we use JShell? So when you enter code at the JShell prompt, the tool immediately executes the code and prints the result to the console. For example, if you enter a simple math expression such as 2 plus 2, at the JShell prompt, the tool will execute the expression and print the result, which is what? 4. Yep. So JShell can be used in conjunction with other tools such as IDE, text editors, and build systems. It provides a number of commands that you can use to control the execution of your code, such as /list to list the code snippets you have entered, or /exit to exit the JShell tool. With all its features, JShell also has some limitation that it does not replace the need for IDE. It's just a handy tool to quickly get you started with Java. So JShell is automatically installed when you install the JDK. All right, now let's open the Windows terminal by typing the command CMD in the Windows Start search bar, and or you could also do Windows plus the Windows key plus R keys together. Once the terminal is open, I want you to type simply JShell. All right, now you have the JShell terminal, and it also displays the version of Java that we are using. Beautiful. To see the introduction to JShell, type the command /help space intro and press enter. Here it has all the introduction. If you want to see the available JShell commands and their uses, simply type /help command. We will cover just a few of those most popular commands, not all of them, of course. As you can see, there are commands to save and open files, reset JShell to its initial state, review your typing history, and more. Let's look at the /list command, which is one of the most important commands. The /list commands allow you to view the code snippets and commands you have entered in the current JShell session. For example, if you have typed 2 plus 2 and press enter, it shows the result 4, right? That's what it tells you. Then if you type /list command and press enter, it shows the code that you wrote earlier. So it's like a history. So to quit JShell, simply type /exit and press enter. It will display a goodbye message, and we are done with it. Okay, now let's try JShell on Linux. Let's open CentOS terminal and type JShell command. Simple. It has become a JShell terminal as Windows, right? Just like that. To see the introduction to JShell, do the same thing. Type the command /help space intro and press enter. Here it has a complete introduction page. You can see how it works the same way as it does on Windows, right? As we have practiced. All right, that's it about JShell, and I will see you in the next lecture. Hey folks, in this lecture we will talk about how to write a Java first program using Notepad and Command Prompt. Yep. Okay, so this is the only lecture where we will learn where we will learn to write Java code on Notepad and run it on Windows Command Prompt. Otherwise, we will write Java code using JShell and then go to the IDE. So the purpose of this lecture is to show a clear understanding of how Java runs, why Java referred to as a two-stage system language, how Java converts source code to bytecode in the form of a class file, and lastly, how the JVM interpreter executes it. To begin the demonstration, first open Notepad. Here we write a Java program that prints "Hello World" on the screen. Now we write it after the code is finished. Then we save it with the name "Hello World," which is the same as the class name, with the .java extension because it's a Java rule. And I have saved it in the directory that I have already created called java-code. Remember that the main purpose of this lecture is to learn how Java is basically run. So I will explain this code in the coming lecture. Now open Windows Command Prompt and give it the path where my Java source code file is saved. This is where I keep my Java source code. You can also see its type here. Now go to the command prompt and type javac, which stands for Java compiler, followed by the name of a Java file with the .java extension, and then press enter. The Java compiler now converts the source code into bytecode and creates a file with the .class extension. Here you can see this file and its type. Now we will open it and see what's inside. We can see that it's a bytecode that is not in a human readable form, right? Now come to the command prompt again. Call the Java interpreter to convert this bytecode into machine language. For this, type Java and then class name, that is Hello World, and press enter. Now you can see the output. Okay, I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will talk about how to write a Java program called Hello World using JShell. Hello World. Hello World is a simple program that is often used as a starting point when learning a new programming language. This program typically just displays the word Hello World on the screen. It's a basic program that allows you to test the syntax of the language and get a sense of accomplishment after completing it. Even experienced programmers can feel the same sense of accomplishment when or after writing their first Hello World program in the new language. Now, I remember back in the days when I was in college and I was taking a programming class, the first program that I wrote was about Hello World. Okay, now completing this simple task is often seen as the first step toward being able to write more complex programs. Before we start writing Java code, we must remember the rules of how to develop a Java program. Here are some basic rules to follow when writing Java code. First is Java is case sensitive, so be careful when using keywords, variables, and method names. Every statement in Java must end with a semicolon. Just remember that as well. Also, Java uses curly braces to group blocks of code. Java is an object-oriented programming language, so all the codes are organized into classes. Each class must have a unique name and should be saved in a separate file with the same name as the class, followed by the .java extension. Yep. Every Java program must have a main method. That's another one to remember, which is the entry point of the program. The main method has the following signature: public static void main parentheses string square brackets arguments. All right, the next one is that Java uses camel case for naming conventions. This means that the first letter of each word in a multi-word identifier is capitalized, except for the first word, which is all lowercase. For example, hello world is a valid identifier in Java. Okay, moving on. Java uses the double slash symbol to start a single line comment, and the forward slash asterisk and asterisk forward slash symbols to start and end a multi-line comment. Comment plays very important role in a Java or any other programming language. Again, comments help to document the code, making it easier for others or even yourself to understand what the code does. This can be especially useful if the code is being worked on by a team of developers or if it is being maintained over a long period of time. Comments can serve as a reminder of the purpose of the particular piece of code, which can be helpful if you need to make changes to the code later on. Also, comments can help to improve the readability of the code, making it easier to follow the logic of the program. These are the general rules that must be followed when writing complete and comprehensive Java code. Now come to JShell. So when we write code in JShell, it only allows us to write and run Java code snippets and expressions, which are small pieces of code. For example, in the previous lecture, we wrote a complete Java program that prints what? Remember, hello world on the screen, right? Here you can see that, and this code is written according to Java rules. Now we see this statement, system.out.print, and it's used to print content on the screen. As a result, we can see only this piece of code rather than writing the entire Java class in JShell. That's the reason we write Java code snippets in JShell. Okay, now for demonstration. Let's open the command prompt and then type JShell. Now we are in the JShell. Okay, now we write the statement system.out.print. After that, use parentheses and double quotation. Inside it, we write hello world. Using this statement, we are telling Java to print hello world on the screen. Now press the enter key. Here is the output that says hello world. Beautiful. Okay. When we use a single quotation marks around hello world instead of double quotation marks, we get the error, which is unclosed character literal, because we define a string with a single quotation mark here. That is not the Java rule. The single quotation is used for character. We will discuss character and string comparison in the upcoming lectures. Okay, this error is also displayed when we miss any quotation like this, as we can see. Now remove the last bracket and press enter. What does it mean? As you can see, the gesture prompt has changed, and it is now three dots followed by a greater than symbol. It is telling us that the J shell is ready for another line of code to be typed in. And you can keep adding new lines of code by pressing enter in between without anything actually running until you complete the set of brackets. If you want to exit without writing any lines, we can do so by pressing Control C. Now we write the bracket and press enter. And that's the output. As you can see, we don't write a semicolon at the end because in JShell, a semicolon is optional. Yes, so remember that. Okay, folks, I hope you learned something useful in this lecture, and I'll see you in the next one. In this lecture, we will discuss variables in Java. Before we get into variables, let's first define keywords. In Java, a keyword is a word that has a specific meaning in the programming language. These words are reserved, meaning they cannot be used as names for variables, methods, or other identifiers in your code. Keywords are also case sensitive, so remember that the lowercase int is different from uppercase I int or integer. There are several types of keywords in Java, including primitive data types. These include keywords like integer, double, and character, which are used to represent basic type of data in language. Then there is control statements. These include keywords like if, else, and while, which control the flow of a program's execution. Then there is modifier. These include keywords like private, public, and final, which modify the behavior or accessibility of a class, method, or variable. Then other keywords, such as this, super, and null, which serve various purposes in the language. We will discuss all of these step by step in the upcoming lecture, so don't worry about it. Okay, now let's discuss variables. What are variables? Variables are used to store data in our computers. Variables that we can declare in a program can be accessed by the names we give them, while the computer handles the task of determining where they are stored in RAM. As their name implies, variable may be modified, that is, their contents may change. We must specify the type of data we want to store in the variable before naming it. Java includes a range of data types, some of which you saw in the keyword list earlier. These are often referred to as the data types. Java also includes basic data types known as keywords. In other words, a variable is a named location in memory where a programmer can store a value of a specific data type. Variables are used to store information that can be changed or used later in the program. So it's like a container which holds the information for you which can be changed. For example, to declare an integer variable named age, you will write int or integer space age and semicolon. Once a variable is declared, you can assign a value to it using the assign operator, and that is equal sign. For example, to assign the value 25 to a variable age, you will write Java age equal 25 semicolon. Java has several primitive data types, including integers as int, floating point numbers as float, and a double characters as char, and booleans. The data types of a variable determines the kind of information it can store and the operations that can be performed on it. It's important to choose appropriate data types for your variables. Yep, you cannot use a different data for different type of variables. This can affect the performance and accuracy of your program. For example, using an integer data type to represent a decimal value may result in a loss of precision. Yep. In addition to primitive data types, Java also supports object data types, which are variables that reference objects. Objects are complex data structures that contain both data and behavior methods. We'll cover objects in more detail, of course, in the later lectures. Let's open a JShell to see how to define our first variable. To define an integer variable, let's say named age, with a value of 25 using JShell, you can use the statement integer space age space equals space 25 and close it with semicolon. Now, this will create a variable integer of type integer, with the name age and assign the value 25 to it. It's important to note that in Java, every statement must end with a semicolon. The semicolon indicates the end of a statement and is necessary for the compiler to know or correctly parse your code. All right, once you have defined a variable, you can see it in your JShell command by referencing its name. For example, you could print the value of your variable age like this: system.out.print parentheses age parentheses close and end it with semicolon. This will print the value of age variable to the console or your screen. You can also change the value of a variable by assigning a new value to it using the assignment operator. And remember the assignment operator? That is equal sign, right? So for example, to change the value of the age variable to, let's say, 30, you can use the statement age equal 30 and close it with semicolon. This will assign, of course, the value of 30 to the age variable, replacing its previous value. Now let's discuss statements. In Java, a statement is a piece of code that performs a specific action or task. A statement can be a simple statement that performs a single action or a compound statement that contains multiple statements in control structure. There are several types of statements in Java. And the first one is expression statement, declaration statements, control statement, expression statement. These are statements that contain an expression, which is a combination of variables, operators, and method calls that evaluates to a value. An expression statement is usually followed by a semicolon. Integer age equal 25 semicolon is an example of an expression statement that we already covered. Then there is declaration statements. These are the statements that declare a new variable, field, or method. A declaration statement usually specifies the data type and name of the entity being declared. There are two concepts used with variables: declaration and definition. Declaration means to create a variable with the data type but without assigning it to a value like integer age or semicolon, ended with semicolon. Remember that. Okay, here we do not assign any value to it. This is also called a declaration statement. Definition refers to assigning it a value. For example, integer age equal 25 semicolon. Then let's talk about control statement. These are the statements as we discussed earlier, like if statement, while loops, or for loops. All of this will be covered, of course, as I said, in the upcoming lecture. Then there are block statements, these statements that are enclosed in curly braces and can contain multiple statements and declaration. Now let's solve a practice question. Use system.out.print method to alter my age variable value from 30 to 65 and print the new value. By the way, that's not my age. I'm just picking that number. Okay. In the JShell, first declare an integer variable named my age and assign it the value 30. Then use the assignment operator equal to change the value of my age variable to 65. Finally, use the system.out.print method to print the value of my age to the terminal or your console. Once you execute it, it will output what? Yep, the new age, which is 65. It is important to note that the value of variable can be changed at any time during the execution of a program by assigning a new value to it using the assignment operator. This is a useful feature for variables as it allows you to store and manipulate data in your programs. Now let's use the JShell command /list to list all of the statements we have run and given values to. For this, just type /list and press enter. This will show a list of all Java statements you have executed in JShell. Now let's clear the shell screen using your Control L. Let's see another example using the arithmetic symbol plus and then storing it in a variable. In this example, my number is a variable of type integer that is being assigned the value of the result of an expression, 5 plus 10. The equal symbol is the assignment operator, which means that the value of expression on the right side of the operator is being assigned to the variable on the left side. In this case, the expression 5 plus 10 is evaluated to produce the value 15, which is then assigned to my number. After this line of code is executed, my number will have the value of what? Yes, exactly, 15. Now print the value my number using the system.out.print method. And there you have your output. Okay, folks, I hope you learned something useful in this lecture, and I'll see you in the next one. In this lecture, we will discuss variables in expressions. In the previous lecture, we covered variables, right? How data is stored in them and how they are used. Now we will work on some complex mathematical expression and store their results in variables. Here we see a literal value in expression with its results stored in a literal variable. For example, integer space literal variable, which is the name that we define for the integer, equal space parentheses 20 divided by or slash 2 parentheses, then plus sign, then parentheses again 10 plus 2 parentheses close and semicolon. Now, the expression is simple arithmetic expression in Java, combining addition and division. And as you could see, slash operator performs division while the plus operator performs addition, right? So in Java, the division operator returns a floating point result if either operand is a floating point type, but it returns an integer result if both operands are integer. Now, parentheses in the expression specifies the order in which the operations are performed. In this case, the operation inside the parentheses are evaluated first, followed by the outside. Therefore, this expression is evaluated as 10 plus 12, which is equal to 22. It's just like a math formula. Now, the result of the expression is then assigned to the literal variable, which is an integer. The value of literal variable, which is the name, will be what? 22. Yep. Now, open JShell, create a variable called literal variable with an integer data type, and assign this expression as its value. Then press enter, and you will see the result. In the next example, we create a variable named second variable. Give it a value of 50. Add this variable to literal variable, which is the variable we created earlier, and store the result in a new variable called sum. To do this, create a variable called second variable of type integer and assign it the value 50. Now use the /var command to view a list of all previously defined variables and their values. You should see all the variables listed here. Next, we add literal variables and a second variable using the plus operator and store the result in the new integer variable named what? Sum. Exactly. Then list all variables again using the /var command. You should see the updated values. Now suppose we change the value of second variable by multiplying it by 3. To do this, write second variable equal second variable asterisk or times 3 and close it with semicolon. In this example, the initial value of second variable is 50, right? The next line of code multiplies this by 3 and stores the result, which is 150, back in second variable. After this line is executed, second variable holds a value of now 150. Yep. Next, we add the new second variable value to the sum variable. To do this, write sum equals sum plus a second variable. Initially, the value of sum is 72. When second variable is added to the sum, the result 222 is stored back in sum. After this line is executed, the sum holds the value of course, 222. These example illustrates some important variation in using variable in Java, and please remember them. And I'll see you in the next one. In this lecture, we will discuss primitive data types in Java. A primitive data type is a basic type of data built into a programming language. Primitives are the simplest data types available and are used to represent basic values such as numbers and characters. In Java, there are 8 primitives data type. Let's briefly review them one by one. First one is byte, an 8-bit assigned integer. Second is short, a 16-bit assigned integer. Then int, which is the integer itself, a 32-bit assigned integer. Then there is long, a 64-bit. Then float, a single precision 32-bit floating point number. Then there is double, a double precision 64-bit floating point number. Then second to the last is char or character, a single 16-bit Unicode character. And the last one is Boolean, which represents a true or false value. Okay, now what does assigned and unsigned mean here? Very good question. All right, in Java, assigned data type can represent both positive and negative numbers. All primitive integers data types like byte, short, integer, and long are signed. Yep, meaning they can hold both positive and negative values. An unsigned data type, on the other hand, can only represent non-negative values, such as positive or zeros. Java does not have built-in unsigned data types, so you cannot use unsigned values directly in your Java programs. Let's start with byte now. In Java, byte is a primitive data type representing an 8-bit signed integer. It can store small whole numbers and is often used to save space in large arrays. It has a range of values from -128 to 127 and is also used when working with binary data, such as reading or writing files. For example, open JShell and type byte space b space equals space 100 and end it with semicolon. In this example, the variable b is for type byte and is initialized with the value 100. If we change the value from 100 to 128 and press enter, it will give an error. Why? Because the byte data type can only store the value between what? -128 and 127. Yep, so you cannot use any number larger than that. The next data type is short. In Java, short represents a 16-bit with a range of values from -32,768 to 32,767, which is a positive number, of course. It is suitable for storing small whole numbers. Now, for example, define a variable as short b equal 100 semicolon. In this example, b is of type short and is initialized with the value 100. If we change the value from 100 to, let's say, 32,768 and press enter, what will happen? Yep, it will give an error because short can only store values -32,768 to what? 32,767. The next data type is integer. In Java, integer represents a 32-bit signed integer with a range from starting like -2 billion 147 148 sorry 483 648 to again with positive 2 billion, same number but one less at the end, 647. It is the most commonly used integer or integer type in Java due to its balance between range and memory usage. For example, type integer I equal 1 million. You can also combine integer variables with others. For example, integer I1 equal 500,000. Second one, integer I2 equal 250,000. Then integer I3 will be the combination of these two integer, and that is I1 plus I2. And of course, all these statements will end with what? Semicolon. In this example, I1 and I2 are integer variables and their sum is assigned to I3 integer. It is important to note that integers should only be used for whole numbers. For fractional values, use a floating point data type such as float or double. So the next data type is long, and in Java, long is a 64-bit signed integer with a range for approximately minus a 9.22337 times 10 to the power of 18 to positive number 9.22337 times 10 to the power of 18. It is used when integer cannot hold a large enough value. For example, write long space L equal 10,000 L semicolon. The L suffix indicates that the value is a long literal. The next data type is float. In Java, float represents a single precision 32-bit floating point number with an approximate range of plus minus 3.40282347 times 10 to the power of 38. It is used to store fractional values with less precision than double, and it is commonly used in large arrays. For example, type float f equal 3.14 f, again lowercase f, and semicolon. The f suffix indicates that the value is a float literal. The next data type is double. In Java, double represents a double precision 64 floating point number with approximate range of plus or minus 1.797 times 10 to the power of 308. This is used for fractional values requiring high precision. For example, for this type double, d equal 3.14 semicolon. Double has more precision than float, but may use more memory in your system, of course, and be slower. Use float when high precision is unnecessary. The next data type is char, or in short, for character. In Java, character represents a single 64-bit Unicode character with a range from backslash U000 to slash UFFFF or 65,535 inclusive. The character is used to store individual characters such as letters, digits, and symbols. For example, type CHAR or character in short, C equal A or uppercase A and cover it or code it with single quotes, end it with semicolon. In this example, C is a character variable initialized with A, uppercase A written as a single character in the single quotes. The final data type is Boolean. In Java, Boolean represents a true or false value. It is used to represent logical operations or conditions and can only take one of two values, true or false. For example, write Boolean B equal true, semicolon. We have now discussed all 8 primitive data types in Java, right? Now let's talk about string. Why is string not primitive data type in Java? In Java, string is a class, not primitive type, which makes it a reference type rather than a value type. String represents a sequence of characters and is commonly used to handle text in Java applications. The reason string is not a primitive data type is that it is more complex, offering various methods for manipulation, such as concatenation, comparison, and substring searching. For example, create a string variable with string lowercase s equal hello world exclamation and semicolon. And by the way, put hello world in double quotes. The value of a string is written as a sequence of characters enclosed in double quotes. You can also use string class in combination with other data types. For example, string s1 equal hello, string s2 equal world, string s3 equal s1 plus s2. And by the way, all of these statements end with semicolon and put double quotes around them. In This example, S1 and S2 are string variables and their concatenation is assigned to S3. Concatenation meaning when you read that variable, the plus operator is overloaded for string objects and is used to concatenate strings. So that's it, folks. I hope you found this lecture useful. And if you have any questions about any of these strings or these data types, please let me know. I'll see you in the next lecture. Hey, folks. In this lecture, we will discuss examples of primitive data types. In the previous lecture, we covered primitive types and their role in Java, right? So now we will look at some practice exercises. Let's start with the byte data type. In Java, byte data type is an 8-bit signed integer and can hold values from -128 to 127, right? I'm sure you remember that. Here are some examples of how you can combine the byte data type with other primitive data types in Java. So byte plus byte. You can add two byte value together using plus operator. The result will be of type integer. Now, for example, to add two byte value in Java, create two variables, x and y. Assign them values and store their sum in a variable of type integer. So byte x equal 10 semicolon. Then the next line will be byte y equal 10 semicolon. Then integer sum equal x plus y semicolon. And the last line will be the output, of course, system.out.println a line parentheses sum parentheses close semicolon. In this example, both x and y are of type byte. The plus operator is used to add them, and the result is stored in where? Sum, which is of type integer. When you add 2 bytes values, the result is always of type integer. Why is that? In Java, when you perform arithmetic operations between two values, the result of the data type that can hold the largest range of values. This process is called widening primitive conversion. Since integer has a larger range than byte, the result is stored as an integer to prevent any loss of precision. Here is a table showing the range of values for each primitive integer data type in Java, demonstrating that integer has a much larger range than byte and can hold the sum of two byte values without precision loss. You can also add a byte value to a short value using the plus operator. The result will also be type integer. For example, create two variables x as a byte and y as a short and add them together. Byte x equal 10 semicolon, short y equal 20 semicolon, integer sum equals x plus y semicolon, then system.out.println or line parentheses sum parentheses close and semicolon. In this example, x is of the type byte, y is of the type short. When added, the result is stored in sum, which is of the type integer. Again, the result is of type integer because short cannot hold the result of the operation. Similarly, adding byte to an integer produces an integer result because integer has a larger range than byte. Adding byte to a long produces a long result, as long has a larger range than byte. Adding integer to a float produces a float result, as float has a larger range than integer. And then adding two double values produces what? Double result. Yep. To check the range of any data type in Java, use min underscore value, all uppercase, and min max underscore value, all uppercase fields. For example, to check the range of the short data type, use the following Java code. System.out.print parentheses double quote minimum or min range of short is colon double quote plus operator short dot min underscore value uppercase both of them plus double quote and max range of short is colon double quote plus short dot max underscore value will be uppercase, close it with parentheses, and end it with semicolon. This code prints the minimum and maximum value that a short variable can hold. The short class is a wrapper class for the short primitive data type and provides several static fields, including min underscore value and max underscore value. To access these limits, we will discuss wrapper classes in future lectures. When this code is executed, it will print min range of short is minus 32,768 and max range of short is 32,767. So that's the whole purpose of showing you of min and max range. I hope you found this lecture useful and I'll see you in the next one. In this lecture, we will discuss the concept of typecasting in Java. Casting is the process of converting one data type to another. There are two types of casting in Java: widening and narrowing casting. Let's talk about widening casting. It converts a smaller data type to a larger data type, also known as implicit casting. For example, converting an integer to a double. Now, if you remember in the previous lecture, we saw an example when adding byte and short, right? Where values and storing the result in an integer, as integer has a larger range than short and byte. To see an example, open JShell and create two variables, one with an integer data type and the other one with double data type. Here's how to declare both variables in a single line by ending each statement with a semicolon, which indicates the end of statement in Java. I'm sure you know that by now. When a variable is declared without a value, Java assigns it a default value. For example, 0 for integer double and float, and /u0000 for character. For example, integer I equal 123 semicolon, then double D equal I semicolon. Now in this case, the value of I is assigned to D without explicit casting. Widening casting is allowed in Java because double has a larger range than integer, allowing the value to be safely converted without a loss or data loss. Let's look at another example with short and integer. Short s equal 100 semicolon. The next line is integer j equal s semicolon. Here the value of s is assigned to j using widening casting, since integer has a larger range than short. This conversion is safe. Now let's talk about converting character into integer. Character C equal single quote A, which is uppercase, single quote, and semicolon. Then integer K equals C semicolon. In this example, the value of C, which is uppercase A, is assigned to K using widening casting. Instead of a character A, the variable K stores the ASCII value of A, which is 65. Java stores characters as a 16-bit unsigned integer, where each character is assigned a unique ASCII value. Now let's talk about what is ASCII, if you don't know, of course. ASCII, which is a short for American Standard Code for Information Interchange. And it is a character encoding structure that represents characters using 7-bit integers. Originally developed by teletypes and based on the English alphabet. It includes codes for uppercase and lowercase letters, numbers, punctuation marks, and a few special characters. ASCII codes can be used in Java to represent characters in the character data type. Now, to convert an ASCII code to a character, let's type integer ASCII code equals 65 semicolon. Then character C equal character, or in short, CHAR, put it in parentheses, space ASCII code semicolon. Here, ASCII code, which is a variable, is a cast to character and stored in C, resulting in C holding the character A. Note that ASCII is limited to certain characters, while Unicode, a more modern encoding standard, supports a broader range of characters. All right, folks, now let's talk about narrowing casting. Now, this one converts a larger data type to a smaller one, also known as explicit casting. For example, converting a double to an integer. It's important to note that narrowing casting can result in a data loss if the value being converted is not within the range of the target data type. Here's another example with float and integer. Float f equal 3.14 f semicolon. Integer a equal parentheses integer parentheses close space lowercase f semicolon. In this example, the decimal portion of s is truncated when cast to integer, resulting in a, which is a variable, holding the value 3. Some important notes. Java does not automatically check if a value fits within the range of a variable. It's the programmer's responsibility. Yep, it's your responsibility to ensure value assigned to the variable are within their defined ranges. For example, if an integer value has a range of, let's say, minus 2 billion 147 483 648 to positive number 2 billion 147 283 647, you must ensure that the value falls within this range. Otherwise, an out of range assignment will cause an error. Now, I'm sure there should be a way to control these numbers, and you need to find that way yourself. So, Java is a statistically typed language, meaning that the data type of a variable must be known at compile time. This allows the compiler to catch errors, such as out-of-range assignments, before the code is executed. However, typecasting allows you to convert a value to a different data type, even if the value may be out of range for the target type. While this can be useful in some situations, it can lead to data loss if the converted value exceeds the range of the target data type. Always use typecasting carefully to avoid unintended consequences. All right, folks, I'll see you in the next lecture. In this video, we will discuss the difference between the float and double primitive data types in detail. We briefly introduced both in the previous lecture, covering their ranges and definition. So let's start with a float data type. In Java, float is a single precision 32-bit IEEE 754 floating point data type. It represents fractional values and is used when the higher precision of double is not needed. Now, what is IEEE 754? IEEE 754 is a standard for representing floating point numbers in computers. It defines how to represent number with fractional components, such as 3.14 or zero point 0.1, and specifies operation like additions and multiplication for these numbers. A 32-bit floating point number consists of 32 binary digits with a single precision format that includes a 1 sign bit, 8 exponent bit, and 23 mantissa fractional bits. And let's discuss key points for float values. Float uses fewer bits than double. It requires less memory. It helps precision, which can cause rounding errors in calculations. Float is generally faster to process than double on most systems due to its smaller memory footprint. Examples with expressions and error handling is something that we'll discuss now. When using expressions with float, remember to include the lowercase f suffix. Otherwise, the value is treated as double by default, leading to a potential error due to incomplete types. All right, let's look at the example. Float num equal 4.0 lowercase f slash 2.0 f plus 3.0 f asterisk or times 5.0 f and semicolon. And then we could put it slash slash result colon 17.0, which is a comment. Now let's look at double data type. In Java, double is a 64 double precision floating point data type, typically used when higher precision is required. Double precision means that double has a 1 sign bit, 11 exponent bits, and 52 mantissa bits. Now let's look at key points for double values. Double uses 64 bits, offering a higher range and greater precision than float. It takes up more memory and may be slower to process, especially when many calculations are involved. Double is commonly used for calculations that require a high degree of precision, like scientific computations. Now let's summarize float versus double. Precision, double has higher precision than float. Memory usage, float uses less memory, 32 bits, than double, 64-bit. Now let's look at the performance. Float is generally faster, while double is slower, but more precise. All right, in the final section of this lecture, we will compare float and double data types. Now, take a look at their differences. The first column will have the characteristics. The second column will actually have the discussion or characteristics of float. And the third column will have, or we'll talk about, double. All right, let's start with the first column, which is we'll talk about the memory. So for float, occupies 4 bytes of memory. Double occupies 8 bytes of memory. All right, moving on the next one, which is accuracy. Float accuracy is low while double accuracy is high. Then let's talk about precision. Float follows single precision while double follows double precision. Yep. Okay, let's look at the keyword used. The float keyword is used to define a float number. The double keyword is used to define a double precision number. Let's talk about the default data type. Java does not use it as the default floating point number. Double is the default data type for floating point numbers. All right, moving on to data loss. There will be no data loss if we convert float to double. And when we're talking about double, there will be data loss if we convert double to float. All right, let's look at the uses. Float should be used where less accuracy is required and storage is a constraint. Now, double is used where more accuracy is required and also requires more precision. All right, the last one is suffix. Float uses uppercase f or lowercase f as a suffix. It is mandatory to add a suffix if you are declaring a float variable. Now let's look at the double. Double uses a lowercase d or uppercase d as a suffix. It is optional to add a suffix if you are declaring a double variable. All right, that's it, folks, and I will see you in the next one. In this lecture, we will use scientific notation with float and double data types. Now, what is scientific notation? Scientific notation is a way to represent very large or very small numbers in a compact form, commonly used in mathematics, science, and engineering. In scientific notation, a number is written as a base number multiplied by the power of 10. The base number is always between 1 and 10 inclusive, and the power of 10 is represented as an exponent. For example, The number 1, 2, 3, 4, 5, 6, 7, 8, 9 can be written in scientific notation as 1.2345678 times 10 to the power of 8. Here the base number is 1.2345678 and the exponent 8 indicates that the base should be multiplied by 10 raised to the power of 8. The scientific notation is particularly useful for expressing very large or very small values. For instance, the distance from the Earth to the Sun is about 93 million miles, which can be written in scientific notation as 9.3 times 10 to the power of 7 miles. In programming, scientific notation is used to represent floating point numbers in languages like Java. Now, let's look at some examples. Open JShell to try these out. All right, so let's go for the first example in which storing large numbers in scientific notation. If we store a large number in a double variable, Java automatically displays it in the scientific notation. For instance, double num equal 2.5 E10 semicolon. Here, 2.5 E10 is a numeric in scientific notation where 2.5 is the mantissa and the 10 is the exponent. This represents 2.5 times 10 to the power of 10. All right, let's look at example number 2. Multiplying scientific notation numbers. In this example, we will multiply two numbers written in scientific notation. And the code will be double num1 equal 4.56 E10 times 5.89 E9 semicolon. Now here 4.56 E10 and 5.89 E9 are scientific notation numbers, where the mantissa are 4.56 and 5.89, and the exponents are 10 and 9 respectively. The result of 4.56 times to the 10th power of 10 times 5.89 times the power of 9 is approximately 2.68584E20. All right, let's moving on to example 3 in which we'll do the calculation, which is calculating the circumference of a circle. All right, the code will be double pi equal 3.14, then double radius equal 5,000, then double circumference equal 2 times pi times radius. Here we declare pi as 3.14, a common approximation, and radius as 5,000. The circumference is calculated using the formula 2 times pi times r, where the r is the radius. The result is then printed to the console. Excellent. All right, let's look at example 4, where we will do the converting Celsius to Fahrenheit. All right, and that formula is Fahrenheit equals parentheses 9.0 divided by 5.0 times Celsius and parentheses close plus 32. All right, let's put that in the code. Double Celsius equals 37.5. Double Fahrenheit equals parentheses 9.0 divided by 5.0 Celsius plus 32. Then to print out system.out.print line parentheses Fahrenheit parentheses close. In this example, we assign 37.5 to Celsius and use the formula to calculate Fahrenheit. The result is printed, showing the temperature in Fahrenheit as the double value. Excellent, folks. I hope this lecture was very useful for you, and I'll see you in the next one. In this lecture, we will compare the character, in short char, and string data types in Java. All right, let's start with character data types. The character data types represents a single 16-bit Unicode character in Java, which can include letters, digits, punctuation marks, and other symbols. Single quotes are used to denote a character literal, allowing a range of 65,536 or to the power of 16 unique characters, including most of the world's languages, special characters, and symbols. To see an example, open JShell. Here we create a character variable ch and initialize it with a value. All right. So let's start writing with char character and the variable ch equal single quote uppercase A single quote close semicolon. And then we'll print it out with the code system.out.println parentheses ch parentheses close and semicolon. This code prints out the value of ch to the console. Remember, single quotes denote a character literal, while double quotes are used for string literals, which represent sequence of characters. All right, then we have the uses of characters in Java. The character data type is useful for storing and manipulating individual characters such as letters, digits, and punctuation. It can also represent special characters using escape sequences like /n for a new line or \t for a tab. Additionally, character can be used in algorithms that operates on individual characters, such as sorting. All right, let's talk about Unicode in characters. Java supports Unicode for character values, allowing it to represent a wide range of characters from different languages and scripts. Unicode assigns a unique numeric value to each character, making it compatible across platforms. To use a Unicode character in Java, write \u followed by a 4-digit hexadecimal code. For example, to represent the capital letter C, Unicode 0043. All right, let's look at the code. Character Unicode equal \u0043, and of course we'll surround it with single quote and end it with semicolon. Then and then we could put a comment as output colon C. All right, let's look at the other part, which is assuming integer values to character. Since character includes all ASCII characters, the first 128 characters in the Unicode set, it is possible to assign an integer value corresponding to an ASCII code. For example, character ASCII equal 65. Here 65 represents A in the ASCII code or ASCII table. All right, let's talk about string data type. A string is a sequence of characters and is represented as a series of characters in double quotes. Now, unlike character, string is not a primitive data type in Java. It is a class in Java library and is considered a non-primitive data type. We use string to represent and manipulate text data in Java. Now, let's look at an example. String company equal Java programming with, for example, Nextware. Now, this code stores and prints the string value Java programming with Nextware. Let's look at some more examples with string. String s1 equal hello, string s2 equal world, string s3 equal program. Now please note every word after the equal sign has to be within double quote and of course end with semicolon. Now let's print that out with system.out.println parentheses s1 parentheses close. Again, system.out.println s2 within parentheses. Then the third line, system.out.println and s3. This code declares and initializes three strings variable, then prints each to the terminal or your console. All right, let's talk about concatenating strings with other data types. The plus operator can be used to concatenate string values with other data types. For example, integer num1 equal 100, and then integer num2 equal 200, and then we could add another integer with the variable sum, then equal it with the variable num1 plus the second variable num2. And the last line will be system.out.println parentheses double quote sum is colon and double quote plus the sum, which is the variable, and then close it with parentheses and semicolon. Here, the plus operator concatenates, or meaning reads the string sum is with the default value of sum displaying the output as sum is 300 because it's adding 100 plus 200. All right, let's look at the summary of characters versus string. And we will look at the summary in a way starting with data type. Character is a primitive data type, while string is non-primitive. Then let's look at content. Character stores a single character, whereas string stores a sequence of characters. And the last one in the summary is about syntax. Character uses single quotes, like single quote A, single quote closed, while string uses double quotes, like double quote hello, double quote. So that's it, folks. I hope you learned something useful, and I'll see you in the next one. In this lecture, we will summarize the primitive data types which we covered in the previous lectures. By now, you should be familiar with all the Java primitive types. And once again, those are byte, short, integer, long, float, double, character, and boolean. Each type has a specific size and purpose. Now, if you feel like that you have a good grip on these data types, then simply skip this entire lecture and go to the next one. But if you want to go through this with me to go over the summary again and refresh your memory, then let's stick around. And now we'll start with byte. Byte is an 8-bit data type that stores signed integer from minus 128 to 127. It's often used for compact data storage and binary data processing, such as in files or network streams. Then there is short, which occupies 16 bits and stores signed integers from minus 32,768 to 32,767. It is useful for handling slightly larger values than byte and is also common in binary data handling. Then we have integer. Integer is a 32-bit data type used for signed integers within the range of minus 2,147,483,468 to the positive value of this and one less. Okay, it is commonly used integer type in Java and is widely used in calculations and as a standard memory unit. Then we have long, which occupies 64 bits, storing signed integer from minus 9223 372 854 775 808 to that same long number with the one less. It is useful for very large integer values that exceeds the integer range. Then let's talk about float. Float is a 32-bit data type for single precision floating point numbers, ideal for approximate values with fractional parts such as measurement, where precision is less critical. Then double, which is a 64-bit data type for double precision floating point numbers. It provides higher precision than float, making it suitable for scientific calculation and cases where accuracy is essential. Then character, which is a 64-bit type that stores in a single Unicode character, representing letters, digits, punctuation, and symbols from various languages, is used to handle individual characters in Java. Then Boolean, which is a 1-bit type used in store true or false values, essential for controlling programs' flow in conditional statements and loops. And the last one is string is a non-primitive type that represents a sequence of characters. Strings are immutable in Java, which means their value cannot change once created. Java provides numerous methods for string manipulation, such as concatenation. searching, and formatting. All right, folks, this is the summary of primitive data types, and I'm sure you have a very good understanding of this, even going through or refreshing what we learned in this entire section. In this lecture, we will discuss operators in Java. An operator is a symbol that performs a specific operation on one, two, or three operands and produces a result. There are many operators in Java. For example, consider the statement D equal A plus B times C. In this statement, D is a variable and A, B, and C are also variables or values. The statement uses this assignment operator, which is equal to assign the value of the expression A plus B times C to the variable D. First, B times C is calculated as the multiplication operator times has higher precedence than the addition operator plus, right? I'm sure you remember that from your math class. Then A plus parentheses B times C parentheses is calculated. Finally, the result of expression is assigned to the variable D. So the value of D will be the result of A plus parenthesis B times C. All right, here we can see three operators, equal, plus, and multiplication, and fourth operands A, B, C, and D. Now let's clarify the term operands. In Java, an operand is the quantity on which an operation is performed. An operator performs an operation on one or more operands to produce a result. For example, in the expression 5 plus 2, comma 5 and 2 are operands, and plus is the operator. The operation performed is addition, and the result is 7. In this case, 5 and 2 are literal values, but operands can also be variables. For example, in the expression x plus y, x and y are variables that represents values, and the plus operator performs addition on these values. Operands can be of various types, such as integers, floating point numbers, characters, and strings, depending on the operation, of course. Now, for example, in the expression hello plus world, the operands are strings, and the plus operator concatenates or joins them to produce the result as hello world. Now, let's define expression. In Java, an expression is a combination of variables, literals, and operators that represent a single value or operation. Expressions are used to perform operations and specify value in Java programs. An expression can be a simple value, such as a literal or a variable, or it can be more complex combination of values and operators. For example, the expression 15 plus 12 represents the addition of what? 15 and 12, right? And which will result in what? 27, of course. If you do the math, of course. Expressions are often used in Java statements, such as assignment statements and control statements. For example, in the assignment statement, let's say x equal 15 plus 12. The expression 15 plus 12 is evaluated and the result is assigned to the variable x or container x, of course. Now let's open JShell and create a variable with a value as an integer sum equal 6 plus 7. I'm sure by now you're very familiar with starting with integer and sum is in this case is the variable. The double slash notation slash slash indicates a start of a single line comment. Anything after the double slash on the same line is considered a comment and can be ignored by a compiler. Just like in C sharp, you have a hashtag as a comment. In Java, you have forward slash as a comment. All right, here the comment slash slash 6 plus 7 equal 13 is added to explain the purpose of the code and of course does not affect the program's execution. So remember that. In this code, integer is a Java keyword that indicates that an integer variable is being declared. Sum is the variable name and equal is the assignment operator that assigns a value to the variable. 6 plus 7 is the expression being evaluated and assigned to sum. Here 6 and 7 are operands, integer literals, and plus is the operator that performs addition. The result 13 is then assigned to the variable sum using the assignment operator equal. After this statement is executed, sum will have a value of what? 13. Yes. All right. Now let's discuss comments in Java. As we used them in the previous example, the comment is a piece of text in the source code that is not executed as part of program. Comments are used to add explanatory notes to the code and document its purpose and functionality. In Java, comments are ignored by the compiler and are not included in the final execution version of the program. They are intended for human readers and help make the code easier to understand. There are two types of comments in Java: single line comments and multi-line comments. Single line comments start with slash slash and continue until the end of the line. Multi-line comment starts with slash asterisk and end with asterisk slash, spanning multiple lines if needed. All right, for example, a variable x of type integer initialized with the value 10. Lines starting with slash slash are comments and are ignored by the compilers used to add explanation to the code. Slash slash declare a variable. This line is a comment explaining the purpose of the line of code. A slash asterisk opens a multi-line comment. Everything between the opening slash asterisk and closing asterisk slash is considered a comment and ignored by the compiler. Now let's return to operator with the example. We have two variables, first value and second value, declared and initialized with the character A and B, respectively. These are of type character, representing a single character in Java. The line system.out.print parentheses first value plus second value parentheses closed prints the sum of first value and second value. Since first value and second value are of type character, their sum is a result of adding their ASCII value. For example, ASCII value of A is 65 and that of B is 66. Thus, first value plus second value evaluates to 65 plus 66, which is 131, and prints 131 to the console. Remember that characters are not concatenated with the plus operator unless they are converted to a string. For example, using system.out.print parentheses double quote plus first value plus second value parentheses would print AB because the empty string converts the entire expression to a string. Now let's explore the subtraction operator. In Java, the subtraction operator, which is minus, is used to subtract numbers. It can be used with numeric operands like integer and double. For example, we have three variables, x and y, and z initialized as follows. X is 10, y is 5, and z is assigned. X minus y. Printing z will output 5. Now let's look at the multiplication operator, which is asterisk, which performs multiplication. For example, integer x equal 10, integer y equal 5, and integer z is x times y. Assign z the value of 10 times 5, which is 50. Another example is integer r equal 10, integer d equal r times r times r, which multiplies r by itself 3 times, resulting in 1000. Now, forward slash or double forward slash d is assign the value of 10 times 10 times 10, which is 1000. This line is a comment explaining the purpose of the previous code. Finally, let's look at the modulus operator, which is a percent sign, which returns the remainder of a division. For example, if integer x equal 10, integer y equal 3, and integer z equals x percentage y, the result of 10% 3 is 1, as 3 does not divide 10 completely, leaving the remainder of 1. All right, that's it, folks, and I will see you in the next lecture. In this lecture, we will talk about arithmetic operators in Java. In the previous lecture, we introduced different type of operators in Java. Let's briefly go over these operators before focusing on arithmetic operators in detail. So, arithmetic operators used for basic arithmetic operation like addition, subtraction, multiplication, division, increment, and decrement. Then there is relational operators. Compare two values, determining relationship like greater than, less than, or equal. The next one is logical operators, which combines a relational expression to evaluate overall truth values. Then there is assignment operators, which assign values to variables. Then the fifth one is conditional operators, which executes action based on a condition's truth value. The next one is bitwise operators, which performs a bit level operators on integer values. Then there is ternary operator, which is a conditional operator that returns one value if true and another if false. And the last one is instance of operator, which checks if an object is an instance of a specific class or interface. Now let's go into the detail about arithmetic operators. All right, in the previous example, we explored addition, subtraction, and module operators, right? Now we will dive deeper into examples in JShell. So let's start with working with curly braces in JShell. Curly braces are used to group statements as a single block, allowing multiple statements to execute as one unit. For example, let's use curly braces to demonstrate basic arithmetic operations in a JShell. And here we have example 1 for addition. We'll start with curly braces. And then we have a code inside of it, like integer first variable. Then coming down to second line, integer second variable equal 3. Then third line, integer sum equal first variable plus second variable. And the last line will output with system.out.println. And then parentheses, double quote, result is colon, then double quote, plus sum, parentheses, and then semicolon. All right, so that was the example of addition. Now let's look at the example 2 with increment operator. Let's see how the increment operator works. In the increment operator, which is plus plus, increases a variable's value by 1. Java has two types of increment operators. The first one is postfix, which is x plus plus, and then prefix, which is plus plus x. Now let's look at postfix increment, which increments the value after the expression is evaluated. So for that, the code will be integer x equal 5, then integer y equal x plus plus. And then, of course, you could put a comment there. Then let's talk about prefix increment. Increments the value before the expression is evaluated. And the code will look like integer x equal 5, and then integer y equal plus plus x, followed by any comments. All right, another way to increment a value is with the compound assignment operator, which is plus equal. For example, in the code, we'll do integer x equal 10, then integer y equal 5. And then the third line will have x plus equal y. All right. Then examples using compound assignment with increment. And then we'll start with the curly braces. Integer my number equal 10. Then my number plus equal 1. Then system.out.println parentheses double quote result is colon double quote plus my number parentheses and semicolon. And then close it with curly braces. All right, then let's talk about decrement operator. All right, the decrement operator, which is minus minus, decreases the variable values by 1. It also has a postfix and prefix forms, just like increment operator. All right, let's talk postfix decrement, which is x minus minus, decrements after evaluation. And the code will look something like integer x equal 5, and then integer y equal x minus minus. Then in prefix decrement, which is minus minus x, which decrements before evaluation. And the code will look something like integer x equal 5, and then second line integer y equal minus minus x. And then, of course, every line will end with semicolon, and you could put double forward slash for comments. All right, let's look at the example using compound assignment with decrement. And the code starts with curly braces, and inside the code we'll do with integer my number, which is a variable, equal 10. Then my number minus equal 1. And then the output will be system.out.print parentheses double quote result is colon double quote plus my number parentheses and end with semicolon. And then of course end the whole code with curly braces. All right, now it's time to talk about multiplication and division with compound assignment. Let's try the compound assignment operator, which is asterisk or multiplication equal for multiplication and slash equal for division. And let's start with the example of multiplication. And the code will start with integer x equal 10, integer y equal 5, then x times equal y. Then system.out.print line parentheses result is colon parentheses plus x parentheses close. All right, that was example of multiplication. Now let's look at the example of division. Integer x equal 10, second line integer y equal 5, third line x slash equal y. And then output would be system.out.print line parentheses double quote result is colon double quote plus x parentheses close. Excellent. All right, now let's look at example with decimal numbers. The compound assignment operator can also be used with decimal values. Yep. And for that, let's start with our code again with curly braces. And then we will have double with variable name point number equal 5.5. Then that variable point number plus equal 4.5. And to print that, we'll use system.out.print parentheses double quote result is colon double quote plus, and then here is your variable which you defined earlier, which is point number. Then close this with parentheses. Of course, every line ends with semicolon, and this whole code will end with curly braces. That's it, folks. I hope you found this lecture helpful, and I'll see you in the next one. In this lecture, we will learn the concept of an IDE. In the previous section, we covered the basics of Java using a simple tool called JShell. So now we are ready to move on to learning advanced Java concepts and writing complete comprehensive Java code. To achieve this, we will use an IDE. So what is an IDE and why do we use it? All right, IDE is an integrated development environment. In short, IDE is a software application that provides a comprehensive set of tools for software development. IDEs typically include a code editor, a compiler or interpreter, and a debugger. They also offer additional features such as source code management systems, version control systems, and build automation tools. The main advantage of using an IDE is that it provides a single, unified interface for all tasks involved in software development. Now, this saves time and effort as developers do not need to switch between different tools or environments for various stages of the development process. IDE offers helpful features such as code completion, syntax highlighting, and error checking, making it easier to write, debug, and maintain code efficiently. There are many different IDEs available for different programming languages and platforms. Some popular IDE for Java include Eclipse, NetBeans, and IntelliJ IDEA. Now, we will be using IntelliJ IDEA for a variety of reasons in this course. Intelligent J IDEA is a popular Java integrated development environment developed by JetBrains. It is widely used by Java developers due to its extensive features and functionality. Now let's go over some of the benefits Intelligent J IDEA has to offer. Now the first one is intelligent code completion. This feature suggests variable names, methods, and classes as you type, helping you write code more quickly and accurately. The next one is advanced refactoring tools. These tools enable you to safely and easily restructure your code. Then a built-in debugger. IntelliJ IDEA includes a built-in debugger that allows you to step through your code, set breakpoints, and inspect variables. The next one is integrated version control, which allows you to integrate with version control systems such as Git and Mercurial, making it easy to manage your code base and collaborate with others. The next one is customizable user interface. Now, this feature offers a customizable user interface, allowing you to tailor it to your specific needs and preferences. The next one is great support for popular frameworks and libraries. IntelliJ IDEA provides excellent support for popular Java frameworks and libraries such as Spring, Hibernate, and Android. All right, and the last one, not the least, is regular updates and improvements. JetBrains actively develops and improves IntelliJ IDEA, releasing new versions regularly. All right, to summarize, let's compare the IDE to a text editor. An IDE typically includes a code editor, compiler, and interpreter and debugger, right? Providing a comprehensive set of tools for full software development lifecycle. Now, in contrast, a text editor is a simple program for creating and editing plain text files and does not include all these IntelliJ IDEA or IDE cool features. All right, next one is IDE offers features such as code completion, which we covered, syntax highlighting, error checking, while text editor may have only basic features like syntax highlighting and code folding. All right, another one, IDE may include tools for source code management, version control, and build automation. Now, whereas a text editor lacks many of these tools and features. Then an IDE is usually more feature rich and may have a steeper learning curve, while an editor is a simpler and easier tool to use. All right, that's about it. I hope this explains why we will be using an IDE rather than a text editor. I'll see you in the next one. In this lecture, we will discuss installing IntelliJ IDEA on Windows. This lecture is specifically for Windows users. Linux users should refer to the separate lecture on installing IntelliJ IDEA for Linux. Now let's download and install the IntelliJ IDEA so we can write our Java programs. Now for that, I want you to go open your browser and go to jetbrains.com. Click on the Developers Tools tab at the top and then click on IntelliJ IDEA. Then click the download button. Ensure that Windows is selected and choose the Community Edition of IntelliJ IDEA to download. The Ultimate Edition is a paid version and it is not necessary for this course. All right, once the .exe file begins to download, wait for it to complete. By the way, this is the executable file. After the download is complete, double-click the .exe file to open it and begin the installation process. When the installation wizard appears, click Next to accept the terms and license agreement. Then choose the destination folder where you want to install IntelliJ IDEA, then click Next. Then select the components you want to install. Make sure to select IntelliJ IDEA Community Edition and then click Next. All right, then you click click Install to begin the installation process. This may take a few minutes, of course. Now, once the installation is complete, then you can click on Finish. IntelliJ IDEA is now successfully installed on your Windows system. In the upcoming lectures, we will explore its features or functionalities and start working with it. I hope you found this lecture helpful when it comes to downloading and installing IntelliJ IDEA, which is an IDE tool. I'll see you in the next lecture. In this lecture, we will cover the installation of IntelliJ IDEA on CentOS Linux. Let's get started. I'm currently setting up a virtual machine in VirtualBox on Windows with CentOS Linux as the operating system. I'm also connecting to CentOS using PuTTY, which is available for Windows. Please note that PuTTY allows you to connect to your Linux machine from a Windows operating system. Okay, so first thing we need to do is log in as root on our Linux machine and then enter root password to proceed. To download IntelliJ IDEA from a CentOS terminal, we first need to enable snaps on CentOS. So let's run the command sudo yum install apple epel-release. Now please note you do not need sudo command if you are logged in as root. Also, if you're using the newer version of CentOS, you could use dnf command instead of the yum command. Nevertheless, let's move on. So this command installs the extra packages for Enterprise Linux, EPEL, which is often referred or pronounced as Apple repository. It may take a few minutes to complete the installation. Next, install the systemd unit that manages the main snap communication socket. All right, to do that, run the command sudo yum install snapd. Again, it may take some time to install. Next, let's enable and start the snapd.socket service by running the command sudo systemctl enable --now snapd.socket. After that, to enable classic snaps support, run the command sudo ln, which is the command for link, then -s option, and /var/lib snapd/snap and then /snap. If you have already enabled snaps on Linux, you can directly download IntelliJ IDEA from the Linux terminal using that command. All right, and that is sudo snap install IntelliJ-IDEA-community space dash dash classic. If you encounter an error message that says too early for operation, device not yet seeded, or device model not acknowledged, simply run the command again. The installation may take some time to complete. All right, all done. So that's it, folks. I hope you found this lecture useful. I'll see you in the next lecture. In this lecture, we will learn the functionality of IntelliJ IDEA and begin writing some Java code. This lecture is beneficial whether you are using Windows or Linux. To get started, we must first associate the JDK Java Development Kit. I have installed IntelliJ IDEA with Oracle's JDK 17 to make them compatible. Essentially, this means informing IntelliJ of the presence or absence of a JDK on the system. In general, the JDK functions as a software development kit and provides all the resources we need to develop programs. The JDK includes tools necessary for a computer to recognize and run our Java code. It also contains a debugger, which we will explore in more detail after developing a program to use it. If you haven't started IntelliJ IDEA already, please go ahead and do so. The first step is to acknowledge the user agreement by checking the box, though it is recommended to read it first. The next step involves the data sharing options. Once IntelliJ IDEA starts, you will see a welcome screen with options to create a new project, open an existing project, or get a project from VCS, which is short for version control system. All right, new project. This option allows you to create a new project from scratch. You can choose the type of project, such as Java or Kotlin, and configure various settings. Then open this option allows you to open an existing project that you have already created or downloaded. And then the third option is get from VCS. This option allows you to check out a project from version control systems such as Git or Subversion. You will need to provide the repository URL and the necessary authentication information to clone the project. All right, let's start by selecting new project. You will see a JDK detection pop up in IntelliJ, looking for the JDK installed earlier. If you look closely, the version number should match the JDK you previously downloaded. In my case, it is version 17.0.5. If you haven't installed the JDK, please refer to the relevant lecture on JDK installation before proceeding. The next step is to verify that Java and IntelliJ are selected and that the correct JDK is displayed. This is the screen you will use frequently when starting a new project. Once you are back on the main IntelliJ screen, click the Cancel button. This time, click Customize to adjust a few things. Then click Settings to change the theme. The document background is a popular choice for programming as it is gentle on the eyes, of course. However, I will select IntelliJ Lite as the white background can be more comfortable for us. Remember, you can return to this menu to change the setting at any time. Okay, next go to Editor and then General. Here we can simplify things for beginners Java programmers. I will enable Auto Import. This feature automatically adds missing import statements when you use a symbol. For example, a class or method that cannot be resolved. It helps avoid manually adding import statements. The auto import feature is enabled by default, but you can disable it if you prefer to add imports manually. Check both add unambiguous imports on the fly and optimize imports on the fly. Add unambiguous imports on the fly automatically adds import statements for symbols used in your code, while optimize imports on the fly removes unnecessary imports and reorders the remaining ones to keep your code clean and organized. Next, we will move on to the code folding. Since IntelliJ IDEA is a professional editor designed to simplify coding for both beginners and experts, some default parameters may hide parts of the source code. To view all the code, deselect options such as imports, file headers, one-line methods, closures, and generic constructor and method parameters. This ensures IntelliJ displays as much as code possible. All right, now go to appearance and ensures that show line numbers is checked. With the settings complete, click OK. To return to projects page, simply click projects. Here, any completed projects will be listed, making it easier to access them later. Since we have no projects at the moment, let's create a new one. Click New Project. Next, provide IntelliJ with the information about the project you wish to create, including the project name, location, and language. The JDK set to Java should automatically default to the version we defined earlier. Enter the project name, such as, for example, my first program. Avoid using spaces in the name, as it can cause issues with file path. To differentiate terms, you can capitalize the first letter of each word. For example, my first program, where my is the uppercase, F and P are the uppercase, as a style known as Pascal case. Pascal case or upper camel case capitalize the first letter of each word, including the first word. For example, upper camel case. Lower camel case, often referred to simply as camel case, capitalizes the first letter of each subsequent word, while the first word remains the lower case. For example, lower with L lower, camel case. Following naming convention like these improves code readability and clarity. That's why it is important that you understand these terms and these cases. Next, specify the project location. IntelliJ uses a default location, which is tilde backslash idea projects on Windows and Linux systems. But you can choose a different folder if you prefer. The tilde symbol represents your home directory, and idea projects is the default directory for IntelliJ projects. For example, on Linux, it might be /home/john/idea projects. And on Windows, it might be C drive or C colon backslash users backslash John backslash idea projects. You can change this location if you want to. There is an option called sample code. If selected, IntelliJ will include sample files and code to help you get started. This can be useful for understanding IntelliJ's features and code structure. However, if you want to start with a blank project or use your own files, uncheck this option. We will uncheck it and press create. Your new project will appear on the left-hand side. Click the little arrow icon to open or close the folder. Below it, you will see a .idea folder which contains IntelliJ configuration files. You can ignore these for now. To create your first Java class, right-click on the src source folder, select New, then click Java class. Enter Hello World as the class name and press Enter. IntelliJ generates some basic code for you. The editor window will display the generated code with Hello World labeled as a class in the left pane. To add code, Place your cursor at the end of the line and press enter. To reduce typing, use the IntelliJ shortcut PSVN, which is in short for public static void main, and press the tab key. IntelliJ will automatically generate the main method. Use system.out.println line parentheses hello world parentheses semicolon, and of course put the double quote around hello world. Now this will print hello world to the console. Remember to end each statement with a semicolon. To execute this code, click the green button at the top right or the green arrow to the left. You can also right-click and select Run. IntelliJ uses the JDK to build and execute the Java program, displaying the output "Hello World" in the running pane. The process finishes with an exit code of 0, indicating a successful completion. Yep, beautiful. We have successfully executed our Hello World Java program in IntelliJ IDEA. I hope you found this lecture helpful, and I'll see you in the next one. In this lecture, we will learn the Hello World program in IntelliJ IDEA. In the previous lecture, we executed our first Java code in IntelliJ. Now, let's take a closer look at the source code for this class, as it is displayed in IntelliJ. You will quickly notice that the code is formatted with a variety of fonts and colors and is well indented. Whenever we create text in a file, IntelliJ automatically formats it for us. When examining the code, you will see elements such as public and class. The public keyword is an access modifier that controls the access level of a class, method, or field. When a class is declared with the public keyword, it means that the class can be accessed from anywhere in the code, whether within the same package or from the other packages. Access modifier help define which part of our code or someone else's code can access a particular element. Okay, now the class keyword is used to define a new class in Java. The class name follows this keyword. A class acts as a blueprint for creating objects with specific data structure, providing initial values for state members variables, which is fields, and implementing behavior member functions, methods. The left and right curly braces define a class body containing the field and methods that make up the class. Anything inside these curly braces is considered a part of class definition. The class definition may also have an optional access modifier at the beginning, such as public in this case, which grants full access as described earlier. This overview will be expanded later when we discuss access modifier and class definition in more detail. Everything inside the curly braces belongs to this class. As we progress through the course, you will see that a class can include both data and code. In this case, we have a clear definition of our first class and our first project. You can also see that this class contains a main function that prints the hello world message. Before diving into that, let's define a method. A method is a group of statements that perform an action. A main method is a special method that Java searches for when executing a program. It serves as an entry point for all Java code. Whenever we run a Java program, Java looks for the main method to launch and execute the application. Later, you will learn how to create your own methods. All right, let's discuss the method and the keywords preceding the method name main. The first keyword is public, which we already covered when defining the class. It allows the other code to access this function. To fully understand the Java keyword static, you need familiarity with other object-oriented concepts. For now, Just know that static is necessary for Java to locate and execute this specific method. All right? Okay. The next keyword, void, indicates that the method will not return any data. We will explore this in more detail later. The parentheses are required for a method declaration, and we are defining a method by including this code. You can optionally specify one or more parentheses inside the parentheses to provide information to the method. Here you see one parameter, which we will discuss in more detail later. The main method must be written exactly as shown, with its syntax carefully followed for Java to recognize it. If you change anything, such as using an uppercase C in the word class, IntelliJ will underline it in red, indicating that it does not recognize the term. That's why it's intelligent. Correcting it back to lowercase c resolves the issue. Be aware of this, as errors often stem from incorrect capitalization. The left and right curly braces used to group statements together, as discussed in the J shell lecture, also appear in the main method declaration. This grouping is known as code block, which in this case defines the beginning and end of the method. You can insert code statements within this block. For practice, let's change the hello world statements to hello Nixware company and run it. It's just a made up company. You can see the updated output. Next, let's create another class in IntelliJ. Right click on this src folder in your project. Select new and then choose Java class. Enter the name, my class, and press enter. You will see my class listed under the src folder with a small blue uppercase C icon indicating it is a class. In the editor window, you will see the class name, my class, and the curly braces for the class body. Let's add two print statements. First, write the method declaration: public static void main parentheses string bracket open bracket close, then arguments parentheses closed, followed by an opening curly brace. Then add the following statement: system.out.print parentheses double quote hello comma space Nixware double quote parentheses close and semicolon. Then the next line is system.out.print parentheses double quote American company double quote parentheses and semicolon. Close the curly brace. When you run the code, both messages will be printed on the same line. To print, for example, Nixware Company on a new line, change the first print statement to system.out.print line and then put that Nixware in it. The ln, or short for line, in print ln moves the cursor to the next line. Yep. So that's it. I hope you found this lecture helpful, and I'll see you in the next one. In this lecture, we will discuss conditional statements, which are if-then statements in Java. The if-then condition is used to control the flow of a program's execution. It allows developers to make decisions within the program based on certain conditions or circumstances. It is also known as conditional logic. So conditional logic in Java refers to the use of if-then statements and related construct to control the flow of a program's execution based on certain conditions. These statements allow a program to make decisions and take different actions depending on the current state or input. One common use of the if-then condition is to check the input values entered by the user to ensure they are valid before performing any further processing. For example, if an application prompts the user to enter a number between 1 and 10, the program can see an if condition to check if that number entered by the user is indeed within the range before proceeding. Another common use of the if condition is to make decision based on the current state of the program. For example, a program may use an if condition to check if a variable has reached a certain threshold before taking a specific action. The syntax of an if then statement is the if keyword is used to start the statement, followed by a set of parentheses that contain the condition that is being evaluated. The condition can be any expression that returns a Boolean value true or false. If the condition inside the parentheses evaluates to true, then the code within the curly braces that follow is executed. These curly braces enclose the code block that will be executed if the condition is true. Any number of statements can be put inside the if block, but it should be noted that the code inside the if block is executed only if the condition inside the if statement is true. Now, there are several advantages of using if condition in Java. All right, like conditional execution. If conditions allow for conditional execution of code, meaning that certain statements or block of code are executed only when a specific condition is true, which we already discussed, right? This allows for a more efficient use of resources and can make a program more versatile and adaptive to different situations. Then there is improved readability. If conditions can make the logic of a program more explicit and easy to understand. By using if conditions to separate the different branches of a program's logic, it becomes easier to see how the program is functioning and how it handles different inputs and scenarios. All right, then let's look at the better handling's advantage. If condition can be used to validate input to check for error conditions that may arise during the execution of a program. This allows for better error handling, which can make a program more robust and less prone to crashing. Okay, another one is enhanced flexibility. By using if else statements, developers can create more complex decision making logic, allowing for the program to handle multiple conditions and scenarios. All right, let's look at another advantage, which is reusability. If conditions can be used to create functions that can handle different conditions and inputs, and these functions can be reused in different parts of the program. This can save time and make the code more efficient. All right, in short, if conditions are a powerful tool for controlling the flow of a program's execution, making it more versatile and adaptive, also improving the code readability and reusability, making it more robust to handle different scenarios and errors. Also, there are a few potential limitations to using if conditions in Java, which I think we should look at as well. The first one is complexity. Using a multiple if condition in a program can make the code more complex and harder to understand, especially if the conditions are nested or involve multiple branches. This can make the program more difficult to debug and maintain. Then another limitation is performance. If a program has a large number of if condition, the execution time may become a bottleneck. Yep, and it can decrease the program performance, especially if the conditions are complex. This can slow down the program's execution time. Then repetitive code. Using too many if conditions can lead to repetitive code, making it harder to maintain and change the program. Then there is a limitation of readability. If the conditions and the code inside if statements are very complex, it can make the code less readable and harder for the developers to understand. All right, then let's look at neglecting other options. If the code is heavily reliant on the if condition, it can lead developers neglecting other options, like using different data structures or solving the problem in a different way. It is important to keep in mind that while if conditions are a powerful tool for controlling the flow of a program, they can also make the code more complex and harder to maintain if used excessively or in a disorganized manner. It is important to be mindful of the trade offs when deciding to use if conditions and make the best decision according to the context. That is why I included both advantages and its limitations. Now we come to some practice for if statements. For this open IntelliJ, here we create a class file named conditions. After creating this class file, add a main method to this class as we discussed in the previous lectures. Now we make a simple example of using an if condition with a Boolean expression in Java. Now we declare a variable named flag and assign it the value of true. The next is if statement, which checks the value of the variable flag, which evaluates to true because it was previously assigned the value true. If the condition inside the if statement is true, then the code within the curly braces that follow is executed. In this case, the code within the if statement block is system.out.println parentheses double quote flag is true semicolon. This line of code calls the println method of the system.out object, which is used to print text to the console. The text that is output is flag is true. Therefore, when this code runs, it will output flag is true to the console because the variable flag is assigned the value true. And therefore, the if statement condition evaluates to true, and the code within the if statement blocks is executed. Now you can see the output here. Now we see another example. For this, we create a new class file. This is a great practice for beginners and it makes the code easier to read and learn. So write the class name condition1, same as previous example. First create a main method here. Now we first declare a Boolean variable user and assign it the value of true. Then the if statement checks if the value of the variable user is equal to true by using the equality operator, that is equal equal. The condition inside the parentheses is user equal equal true, which compares the value of user with the Boolean literal true. If the condition inside the if statement is true, then the code within the curly braces that follow is executed. In this case, the code within the if statement block is system.out.println parentheses double quote it's true semicolon. This line of code calls the println method of the system.out object, which is used to print a text to the console. And the text that is output is it's true. Okay. Therefore, when this code runs, it will output it's true to the console because the variable user is assigned the value true. And therefore, the if statement condition evaluates to true and the code within the if statement block is executed. Now you can see the output here. Now we see another example. For this, we create a new class file named condition2. Now first we create a main method here. We first declare an integer variable x and assign it to the value of 5. Then the if statement checks if the value of the variable x is greater than 0 by using the greater than operator. The condition inside the parentheses is x greater than 0. which compares the value of x with the integer literal 0. If the condition inside the if statement is true, then the code within the curly braces that follow is executed. In this case, the code within the if statement block is system.out.println parentheses double quote x is positive semicolon. This line of code calls the println method of the system.out object, which is used to print text to the console. The text that is output is x is positive. It's important to note that if the condition inside the if statement is false, the code within the if block will not be executed, and the program will continue executing the next statement after the if block. I hope you learned something useful in this lecture, guys, and I'll see you in the next one. In this lecture, we will discuss logical operators in Java. In the previous lecture, we discussed the if-then condition and used some operators to learn the concept of the if-then condition. Now we will learn the logical operator and see how we could use it. In Java, logical operators are used to perform logical operations on Boolean expressions. They are used to combine multiple conditions in an if statement or a loop or to negate a Boolean value. The logical operators that are available in Java are AND operator. This operator is used to check if both the conditions are true. If both conditions are true, then the entire expression returns true. The next one is OR operator. This operator is used to check if either of the conditions is true. If any one of the conditions is true, then the entire expression returns true. Yep. Okay. The next one is a NOT operator. This operator is used to negate a Boolean value. If a condition is true, then the NOT operator will make it false, and vice versa. Some other include working with bitwise logical operators such as bitwise and bitwise OR operators. In Java, bitwise logical operators are used to perform operations on individual bits of a binary number. These operators work on a binary representation of the numbers and allow you to manipulate the bits directly. Bitwise logical operators are typically used in a low-level programming, such as working with hardware devices or in performance-critical code, when manipulating the bits directly can be faster than using the higher-level operators. It's also used in some cases where bit manipulation is needed, such as in encryption and compression algorithms. So we will discuss bitwise logical operators later. Logical operators are important in Java because they allow you to create complex conditional statements and control the flow of execution of your program. They allow you to check multiple conditions and make decisions based on the result of those conditions. They can simplify complex expression by breaking them down into smaller, more manageable parts. They also make your code more readable and maintainable. Logical operators are also useful for improving the performance of a program, as they allow you to evaluate multiple conditions in a single statement and avoid unnecessary computation. Furthermore, logical operators are versatile and can be used in a wide variety of situations, such as in if-else statements, while loops, and for loops. This makes them a powerful tool for programmers to use in many different types of applications. So, there are a few potential limitations of using logical operators in Java as well, like complexity. Logical operators can make code more complex and harder to understand, especially when multiple conditions are combined in a single expression. Also, error prone. Logical operators can be difficult to use correctly, and using them incorrectly can lead to bugs and errors in your code. Also, performance. Using too many logical operators can slow down the performance of a program. So remember that. Then there could be confusion where logical operators can be confusing to new programmers especially if they are not familiar with the rules of Boolean logic. And then also it has some limited functionality, like not able to perform all the logic manipulation. It only performs the basic logic manipulation, and other complex logic manipulation requires other techniques. Now we come to some practice, okay? So for this, open IntelliJ. Here we create a class file named logical operators. Now we declare an integer variable named age and assign it to the value of 18. Then use the if statement to check if the value of variable age is greater than 18. The if statement starts with the keyword if followed by a condition in parentheses, in this case age greater than 18. This condition is checking if the value of age is greater than 18 using the greater than symbol operator. If the condition is true, the code inside the curly braces will be executed. In this case, the code inside the if statement is a simple print statement that prints out condition is true to the terminal or your console. If the condition is false, the code inside the if statement will not be executed and nothing will be printed to the console. Now you can see the output here. Next, we declare another string variable named gender and assign it the value of male. If the statement starts with keyword followed by a condition in parentheses, in this case gender equal male, the condition is checking if the value of gender is equal to male using the equality equal operator. If the condition is true, the code inside if statement will be executed. The code inside the if statements is simple print statement that prints out condition is true. In this case, since the value of gender is male, this if statement is met, right? So the code inside the if statement will be executed and the output will be condition is true. Yep. Now you can see the two outputs here. First for upper if statement and second for below if statement. And now we use AND operators to combine these two conditions into one if statement. For example, if we want to check if the age is equal to 18 and the gender is equal to male, then output is given, and that is legible. First, we will comment on these print method statements because we want only the last generated output. So we use already created variables from the above, which are age and gender. The if statement starts with the keyword if followed by a condition in parentheses. In this case, age greater than 18 and operator gender equal double quote male. The condition is checking if the value of age is greater than 18 and if the value of gender is equal to male using the and equal operators respectively. The ampersand or and operator is used to check if both conditions are true. If both conditions are true, the code inside the if statement will be executed. The code inside the if statement is a simple print statement that prints out eligible to the console. If either of the conditions is false, the code inside the if statement will not be executed and nothing will be printed to the console. Now you can see the output here. See another example. For this, we create a class file named logical operators 1. Now we declare one integer variables, a, b, c, and d, and initialize them with the value 10, 20, 20, and 0 respectively. The if statement starts with the keyword if followed by a condition in parentheses. In our case, parentheses a less than b, and operator parentheses b equal c. The condition is checking if the value of a is less than b and if the value of b is equal to c using less than and equal operators respectively. The AND operator is used to check if both conditions are true. If both conditions are true, the code inside the if statement will be executed. The code inside the if statement assign the sum of the variables a, b, and c to the variable d and prints out. The sum is along the value of d. Then if statement will be executed because the values of a and b are 10 and 20 respectively, and b equal c, which is 20. So the result will be the sum is 50. Now you can see the output here. It's a simple example of how a logical operator can be used to check multiple conditions in a single statement and perform different actions based on the outcome. It's a good practice to initialize variables with meaningful values. This will help to improve the readability and maintainability of the code. I hope you learned something useful in this lecture, and I'll see you in the next one. In this lecture, we will discuss OR and NOT logical operators in Java. First, we will discuss the OR logical operator and its examples, and then discuss the NOT logical operator. So, in Java, the OR logical operator is used to test whether either or both of those two conditions are true. It returns Boolean value of true if at least one of the conditions being tested is true and returns false if both conditions are false. The OR operator is represented by two vertical lines and is commonly used in control flow statements such as if else and while loops to make decisions based on multiple conditions. Here we can see an example. In this piece of code, the variable x and y are assigned the values 4 and 5 respectively. Okay. The if statement is then used to check if either x or y is greater than 4. The OR operator is used in the condition of the if statement to check if either x greater than 4 or y is greater than 4 is true. In this case, the value of y is greater than 4. So, the if statement evaluates to true and the code inside the if statement block is executed. The code inside the if statement block is a call to the system.out.println method, which outputs the string x or y is greater than 4 to the console. Okay, so the output will be x or y is greater than 4. It's important to note that in this case, the value of x is not greater than 4, but the OR operator checks both conditions, and since one of them is true, the if statement is executed. The OR logical operator has several advantages when used in Java. Look at them one by one. The first one is it's concise and easy to read. The OR operator allows you to check multiple conditions in a single line of code, making your program more readable and easier to understand. It gives you the flexibility, which allows you to check the multiple conditions and take action based on any of them being true. This allows for greater flexibility in your program to control. Also, it gives improved performance. Yep, the OR operator short circuits, which means that it stops evaluating further conditions as soon as one of them is found to be true. This can improve the performance of your program, especially when dealing with a large number of conditions. Then let's talk about error handling. The OR operator can be used to check multiple conditions for errors in a single line of code. Again, this can improve the readability and maintainability of your program. Also, it has multiple conditions check, which allows checking multiple conditions in a single line of code. This can save many lines of code and make it more readable, rather than writing multiple if-else statements. Also, it gives combining multiple conditions. The OR operator allows you to combine multiple conditions in a single statement. This can make your code more efficient as it will only execute the code block when one or more conditions are met. While the OR logical operator has many advantages, there are also some limitations to consider when using it in Java. And I always wanted to give you the pros and conditions of everything that we are covering, so you will have a better understanding. All right, let's cover these advantages real quick. Complex condition is the first one. So when using OR operator to check multiple conditions, it can make the code more complex and harder to understand, especially when dealing with a large number of conditions. Then the next one is inefficiency. If multiple conditions are independent from each other, checking them all with OR can lead to inefficiency since it will check all conditions even if one is true. Reduce performance, yep, when using OR operator to check multiple conditions, It may not be as efficient as using multiple if-else statements. Yep. Then moving on to lag of granularity. The OR operator only checks whether one or more conditions are true and doesn't provide information about which conditions were true. Now, this can make it difficult to take specific actions based on which conditions was met. Another one is incorrect result. If the conditions are not well defined or if the logical operator is not properly used, the OR operator can lead to incorrect results. Then there is a risk of logical errors. Using the OR operator incorrectly can lead to logical errors, where the program behaves in unexpected ways or produces incorrect results. Therefore, it's important to understand the behavior of OR operator and use it correctly. All right, now that we have covered, let's do some practice. For this, open IntelliJ. Here we create a class file named OR operator. Now we declare a double variable named exam score, and then the variable exam score is assigned the value of 85. All right. The if statement is then used to check if the value of exam score is greater than or equal to 60 or less than or equal to 100. The condition of the if statement is exam score greater than or equal to 60. And then there are two pipes, which is or exam score is less than or equal to 100, which means that if the value of exam score is greater than or equal to 60 or less than or equal to 100, the if statement will evaluate to true and the code inside the if statement block will be executed. Here, the less than or equal to operator and greater than or equal to operator is a comparison operator that is used to determine if the value is less than or equal to or greater than or equal to another value. We will discuss comparison operator in detail later on. Okay, in this case, the value of exam score is 85, which is greater than 60. So the first part of the condition, exam score is greater than equal to 60, is true. And the if statement will evaluate to true, and the code inside the if statement block will be executed, right? So the code inside the if statement block is a call to the system.out.println method, which outputs the string, and that is the student has passed exam. Woohoo! To the console. Okay, so the output is. Now let's see another example. In this example, we'll show how the OR operator is used to check if a number is even or divisible by 3. It checks if the remainder of the dividing num by 2 is equal to 0 or the remainder of the dividing number or num by 3 is equal to 0. So for this, we create a class file named OR operator1. Now we declare a double variable named num, and then the variable num is assigned the value of 6. The if statement is then used to check if the value of num is even or divisible by 3. The condition of the if statement is num percent 2 equals 0 or num percent 3 equals 0, which means that if the remainder of the dividing number or num by 2 is equal to 0 or the remainder of the dividing num by 3 is equal to 0, the if statement will evaluate to true and the code inside the if statement block will be executed. Yep. Okay. In this case, the value of num is 6. The remainder of 6% 2 is 0. So the first part of the condition num percent 2 equals 0 is true. And the if statement will evaluate to true and the code inside the if statement block is executed. The code inside the if statement block is the if statement block is a call to the system.out.println method, which outputs the string. The number is even or divisible by 3 to the console. It's important to note that 6 is also divisible by 3, so if the program was checking both conditions independently, the output would be the same. But the OR operator allows to check both conditions in a single line of code. Now come to NOT operator. In Java, the NOT logical operator is a unary operator that is used to negate the value of Boolean expression It is commonly used to invert the truth value of a Boolean variable or expression. The not operator is represented by an exclamation mark or bang and is placed before the Boolean expression that is to be negated. Here we can see an example. In this piece of code, the value of the variable flag is true. The not operator is used to negate the value of flag. So the if statement value is to false. Therefore, the code inside the if statement block is or will not be executed. The not logical operator has several advantages and used in Java, like simplifies control flow. It also improves readability. Okay, the not logical operator has several advantages when used in Java, like simplifies control flow and gives improved readability. It has error handling, gives reusable code, which is the not operator can be used to create reusable code by inverting the results of a function that returns a Boolean value. Also, it is versatile. Then condition inversion, which means the not operator is useful when you need to invert the condition of your code, making it more readable and maintainable. Brevity. The not operator can make the code more brief as it allows to negate a condition in a single line rather than writing multiple lines of code. All right, it's a quick way to invert the value of Boolean variable or expression, making it a powerful tool for controlling the flow of a program. All right, while not logical operator has many advantages, there are also some disadvantages to consider when using in Java. Some of them like are complexity, confusion, some error prone, some risk of logical errors, um, reduced performance when using the not operator to negate a large number of condition. It can lead to reduction in performance. Yep. Also, it's a unary operator, meaning it only operates on one operand, so it can only negate a single Boolean value or expression, and it cannot be used in conjunction with other logical operations. Now we come to some practice. For this, again, open IntelliJ. This example shows how the not operator is used to check if a number is odd. It negates the result. So if the result is false, meaning the number is odd, the if statement is executed. Now we create a class file named not operator. Now we declare an integer variable named num, and then the variable num is assigned the value of 7. The if statement is then used to check if the value of the num is odd. The condition of the if statement is exclamation parentheses num percent 2 equal 0 close parentheses, which means if the remainder of the dividing num by 2 is not equal to 0, the if statement will evaluate to true and the code inside the if statement block will be executed. In this case, the value of num is 7, the remainder of 7% 2 is 1, so the expression num percent 2 equal 0 is false, and a not operator negates this value, making the if statement true. Therefore, the code inside the if statement block is executed. The code inside the if statement block is a call to what? System.out.println method, right? Which actually outputs the string, the number is odd. All right, I hope you learned something useful in this lecture, and I'll see you in the next one. In this lecture, we will discuss assignment operators in Java. We have already discussed some of assignment operator in the previous arithmetic operators lectures. Now we discuss in detail in Java, assignment operator are used to assign a value to a variable. The basic assignment operator is equal to, which assigns the value on the right side of the operator to the variable on the left side. For example, integer x equal 5 semicolon. It assigns the value of 5 to the variable x. In Java, there are common assignment operators like equal, which is basic assignment operator, which assigns the value on the right side of the operator to the variable on the left side. Then there is plus equal, which is addition assignment, which adds the value on the right side of the operator to the variable on the left side and assigns the result to the variable. Then there is minus equal, which is a subtraction assignment, which subtracts the value on the right side of the operator from the variable on the left side and assigns a result to the variable. Then the next one is multiply equal, which is a multiplication assignment, which multiplies the value on the right side of the operator by the variable on the left side and assigns the result to the variable. Then there is divide equal, is division assignment, which divides the variable on the left side by the value on the right side of the operator and assigns the result to the variable. Then there is modulus equal, which is a remainder assignment, which calculates the remainder when the variable on the left side is divided by the value on the right side of the operator and assigns the value to the variable. Okay, now let's look at several advantages of using assignment operator in Java, like conciseness. Assignment operator allows you to perform an operation and assignment in a single step, which can make your code more concise and easier to read. Yep. Then also improve readability. Using shorthand assignment operators can make your code more readable by clearly indicating the intent of the operation. For example, the statement x plus equal 10 is more clear than x equal x plus 10, right? Okay. The next one is increase efficiency. Assignment operator can increase the efficiency of your code by reducing the number of operators that need to be performed. Then there is chaining. Assignment operator can be chained together to perform multiple operations on the same variable in a single line of code, which can also improve readability and conciseness. Not to forget, there has reduced errors. Yep, assignment operator can reduce the number of errors in your code by making it less likely that you will accidentally use the wrong operator or forget to update a variable. Then the last one we'll talk about is avoiding unnecessary variables. In some cases, the assignment operator can be used to avoid the need for additional variables, making the code more efficient and easier to read. Okay, now we come to some practice. For this, as always, I want you to open IntelliJ. Here we create a class file named assign operator. Now we declare an integer variable named x, and then a variable x is assigned the value of 10 using equal assignment operator. The statement x plus equal 5 semicolon use this shorthand addition assignment operator to add the value of 5 to the current value of the variable x, and then assigns a result to the variable x. In this case, the original value of x is 10 and the operation x plus equal 5 semicolon is equivalent to x equal x plus 5 semicolon. So the value of x after this operation will be 15. So we already discussed these entire assignment operators in our previous arithmetic operators lectures, right? Now we discussed the difference between equal sign and equal to operator. Now in Java, the assignment operator equal is used to assign a value to a variable, while the equal to operator equal is used to compare the value of two variables or expressions. For example, we are declaring two integer variables, x and y, and initializing with the value of 5 using assignment operator. Then use an if statement, and the equal to operator compares the value of two variables x and y and returns a boolean value, true or false. This operator compares the value of the variable x and y on the left and right side of the operator. If the values are equal, the code inside the if statement will execute and print both are equal. And that goes to the console. So in this case, both x and y are assigned the value of 5 before the comparison. So the condition x equal y is what? True. Yep. And the code inside the if statement will execute, resulting in both are equal being printed on the console. Now, let's see another example. We declare a Boolean variable z and initializing it with the value of true. Then we use an if statement to check if the variable z is equal false. You can see that we use the equal assignment operator in if statement rather than the equals to operator. What it means here is it's assigning the value false to the variable z, and the assignment operator returns the value that is assigned, which is Boolean false in this case. So the if statement will always evaluate to false, and the code inside the if statement will never be executed. This will lead to program not printing anything to the console. That is to say, the value is assigned without being compared, as you can see the output. All right, folks, I'll see you in the next one. In this lecture, we will discuss comparison operators in Java. In Java, comparison operators are used to compare two values and return a Boolean value true or false, indicating the result of comparison. These are the most commonly used comparison operators in Java: equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. They are used in many different ways in Java, such as conditional statements. Comparison operators are often used in conditional statements such as if else, switch case to make decisions based on the comparison result. Then looping. Comparison operators are used to control the flow of loops such as while, do while, and for loops. Also for searching and sorting. Comparison operators are used to search and sort data in arrays, lists, and other data structures. Moving on to comparison of objects. Comparison operators can be used to compare the properties of two objects and determine their relative order. The next one is checking the type of an object. Instance of operator is used to check if an object is an instance of a class or an interface. Then there is debugging and testing. Comparison operators are also used in debugging and testing to check the statement of a program and ensures that it is working as expected. All right, moving on, comparison operators in Java have several advantages, and I wanted to cover both advantages and disadvantages real quick. All right, the first one is simplicity. Comparison operators are easy to use and understand, enabling direct value comparison for more readable and maintainable code. Then flexibility. They work with various data types such as integers, floats, strings, and objects, making them highly versatile. Then another advantage is conditional control flow. Comparison operators allow decision making based on comparison result, leading to dynamic and flexible code. And the last one in advantages is searching and sorting. They facilitate efficient data searching and sorting in arrays, lists, and other structures, making data organization straightforward. All right, now let's look at some of the disadvantages. And the first one is limited functionality. Comparison operators only handle simple comparisons, making complex tasks more verbose and harder to read. Then there is inconsistency. They may behave unexpectedly across data types, like when comparing strings and numbers. Then there is overuse. Excessive use can complicate code readability and maintenance. Moderation is the key. All right, the next disadvantage is inability to compare certain data types. Yep, some types like NaN cannot always be compared. Then the restricted object comparison. Only exposed properties of object can be compared. And the last one is not ideal for complex tasks, which is for more complex comparisons, other methods are often better suited. All right, that's about advantages and disadvantages. Now let's do some practice. For this, I want you to open IntelliJ. Here we create a class file named comp operator. Now we declare three integer variables, x, y, and z, and assigns them initial values. The variable x is assigned the value of 5, variable y is assigned the value of 3, and the variable z is assigned the value of 4. Then the if statement checks if the condition x greater than y and x greater than z and the AND operator is true. This means that x should be greater than both y and z for the if statement to evaluate as true. The AND operator is used to check if two conditions are true. If both conditions are true, the overall result is true. Otherwise, the result is false. In this case, the first condition is x greater than y, and the second condition is x greater than z. If the condition x is greater than y and x greater than z, using AND operator is true, meaning that x is indeed greater than both y and z. Then the code inside the if statement will execute, and it will print x is the largest number. Here is the output. Okay, now let's see another example. In this example, we use if statement that only evaluates as true if score is greater than or equal to 80 and smaller than or equal to 95. If score is greater than 95 or smaller than 80, the inside the if statement won't execute. For this, we declare a variable score as an integer and assign it an initial value of 85, and another variable grade as a string. Then the if statement checks if the condition score greater than or equal to 80 and operator smaller than or equal to 95 is true. This means that score should be greater than or equal to 80 and less than or equal to 95 for the if statement to evaluate as true. The AND operator is used to check if two conditions are true. If both conditions are true, the overall result is true. Otherwise, the result is false. In this case, the first condition is score greater than or equal to 80, and the second condition score less than or equal to 95. If the condition score greater than or equal to 80 and operator smaller than or equal to 95 is true, meaning the score is between 80 and 95, inclusive. Then the code inside the if statement will execute, and it will assign A to the variable grade. And the print method outputs the grade variable result on the screen, here as you could see it. All right, I hope you learned something useful in this lecture, and I'll see you in the next one. In this lecture, we will learn the ternary operator in Java. So the ternary operator is a shorthand way of writing an if-else statement. It is the only operator in Java that operates with three operands, which is why it is often referred to as a conditional operator. The ternary operator is a concise way of performing conditional checks. It uses the syntax condition, question mark expression 1, colon expression 2, and closes with semicolon. If the condition evaluates to true, the value expression 1 is returned. Otherwise, expression 2 is returned. Let's consider an example. The ternary operators to determine the value of a variable based on an age condition. We have an integer variable age with the value 20. The ternary operator checks if age is less than 18. If true, it assigns underage to the status variable. Otherwise, it assigns senior or, adult, whatever you want to pick. Since age is 20, the condition is false, so the value senior is assigned to the status and printed to the console. In another example, we use a ternary operator to determine a pass or fail result based on the marks variable. The value of marks is set to 50. The ternary operator checks whether marks are greater than 40. If the condition is true, it assigns pass to the result variable. Otherwise, it assigns fail. Since the value of marks is 50, which is greater than 40, the condition is true, so the pass is assigned to the result. The output message confirms you passed the exam. All right, that's great. But folks, don't get 40 or 50. I want you to get more than that, close to 80% mark. And I know you will. Okay, finally, let's consider a case where we check whether a number is positive or negative. The variable number is assigned the value 24. The ternary operator checks if the number is greater than 0. If true, it assigns positive number to the result variable. Otherwise, it assigns negative number. Since the number is 24, the condition is true, So the value positive number is assigned to the result and of course printed to the console. All right, I hope you found this lecture helpful and I'll see you in the next one. In this lecture, we will practice some of the operators questions in Java. In the previous lectures, we discussed several types of operators that can be used to perform various operations in a program. These are like arithmetic operators. These include basic mathematical operations such as addition, subtraction, multiplication, division, and modulus, increment, decrement. Then there is comparison operators, right? Those operators are used to compare values such as equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to operators. They return a Boolean value of true or false, right? Okay. Also, logical operators, don't forget that. These operators are used to combine multiple conditions in a logical expressions such as and, or, not. Then there are assignment operators that we talked about. These operators are used to assign a value to a variable, such as the equal sign, or to perform a mathematical operation on a variable and assign the result, such as addition assignment, subtraction, multiplication assignment, division assignment, and remainder assignment operators. Then the last one we talked about is the ternary operators. These operators provide a shorthand way of writing an if-else statement using the format condition question mark, expression 1, colon, expression 2. Okay, now for some practice. For this, open IntelliJ. Here we create a class file named challenge1. Now see the first challenge, that is, how can I check if a number is within a certain range using logical operators? For this, we declare a variable called num and assign it to the value 15. Then use if statement. It checks the condition inside the parentheses, which is num greater than 10, and operator num less than 20. The ampersand operator is used to check if both conditions are true. In this case, the first condition being checked is num greater than 10, which is true because the value of num is 15, which is greater than 10. The second condition being checked is num less than 20, which is also true because of the value of num is 15, which is less than 20. If both conditions are true, then the code inside the curly braces will be executed. In this case, it is a single line of code that prints out a message that is the number is within the range of 10 to 20. Now we see that output. Excellent. Okay, so now we see another challenge, that is, how can I use the OR operator to check if the variable is equal to multiple values? Okay, for that we create file name challenge2. Now we declare a variable called val and assign it the value of 5. Then use if statement. It checks the condition inside the parentheses, which is val equal to operator 3 or operator val equal to operator 5 or operator val equal to operator 7. The pipe or operator is used to check if at least one of the condition is true. In this case, the first condition being checked is val equal to operator 3, which is false because the value of val is 5, which is not equal to 3. The second condition being checked is val equal to operator 5, which is true because the value of val is 5, right, which is equal to 5. The third condition being checked is val equal to operator 7, which is what? False, right? Because the value is 5, not 7. So, if any of the condition is true, then the code inside the curly braces will be executed. In this case, it is a single line of code that prints out a message that is, the value is 3, 5, or 7. Here's the output. Now see another challenge, that is, how can I check if one variable is less than or equal to another? For this, we create a class file named challenge3. Now we declare a variable called num1 and assign it to the value of 10. Then declares a variable called num2 and assign it to the value of 15. Then use if statement. It checks the condition inside the parentheses, which is num1 less than or equal to num2. The less than or equal to operator is used to check if the value of num1 is less than or equal to the value of num2. In this case, the value of num1 is 10 and the value of num2 is 15. And 10 is less than 15, so the condition is true. If the condition is true, then the code inside the curly braces will be executed. In this case, it is a single line of code that prints out a message num1 is less than or equal to num2. Here is the output. All right, now let's look at more complex challenge statement. That is, write a Java program that declares and assigns a value to three variables, x, y, and z. Using an if statement, check if the value of x is greater than 20, and either the value of y is less than 30, or the value of z is greater than 30. Okay, if the condition is true, print the message, the condition is true. For this, we create a class file named challenge4. Now we declare a variable called x and assign it to the value of 25. Then declares a variable called y and assign it to the value of 30. Then declares a variable called z and assign it to the value of 35. Then use if statement to check the condition inside the parentheses, which is x greater than 20 and operator parentheses y less than 30 or operator z greater than 30. The first part of condition x greater than 20 is a relational operator that checks if the value of x is greater than 20. In this case, the value of x is 25, which is greater than 20. So this part of the condition is true. All right, the second part of the condition is parentheses y less than 30 or operator z greater than 30, which is a logical OR operator that checks if either of the condition inside the parentheses is true. The first condition, y less than 30, is a relational operator that checks if the value of y is less than 30. The value of y is 30, which is not less than 30. So this part of the condition is what? It's false. The second condition, z is greater than 30, is a relational operator that checks if the value of z is greater than 30. The value of z is 35, which is greater than 30. So this part of the condition is, of course, true. All right, the logical AND operator combines two parts of the condition and checks if both are true. Since the first part of the condition is true and the second part is true, the overall condition is true. If overall condition is true, then the code inside the curly braces will be executed. In this case, it is a single line of code that prints out the message that is, the condition is true, and you can see the output. Now let's look at a more complex challenge statement. Yep, I want you to keep trying it and keep checking it out through these practices. Okay, write a Java program that declares and assigns value to two variables, A and B, using the ternary operator. Assign the value of a string variable result based on whether the value of A is greater than B or less than B. Then prints the value of the result variable. For this, create a class file named challenge5. Now we declare a variable called A and assign it the value of 5. Then declares a variable called B and assign it to the value of 10. Then write string result equal parentheses A greater than B question mark. A is greater than B colon. A is less than B semicolon. The ternary operator is used to assign the value of the result variable based on the outcome of the expression. Then use ternary operator statement. It checks the condition inside the parentheses, which is a greater than B. The condition being checked is a greater than B. If the condition is true, the value of the result variable will be A is greater than B. If the condition is false, the value of the result variable will be A is less than B. In this case, the condition is false. The last line of code prints the value of the result variable. So, here is the output. I hope you learned something useful in this lecture, and I'll see you in the next one. In this lecture, we will learn keywords and expressions in Java. We will build on our previous discussions of expressions and go deeper into keywords, which we have already touched on before. Starting with keywords, there are 51 reserved keywords in Java that you can utilize in your programs. Each of these reserved keywords has a specific meanings in Java programming language, including terms like integer, double, float, and many more. You don't need to memorize all of them, of course, as we will cover each one in detail throughout this course. Java uses the term character sequences to describe these keywords because since Java 9, the underscore is considered a keyword in itself. Okay, a character sequence refers to a specific sequence of characters that have a distinct meaning within Java. These reserved sequences cannot be used as variable names, method names, or class names. For example, the keyword class is a reserved term in Java that is used to define classes and cannot be used as a name of a variable, method, or class. In addition to the 51 reserved keywords, Java, as of JDK 17, has 16 contextual keywords that acts as a keywords only in specific context. To explore keywords further, let's open IntelliJ and create a new project. We will call this project Expressions and Statements using a camel case. On the Welcome to IntelliJ idea screen, select New Project. We will choose Java as the language and accept the default settings before clicking Create. Inside this project, we will create a new class called main by clicking on the src source folder, selecting new class and naming it keywords. Once we have the main class set up, you will notice that IntelliJ highlights certain words in blue, indicating that they are reserved keywords. For example, if we attempt to create a variable using a keyword like double, by writing double equal 2.0, IntelliJ will highlight an error with red underscores, indicating that something is wrong. This happens because double is a reserved data type and cannot be used as a variable name. If we change the variable name to double one, the error is removed since double one is not a reserved keyword. This demonstrates the importance of ensuring that you are not using reserved keywords for variable names. That is why I want you to remember what are those keywords. Additionally, although true, false, and null are technically not keywords but literal values, they also cannot be used as variable names or other elements. Now, let's move on to expressions. An expression is a combination of one or more literals, variables, operators, and method calls that can be evaluated to a single value. Expressions are used to perform calculations, assign values to variables, and control program flow. Simply put, an expression is something that evaluates to a single value. In contrast, a statement is a single instruction that tells the program to perform a specific action. Statements are standalone units of work within the code. Code blocks, on the other hand, are groups of statements enclosed in curly braces. Code blocks help define variable scope and group related statements together. Let's start with some examples of expressions. Consider this line of code that converts kilometers into miles using conversion factor. 1 kilometer equal 0.621371 miles, right? Double miles equals 70 times 0.621371. This line of code is a valid statement. The actual expression here is the calculation, which is 70 times 0.621371, which of course evaluates to a single value. The data type double and the semicolon are not part of the expression itself, but help form a complete statement. Another example of an expression involves clicking of a value of x is greater than 3 and then incrementing it by 10 if true. We first declare a variable x and assign it a value of 5. The if statement checks whether x is greater than 3. The condition x is greater than 3 is an expression that evaluates to true or false. If it evaluates to true, the code inside the curly braces increments x by 10. Yep. The new value of x becomes 15. Here x equal 5 is an expression, while the integer data type and semicolon make a complete statement. Now similarly, x greater than 3 is an expression. An if statement surrounding it forms a complete statement. Within the code block, there are two expressions: the calculation 10 plus x and the entire line excluding the semicolon. Yep. Okay, folks. I hope you found this lecture informative and useful, and I'll see you in the next one. In this lecture, we will discuss whitespace indentation and code organization in Java. We will explore what indentation and whitespaces are and why they are important for Java programs. To demonstrate this, I have created a new project in IntelliJ called Code Organization with proper indentation and spacing, and a new class named Whitespace with a capital W. I have also introduced the public static void main function. Let's start by declaring a simple variable within the main method, integer number equal 100. As discussed in previous lectures about expressions, this is an example where the number variable is assigned the value 100. So what does this statement mean? A statement in Java consists of the entire line of code, including the variable declaration, assignment expression, and the semicolon at the end. In this example, a valid Java statement is created by beginning with the data type and ending with a semicolon. Java statements may include assignment expressions, such as this one, where we assign the value 100 to the number variable. Next, consider a system.out.println statement that prints a string. This line of code outputs a message such as, "This is the Nextware company and its services include consulting." While most Java lines require a semicolon at the end to turn them into a statement, there are certain exceptions which we will discuss later in the course. It's important to note that statements do not necessarily need to fit on a single line. For example, a print statement can be split into multiple lines using a plus sign for string concatenation. As long as there is no semicolon indicating the end of the statement, you can continue the statement across multiple lines. This allows for better readability and makes complex statements easier to follow. Java treats the entire code segment as a single statement regardless of whether it spans multiple lines. Breaking down statements into multiple lines can help improve code readability. However, be cautious about placing semicolon in the wrong spot, as it may confuse Java about where a statement ends. You can also have multiple statements on a single line by separating them with semicolons. For example, you can declare a variable and print a message in one line. Although this is a valid in Java, it is generally discouraged because it can make the code harder to read and maintain. It's better to write one statement per line or break up longer statements into smaller segments for clarity. Now let's discuss white spaces in Java. White spaces refer to characters that separates words or tokens in the source code, such as spaces, tabs, and new line characters. These characters make the code more readable for humans but are ignored by the Java compiler. Two types of white spaces: horizontal and vertical white spaces. Let's talk about horizontal white spaces. This includes spaces and tabs used to separate words or tokens horizontally in the code, such as alignment variable, declaration, or method arguments. Then there is vertical white spaces. This includes new line characters and line breaks used to separate lines of code vertically, making it easier to distinguish between different code sections. Just ignore excess white spaces, meaning you can add spaces or tabs without affecting how the code runs. However, using too much white spaces or placing it in the unconventional ways can make the code difficult to read. Good formatting practices help create more readable code by aligning code blocks and using consistent white space. IntelliJ provides tools to help you format your code. For example, you can highlight a section of code to go to the code menu and select Reformat Code to automatically align the structure of your code according to standard conventions. This can help ensure that your code remains clean and organized. Now let's discuss indentation. Proper indentation makes your code easier to read by visually separating code blocks and indicating the logical structure of the program. If you remove all indentation, it becomes much harder to understand the code flow. Using the tab key or IntelliJ's reformat code feature can help you quickly apply consistent indentation, making the code easier to comprehend or understand. As you create code blocks at different levels, IntelliJ will automatically apply default indentation, making it easier to see how the code is organized. All right, I hope you found this lecture helpful, and I'll see you in the next one. In this lecture, we will learn the if then else control statement in Java. So, the if then else control statements in Java are used for decision making in a program, but they differ slightly in how they handle conditions. The if statement is used to execute a block of code only when a specific condition is true. The basic syntax of an if then statement starts with the if keyword, followed by the condition enclosed in parentheses, then curly braces containing the code to be executed if the condition is true. Now, on the other hand, the if else statement is used when you want to execute one block of code if the condition is true, and the different block of code if the condition is false. Yep. The syntax for an if else statement starts with the if keyword, followed by the condition in parentheses and curly braces for the if block. After this, the else keyword introduces another set of curly braces containing the code to be executed if the condition is false. The key difference between if then and if then else statement is that if then only execute the code block when the condition is true with no falling back code for what or when it is false. Whereas if then else provides a fallback code block for when the condition is false as well. Let's see an example where we check if a number is positive or negative. For this, let's create a variable num and initialize it with a value -5. Use an if-else statement to check if num is greater than 0. If true, print the number is positive. Otherwise, what? Print the number is negative. Since the value of num is number -5, which is of course less than 0, the else block will be executed and the number is negative will be printed on the console. All right, let's see another example where we check if a number is within a range. First, for that, create a variable num and initialize it with the value 10. Use an if-else statement to check if num is greater than 1 and 10 inclusive. If true, print number is within the range. Otherwise, print the number is not within the range. Simple. Now, since number is 10, it falls within the range, right? So the if block executes, printing what? The number is within the range. Yep. Okay. Let's see another example where we check if a letter is a vowel or consonant. For this, create a variable letter and initialize it with the value A. Use an if-else statement to check if the letter is one of the vowels. What are those? Like A, E, I, O, or U, right? If true, print the letter is vowel. Otherwise, print the letter is a consonant. Since the value of letter is A, the if block execute printing the letter is a vowel. Yep. Okay. Now letter if else statement. Let's talk about that. A ladder if else statement is used to check multiple conditions in a sequence. It is called a ladder because conditions are evaluated one after the other. If one condition is true, the corresponding code block executes, and the remaining conditions are ignored. If none of the conditions are true, the final else block executes. All right, let's see this as an example where we assign grades based on a score. For this, create a variable score and initialize it with the value 65. Use a ladder if else statement to check multiple conditions and assign a grade based on score. If score is greater than or equal to 90, print grade A. If it is greater than or equal to 80, print grade B. Continue checking conditions for grade C, grade D, and if none are true, default to grade F. Uh-oh, I hope you don't get that in your exam. Okay, since the score is 65, the corresponding else if block for grade D executes, printing grade D. By the way, I always hope that you get a grade of A above 90. All right, I hope you found this lecture helpful, and I'll see you in the next one. In this lecture, we will practice some ladder if then else exercises. So let's get started. For this, open your IntelliJ IDE and create a class file named ladder if else. Inside it, create a main method. Let's see an example where we determine age category. All right. In this example, we'll take a person's age and print out whether they are a child, teenager, adult, middle-aged adult, or senior citizen. All right. First, we create a variable age with an assigned value of 30. Then we use an if statement to check if the value of a variable age is greater than or equal to 5 and less than or equal to 12 using the greater than or equal to and less than or equal to operators. If this condition is true, it prints child. Okay, next we use the second else if statement to check if the value of the age is greater than or equal to 13 and less than or equal to 19. If this condition is true, it prints what? Teenager. Yes, exactly. Okay, then we use the third else if statement to check if the value of age is greater than or equal to 20 and less than or equal to 39. If this condition is true, it prints adult. After that, we use the fourth else if statement to check if the value of age is greater than or equal to 40 and less than or equal to 59. And in this case, if the condition is true, it prints, let's say, middle-aged adult. Finally, if none of the above conditions are true, the code in the else statement is executed printing senior citizen for ages 60 and above. Well, if you are 60 and above, then don't consider yourself senior citizen. Of course, this is just a category that we picked for this lecture. You're still young and still can learn. All right. In our example, since the value of age is 30, the program executes the third else if statement and prints adult. Here you can see the output. All right, let's see another example where we determine day of the week message. For this, let's create another class file named letter if else one. And inside it, create main method as always. All right, in this example, we'll create a program that takes days of the week and prints out a message depending on the day. For example, Monday blues, TGIF, which is thank God is Friday, and weekend. First, create a variable day with an assigned value of Tuesday. We then use an if statement to check if the value of day is equal to Monday using the equal operator. If true, it prints Monday blues. Next, use a second else if statement to check if the value of day is equal to Tuesday. If it's true, it prints just another Tuesday. Continue using additional else if statement to check for Wednesday. Prints hump day. Thursday prints almost Friday. And then Friday prints TGIF. A lot of people look for. Saturday will print for weekend, and Sunday prints weekend hangover. Hopefully, it doesn't happen. Okay, finally, if none of the conditions are true, the else statement prints invalid day. In this example, since the value of day is Tuesday, the program executes second else if statement and prints just another Tuesday. And we'll continue learning. Okay, and you see the output here. So, folks, I hope you found this lecture helpful, and I'll see you in the next one. In this lecture, we will discuss the nested if then else concept. So, the term nested refers to placing one thing inside another. In programming, it refers to placing one control flow statement, such as if then else statement, within another control flow statement. In other words, one control flow statement is nested inside another. When an if statement is nested inside another if statement, it is called a nested if statement. The inner if statement is executed only if the condition of the outer if statement is true. In Java, you can use if then else statement inside other if then else statements to create a nested structure. This is known as nested if then else. The inner if then else statement is executed only if the condition of the outer if then else statement is true. I hope I'm not confusing you, so we'll get into some syntax or examples later on. Here is the syntax. The outer if statement has a condition 1, which is evaluated first. If condition 1 is true, then the code inside the first set of curly braces is executed. Inside that code block, there is another if statement with condition 2. This inner if statement is nested within the outer if statement. If condition 2 is true, then the code inside the second set of curly braces is executed. However, if condition 2 is false, the code inside the else block is executed. If condition 1 is false, the code inside the outer else block is executed. All right, now let's see another example where we check if a number is positive and even. To demonstrate, open IntelliJ and create a class file named nested if else with a main method. In this example, we will create a program to determine whether a number is both positive and even. First, we create a variable number and initialize it with a value of 5. Then we use a nested if then else statement as follows. Use an outer if statement to check if the number is greater than 0. If true, the code inside the first set of curly braces is executed. Inside that code block, there is an inner if statement that checks if the number is even using the modulus operator. If number %2 is 0, it means the number is even. If this number if statement's condition is true, it prints a message stating that the number is positive and even. If the inner if statement's condition is false, the code inside the inner else block is executed, printing a message stating that the number is positive but not even. If the outer if statement's condition is false. The code inside the outer else block is executed. Now, printing a message stating that the number is not positive. Yep. In this example, since the number is 5, the outer if statement, which is number greater than 0, is true. But the inner if statement, number percentage 2 equal 0, is false. The output is 5 is positive but not even. Here is the output. Let's see another example where we offering a discount based on purchase amount and membership status. This actually will tell you what we mean by the entire nested if then else concept. Create a class file named nested if else one with a main method. In this example, we create a program that checks if a customer has made a purchase and offers a discount based on a purchase amount and a membership status. All right, create two variables, purchase amount of type integer and assigned a value of 120, and is member, all one word, of type string and assigned a value of yes. Use an outer if statement to check if purchase amount, one word, is greater than 100. If true, the code inside the first set of curly braces is executed. Inside that code block, use an inner if statement to check if the variable is member equals to yes. If true, print you are eligible for a 10% discount. If not, then print you are eligible for a 5% discount. If the outer if statement condition is false, then what happens? Then it will print you are not eligible for a discount. Beautiful. So in this example, since the purchase amount is 120 and the customer is a member, the output is you are eligible for a 10% discount, and you see the output here. All right, folks. Again, I hope you learned or you found this lecture helpful. I'll see you in the next one. In this lecture, we will learn about methods in Java. Every time we write code, we use a method, the main method, right? We will first explain what a method is and then break down the main method. So, a method in Java is a block of code that performs a specific task and can be invoked multiple times from other parts of the program. Methods can take parameters as input and may or may not return a value. They are defined within a class and usually consist of a name, a return type, and a list of parameters. The syntax for defining a method in Java is shown as modifier, space return type, space method name, parentheses, parameter, space list, parentheses closed, space, curly braces, method, space body, and curly braces closed. Now, here modifier are keywords such as public or private that control the access level of the method. They determine who can call or use the method. The return type is the data type of the value that the method returns. For example, if the method returns an integer, the return type would be integer, right? If the method does not return a value, the return type is void. Then the third part is the method name, is the name of the method. It should be descriptive to indicate what the method does. Then we have parameter list, which is a list of input variables, also known as parameters that the method accepts as input. Then in the end, there are curly braces. These curly braces enclose the actual code of the method, also known as method body. Inside the method body, various operations such as calculations and input-output operations can be performed. Now, simply put, a method in Java is a reusable block of code with a name. It can accept inputs and return outputs. The code inside the curly braces is executed when the method is called. Okay, now let's learn about main method. Here is the main method syntax first. Public space static space void space main parentheses string bracket bracket closed space arguments closing parentheses space curly braces close. Okay, here public means that the method can be called from anywhere in the program. Static indicates that the method belongs to the class itself, not an instance of the class. We will discuss method types in more detail in the upcoming lectures. Then void, which means that the method does not return any value. Then there is main, which is the main method name. Then there is string, brackets, arguments is an array of strings that can be passed to the main method when the program runs. All right, let's learn about some standard conventions for creating methods in Java. Let's start with method names. Method names should be written in camel case, where the first letter of the first word is lowercase and the first letter of the subsequent word is uppercase. Then there is descriptive names. Method names should clearly describe the method's purpose. For example, calculate circle area. You see all, we could put that in one word. And of course, followed by parentheses opening and parentheses closed. Instead of just saying area and parentheses open and parentheses closed. Then there is a no special character or spaces. Methods name should not contain special characters or spaces. Then parameters naming. Methods parameters should follow camel case convention and have descriptive names that match the expected data type. Then let's talk about return type in parentheses. The method's return type should be specified before the name, and the name should be followed by parentheses, even if there are no parameters. Then talk about indentation. The method body should be indented one level from the method declaration and enclosed in curly braces. All right, let's see an example where we create a simple method. To demonstrate, let's open IntelliJ and create a class file named myMethodClass with a main method. Remember, the main method is the entry point of a Java program that tells the JVM where to start execution. We will create a custom method after the main method and then call it inside the main method. A custom method or user-defined method performs a specific task. Let's define a method named printString with a public static void, which is a modifier, indicating it can be accessed from anywhere and does not return a value. The method takes no parameters and contains a system.out.println and put that in parentheses hello world. That statement to print a message to the console. To call the method, simply use its name followed by parentheses. Yep. So there are two main types of method: parameterized and non-parameterized method. Parameterized method, these methods take one or more parameters as input defined in the method signature. Then non-parameterized methods. These methods take no input parameters. The earlier example is a non-parameterized method. Let's see an example of a parameterized method. For this, create a class file named parameterClass with the main method. Define a method named myMethod that takes two parameters, an integer number and a string name. The method prints the value of the parameters. When calling this method, pass appropriate argument such as myMethod parentheses 1 comma double quote next where double quote close and close with parentheses followed by semicolon to execute it. All right, folks, I hope you found this lecture helpful as well, and I will see you in the next one. In this lecture, we will discuss how to use the return statement in a method. So we will look at some examples and explore how a method can return a value. Let's start with an example where we add two numbers. So open IntelliJ and create a class file named a method examples. Inside the class, create a main method. In this example, we will create a method that takes two numbers as parameters, calculates their sum, and prints the result using the print line method. Create a method using a public static void with the name add numbers that takes in two integer parameters, num1 and num2. The method add numbers is a public static method, meaning it can be called from anywhere within the program without creating an instance of the class. Now, inside the method, an integer variable sum is declared and assigned the value of the sum of num1 and num2 using the plus operator. System.out.println method is then used to print the string sum is along with the value of the sum variable. Yep. Okay, to call this method in the main method, simply use the method name followed by parentheses and pass the value you want to add. For example, 23 and 30. Remember that both parameters must be of integer type. Now run the program and you will see the output. Let's see another example where we calculating the area of a circle. For this, create another class file named a method example1. Inside the class, create a main method as always. This program will define a method to calculate the area of a circle. Define a public static method named calculateArea that takes two double parameters, radius and pi. The public keyword means that the method can be accessed by any code outside the class it belongs to, while the static means that the method can be called without creating an instance of the class. Inside the method body, a variable result is declared and assigned the value of pi multiplied by the square of radius using the multiplication operator. The system.out.println method is used to print the string area of circle is concatenated with the value of the result variable. To call this method in the main method, use the method name followed by the parentheses and pass the value for radius, for example 10, and pi, for example 3.14. Ensure both parameters are of double type and that value are passed in the correct order. Now run the program and you will see the output. Okay, now let's learn about the return statement. Similar to declaring a variable with a type, you can declare a method to have a return type. This declared type is placed before the method name. Additionally, a return statement is required in the method's code block, which specifies the value to be returned. So in the previous example, we used void, right? Which means that the method does not return any data. Here is an example of a method declaration with a return type. In this case, if the return type is integer, the method will return an integer value upon successful execution. Returning a value from a method allows for a two-way interaction between the calling code and the method, enabling the method to calculate and send back a value. All right, let's move on. Let's see an example where we're returning a value. Let's modify the previous calculateArea method to return a value instead of printing it. Change void in the declaration to double to indicate that the method will return a double value. Immediately, IntelliJ will highlight an error because the method is missing a return statement. Yep, you see that? Java requires a return statement in methods that return a value. A return statement transfers control back to the caller of the method, typically with a value. In methods that do not return anything, void methods, a return statement is not needed. In the modified calculateArea method, we want to return a result variable. The return statement should be placed just before the closing curly brace of the method. return result. Next, modify the code in the main method to capture the return value. Create a new variable area and assign it the value returned by the method call. Remember that the variable receiving the method value must have the same data type as the return type of the method. Print the area variable using system.out.println. When you run the program, you will see the output. Note that if you call calculate area a second time without capturing the return value, it will be ignored. Yep. All right. Let's see another example where we summing two numbers with a return statement. All right. For that, create another class file name, method example 3. Inside the class, create a main method, as you already know. This program will define a method that returns the sum of two numbers. Okay, now define a method name, add as public static to indicate that it can be accessed by other parts of the program without creating an instance of the class. The return type is integer, indicating that the method will return an integer value. The method takes two integer parameters, a and b, and performs a simple arithmetic operation, a plus b. The result is returned using the return statement. You can return values in various ways, including as an expression. To call this method in the main method, use the method name followed by parentheses and pass two integer values. For example, 100 and 200. Create an integer sum variable to store the return value and print it using println method. Now run the program and you will see the output. All right, I hope you learned something useful again in this lecture, and I'll see you in the next one. In this lecture, we will revise the concept of methods in Java. In previous lectures, we covered various concepts related to methods, remember? Yep. So now is a good time to review what we have learned and further explore how methods work effectively in Java. An executable piece of code in Java is declared as a method, and it can be called by passing a predetermined set of values and as arguments. A method can sometimes act as a statement or an expression, similar to some of the shorthand operators we have covered. Any method can perform a statement. Additionally, an expression or part of an expression may invoke a method that returns a value. In some programming languages, a method that doesn't return a value is called a procedure, while one that does return a value is called a function. In Java, however, the terms function and methods are often used interchangeably. While procedure is less commonly used to describe Java methods, a method with a void return type may still be referred to as such. Now, to create method, we must make several declarations, including starting with modifier. These are keywords like public or static that control the access level of a method and indicate its behavior. Public and static are examples, but there are others, of course. Then there is return type. This is the data type of the value returned by the method. If no data is returned, the return type is void. Yep. If a return type is defined, the code block must contain at least one return statement that returns a value of declared type or a compatible type. All right, then let's talk about method name. By convention, a method name should be written in lower camel case. Then there is method parameters. A method may or may not have parameters, which are declared within the parentheses. If no parameters are required, an empty set of parentheses is used. Then the last one is method body. This is enclosed in curly braces and contains the code to be executed by the method. Parameters are declared as comma separated list, each with a type and a name that is identifier. The order of the parameters matter when calling the method. The arguments passed must match the order and type specified in the declaration. The calling code must also pass the same number of arguments as declared parameters. Now, when declaring a return type, void indicates that no data will be returned. If a method declares a non-void return type, a return statement must be present at every possible exit point from the method block. All right, let's see an example of a method with a Boolean return type. Consider a method named checkNumber that is declared as public and static. The method returns a Boolean value as indicated by the Boolean keyword before the method name. It takes one integer parameter, number inside the method body. There is an if statement that checks if number is less than or equal to 1. If true, the method returns true. Otherwise, it does not return any value, which would cause an error. Yep. Thus, a value must always be returned when a return statement is used in nested code blocks within a method or possible code segments. All right, now let's see an example of a valid method with a return statement. Another valid example involves returning false if the condition is not met. The return statements can also terminate execution early in the method declared with a void return type. In such cases, the return statement is optional but can be used to exit the method prematurely, as demonstrated here. This type of return statement does not return any value because the method is declared with a void return type. Now, please note that no data is passed in the return statement, which is valid usage. Additionally, no return statement is needed at the end of the method block for void methods, unlike those with a non-void return type. All right, let's learn method signature and overloading. A method is uniquely defined in a class by its name and the number and type of parameters declared, right? This is called the method signature. You can have multiple methods with the same name as long as their signature differ. This becomes important when we cover method overloading later in this section. When invoking a method, you must provide values, arguments that match the declared parameters in number and type. Now, Java does not support default parameters values like some other programming languages. So the arguments must always exactly match the parameters in the method declaration. Let's revise the main method concept. The main method is special in Java because the Java virtual machine, or in short JVM, looks for a specific method signature as an entry point for executing code. The main method has two modifiers. What is that? Public and static. Yep, which are necessary for the JVM to recognize it. This method does not return any data as indicated by the void return type. The name of the method is main, written in all the lowercase. While you can technically name a method main or use all capitals, the Java compiler will not recognize it as the entry point. The main method takes one parameter named arguments, or args in short, which is an array of strings. This parameter allows the user to pass a list of values into the code from the command line or terminal. In IntelliJ, you can type PSVM and press enter to automatically insert the main method signature. All right, folks. Again, I hope you learned or you found this lecture helpful. I'll see you in the next one. In this lecture, we will practice some exercises related to methods in Java. Let's begin with the first example. For this, we will create a method named isEven, one word, that accepts an integer argument. The method should return true if the argument is even, or false otherwise. To do this, let's open IntelliJ and create a class file named method practice with the main method inside it. Next, we will create our custom method using public static boolean is even parentheses integer number and closing the parentheses. Here, the public indicates the method can be called and used by any class. Static means that the method belongs to class itself rather than an instance of the class. Boolean is the return type, signifying that it will return a true or false value. Is even is the name of the method, and the parameter integer number is the input passed to that method. Within the method, we use an if conditional statement to check whether the value of the number divided by 2 has a remainder of 0. If it does, the method returns true. If not, the else block is executed and the method returns false. To test this method, we will call it from the main method. First, we create an integer variable, and let's call it my number, and assign it the value 20. We then call the isEven method, passing my number as an argument. The result of the method call is stored in a Boolean variable named result, which will hold either true or false. Finally, we print the value of the result using the printLine method. In our example, since my number is 20, the isEven method checks whether 20% 2 equals 0, which it does. Therefore, the method returns true, and this value is printed. The output is true. Now let's move on to another example. For this, we will write a program that calculates the position of students based on their marks and prints their name and position. To do this, we create a class file named position calculation with the main method inside. The program will have two methods, one to calculate the position based on a number and another to print the student's name and their position. First, we create a method named position method that takes an integer parameter number and returns an integer. Inside this method, we use a ladder, which is if then else structure, to determine the value to return based on their input number. If the number is less than 50, the method returns 0, indicating the student has failed. I'm sorry. If for the values between 50 and 60, the method returns 5. For values between 61 and 70, it returns 4. For values between 71 and 80, it will be 3. For values 81 to 90, it returns 2. If none of these conditions are met, meaning the number is between 91 and 100, the method returns 1. Yep. Next, we create a second method named printPosition, which takes two parameters, a string standard name as one word representing the student's name, and an integer position representing their calculated position. This method prints a message combining the student's name and their position in the format, that is, student name is the name and position is position in bracket. To test these methods, we call them from the main method. We declare an integer variable, and the variable is, let's call it getPosition, and assign it the value returned by the position method when we pass 65 as an argument. We then call the printPosition method with the argument James and getPosition, which prints the student's name and position. The output is student name is James and position is 4. We can repeat this process for another student. For example, we pass the value 82 to the position method to get a position, and then call printPosition with the argument William and getPosition. The output for this second call is student name is William and position is 2. I hope you found these exercises helpful for practicing methods in Java. See you in the next lecture. In this lecture, we will continue practicing more exercises involving methods in Java. Let's begin with our first example. We'll create a program that converts a given temperature from Celsius to Fahrenheit and vice versa based on specified conditions, then prints the result on the screen. First, open IntelliJ and create a class file named, let's call it temperature converter, with a main method. The program will have two methods, one for calculating the temperature conversion and another for printing the result. First, we create a method named calculate temperature using public static double calculate temperature, which takes two parameters, temp char, a character representing the unit of temperature, either F for Fahrenheit or C for Celsius, and temperature, a double representing the temperature value to be converted. Inside this method, we declare a double variable result to store the conversion result. We use an if then else statement to determine whether temp char is F or C. If temp char is F, the temperature is converted from Fahrenheit to Celsius using the formula C equal parentheses F minus 32 parentheses close and times 5 divided by 9. The result is then stored in the result variable. If temp char is C, the temperature is converted from Celsius to Fahrenheit using the formula, which is F equal parentheses C times 9 divided by 5 parentheses close plus 32. And by the way, this is just a standard formula for conversion. Now, the converted value is assigned to the result. If temp char is neither F nor C, the result is set to 0. Finally, the method returns the value stored in the result. Next, we create a second method named print result. This method takes two parameters, temp underscore name, a character representing the unit of temperature, either F or C, and result, a double representing the converted temperature. Inside the method, we use system.out.println statement to print the converted temperature and its units, concatenating the result with the temperature unit to form a complete output message. When I say concatenating, meaning reading out of the result. To use these methods, we call them from the main method. We declare and assign values to two variables, temp name, representing the unit of temperature, for example, C for Celsius, and temp value, a double representing the temperature to be converted. For this example, temp name is assigned the value C, and temp value is 80.2, which represents a temperature in Fahrenheit to be converted. We then call the calculate temperature method, passing temp name and temp value as arguments, and store the result in the double variable named calculate result. Next, we call the print result method, passing temp name and calculated result as arguments. When we run the program, it prints the temperature conversion result to the console showing the converted value in Celsius. Nice. Okay, now let's move on to another example where we write a program to check whether a given year is a leap year. Before we begin coding, let's understand what a leap year is and the logic behind identifying it. Just a quick one. A leap year has an extra day, February 29th, I'm sure you know, to align the calendar year with the solar year, the time it takes for Earth to complete its orbit around the sun. Leap years occurs every 4 years, except for years divisible by 100 but not divisible by 400. This means that a year divisible by 400 is a leap year, or a year divisible by 4 but not by 100 is also a leap year. Anyway, to create this program, we start by creating a class file named leap year with a main method. We define a method named check leap year that takes an integer parameter and let's call it year. Inside the method, we use an if statement to check whether the year is a leap year. The method first checks if the year is divisible by 400 or if it's divisible by 4 but not by 100. If either condition is true, it prints that the year is a leap year. If both conditions are false, it prints that the year is not leap year. All right, the percentage operator is used to check divisibility, returning the remainder when one number is divided by another. If a year is divisible by 400, it is considered a leap year, and a program prints that the year is a leap year. If the year is not divisible by 400, but it is divisible by 4 and not by 100, it is also considered a leap year. If neither condition is met, the program prints that the year is not a leap year. Okay. Now, to test this method, we call it from the main method with the variable check year, assigned the value 2019. When we run the program, it prints that 2019 is not a leap year. If we change the check year to, let's say, 2020 and run it again, the program prints 2020 is a leap year. All right, folks, this is about method exercises, practicing more, and I'll see you in the next one. In this lecture, we will continue practicing more examples of methods in Java to enhance our understanding. I really want you to learn how method works in Java. That is why I'm taking you from all these different exercises one by one. All right, let's begin with an exercise where we create a program to convert distance between different units. Miles to kilometers, meters to kilometers, and kilometers to miles, displaying the result on the screen. So open IntelliJ and create a class name, and let's call it distance conversion with the main method. The program will consist of four methods. The first three methods handle the conversion, while the fourth method does what? Any guess? Yes, it prints the result of these conversions. We do have to see what the result is, right? That's why that we need to have the print method. All right, to start, let's create the first method named, let's call it miles to kilometers. This is the static method that accepts a double parameters, miles. The method converts miles to kilometers by multiplying the input value miles by the conversion factor 1.609344. By the way, this is just a standard formula. The result is then returned as a double. Next, we create the second method named, and we'll call it meters to kilometers. This static method takes a double parameters, meters, and converts it to kilometers by dividing the input value by 1000. The result of this calculation is returned as a double. Now, the third method, and we'll call it kilometers to miles, is also static and takes a double parameters, kilometers. This method converts kilometers to miles by dividing the input value by 1.609344 and returns the result as a double. All right, now let's talk about the fourth method, and we'll call it print distance. Is a static void method that takes four parameters. First value of type double, representing the initial value to be converted. Value type of type string, representing the unit of the initial value. Then second value of type double, representing the converted value. And then converted value of type string, representing the unit of the converted value. This method uses system.out.println to print a statement that combines these parameters value, displaying the initial value, its unit, the converted value, and its unit in a clear and concise format. All right, in the main method, we begin by creating a double variable miles and assigning it a value of 400. We then call the miles to kilometers method, passing that miles as an argument. The method returns the equivalent value in kilometers, which we stored in a variable named kilometers. We then call the print distance method, passing four parameters: miles, the string miles, kilometers, and the string kilometers. This prints the conversion result from miles to kilometers on the console. This completes the first part of the example. Beautiful. Okay, now moving on to the second part. We create a double variable meters and I'll assign it a value of 4000. We call the meters to kilometers method, passing meters as an argument. This method returns the equivalent value in kilometers, which is stored in the kilometer variable, effectively overriding its previous value, of course. If you prefer, you can define a new variable instead if you want, but let's keep it consistent. Let's keep the same one. We then call the print distance method passing meters, the string meters, kilometers, and the string kilometers. This prints the conversion result from meters to kilometers to or on the console. So the second part is now complete. Now let's move on to the third part where we assign a value of 200 to kilometers variable and call the kilometers to miles method, passing kilometers as an argument. This method returns the equivalent value in miles, which is stored in the miles variable again, overriding its previous value. As I mentioned before, you can of course use a new variable if you want. All right, anyway, we then call the print distance method, passing the kilometers, the string kilometers, miles, and the string miles. This prints the conversion result from kilometers to miles, where? To your screen, yep, to your console. Okay, when we run the program, it displays the output. 400 miles is equal to 643.7376 kilometers. 4,000 meters is equal to 4 kilometers. And 200 kilometers is equal to 124.2742 to be exact miles. That's it. Um, we will practice another method in the next lecture. So now you should be proud of yourself that you're doing all these calculations and creating these little programs and converting it using Java. In this lecture, we'll continue to practice more exercise involving methods. All right, let's start by writing a program to calculate the perimeter and area of a rectangle, as well as the perimeter and area of a square. Open IntelliJ and create a class file named, and let's call it area perimeter with a main method. This program will contain four methods: rectangle perimeter, rectangle area, square perimeter, and square area. Here are the formulas we'll use for our calculations. The perimeter of a rectangle is calculated as 2 multiplied by the sum of the length and width. The area of a rectangle is given by multiplying the length and width, right? The perimeter of a square is 4 times the length of one side, while the area of a square is the side length squared. Well, all these formulas are standard, and we are not, of course, changing anything here. I'm sure you know and remember these formulas. All right, so first we create a method name, and we'll call it rectangle perimeter. This is a public static method that takes two integer parameter, length and width. The method returns an integer value calculated by multiplying 2 by the sum of length and width. This value represents the perimeter of a rectangle. Next, we define another public static method and name it rectangle area. That also takes two integer parameters, length and width. This method calculates the area of a rectangle by multiplying length and width, and then returns the result as an integer. Okay, then we create another method named square perimeter. This method is also public and static, taking a single integer parameter named side. Then it returns the perimeter of a square by multiplying side by 4. Similarly, we create a method named square area that takes an integer parameter side and returns the area by multiplying side by itself. With our methods defined, we now move to the main method to use these methods. We start by defining three integer variables, right? First one is rectangle length with a value of 5, then rectangle width with the value of 10, and square side with a value of 5. To call the methods and display their results without storing the values in additional variables, we use system.out.println method. For example, to calculate the rectangle's perimeter, we use a call to rectangle perimeter by passing rectangle length and rectangle width as arguments. The result is then read with the string rectangle perimeter and printed. Similarly, We use another statement to calculate and display the area of the rectangle by calling rectangle area with the same arguments. For the square, we calculate and print the perimeter using a call to square perimeter and square side as the argument. We also calculate and print the square's area using a call to square area with square side. Running the program produces the output: rectangle perimeter is 30, rectangle area 50, square perimeter 20, and square area 25. Beautiful. All right, guys, I hope you have learned a lot about the methods. I've used all different examples in these methods, and I want you to try some of your own to convert and create your own methods. In this lecture, we will learn the concept of method overloading in Java, building upon our previous discussion on methods and their applications. Method overloading occurs when a class contains multiple methods with the same name but different parameters declaration. This allows a single method name to be used for various tasks by accepting different sets of parameters. Java uses the input parameters provided when a method is called to determine which version of the overloaded method should be executed. To understand method overloading, we need to discuss the concept of method signature. In Java, a method signature consists of a method's name and its parameters, their number, types, and the order in which they are declared. It is important to note that the return type and the names of the parameters themselves do not form part of the signature. Therefore, the combination of the method name and its parameters list makes a method signature unique. This uniqueness is how the Java compiler determines if a method is correctly overloaded. All right. For example, consider a method with one integer parameter. If we define another method with the same name but with a single float parameter, it constitutes a valid overload method because the parameter types differ. Similarly, if a method has two parameters of a particular type and another method with the same name has a different number or order of parameter, it will also be valid. However, if two methods have the same number and type of parameters in the same order but different return types, it will not be considered a valid overload and will cause a compiler error. The parameter list is the deciding factor for method signature uniqueness, not the return type. The benefit of method overloading include code reusability, as you can use the same method name for different tasks by varying parameters. It improves readability, allowing for more intuitive and consistent method naming across similar tasks. It also ensures type safety by providing different implementation for various data types, ensuring methods can be tailored to specific needs while maintaining a consistent interface. To illustrate a method overloading, let's consider an example. We start by creating a class name. We call it method overloading with a main method. First, we define a method named add that accepts two integer parameters. Inside this method, the sum of the two parameters is printed along with the message indicating that this is the method with the two parameters. We then define another method with the same name, add, but this one takes three integer parameters. This a second method calculates the sum of three parameters and prints it, along with the message that this is the method with three parameters. By having two methods with the same name but different parameters list, we have successfully demonstrated method overloading. When we call the add method from the main method, passing two arguments, such as 10 and 20, the Java compiler automatically selects and executes the version of the method that accepts two parameters. Similarly, when we call add again but pass three arguments, such as 100, 200, and 400, the compiler selects the method with three parameters. Upon running the program, the output clearly distinguishes between the two calls. The first method outputs a method with two parameters, 10 and 20, while the second outputs method with three parameters, 100, 200, and 400. All right, I hope this lecture has deepened your understanding of method overloading in Java. Thank you, and I'll see you in the next lecture. In this lecture, we will practice some examples of method overloading. So for this, we'll create a program that calculates the area of different shapes, rectangle, square, triangle, and circle using a single method named area, but with different parameters to demonstrate method overloading. To start, let's briefly overview the formula we will use for each shape. The formula to calculate the area of rectangle is length times width, where length and width are the dimensions of the rectangle. For square, the formula is side times side, right? Where side is the length of one of the square's sides. Now for the rectangle, the formula is zero point 0.5 times base times height, where base represents the base of the triangle and height is the height of the triangle. Finally, for the circle, the formula to find the area is pi times, where pi is approximately 3.14 and the radius is the distance from the center of the circle to its edge. Now, we'll create a program to implement these calculations. First, open IntelliJ and create a class named Shapes with the main method inside it. In this class, we will implement method overloading by creating four methods named area. Each method will calculate the area of a different shape: rectangle, square, triangle, and circle. The first area method will accept two parameters of type double, length and width. It calculates the area of a rectangle by multiplying length by width and returns the result. The second area method will take one integer parameter, side, and calculates the area of a square by multiplying side by itself. This method is overloaded since it has a different parameter signature, one integer parameter, compared to the first method, two double parameters. The third area method accepts three double parameters: base, height, and shape. It calculates the area of a triangle using the formula 0.5 times base times height by multiplying the shape, representing 0.5 by the base and height. This method is overloaded as well as it has three parameters, distinguishing it from the previous methods. The fourth area method takes one double parameter, radius. It calculates the area of circle using the formula 3.14 times radius, and returns the result. This method is also overloaded as it differs from the previous method in terms of the number and type of parameters. Next, we call these methods in the main method to see them in action. Okay, we use print statement to display the result of each calculation. For example, we call the first area method to calculate the area of the rectangle by passing two arguments, 30 and 20, representing the length and width, respectively, of course. We then call the second area method to calculate the area of a triangle by passing an integer argument of 30. Next, we call the third area method to calculate the area of square, 50 for the base, 10 for the height, and zero point 0.5 as the multiplier for the area calculation. Finally, we call the fourth area method to calculate the area of a circle by passing the radius of 40. The output is displayed as area of rectangle, 600, area of triangle, 900, area of square, 250, area of circle, 5024. So, in conclusion, we see how method overloading allows us to use the same method name area for different shapes, with each method handling different parameters to perform the appropriate calculations. All right, I hope you learned something useful again in this lecture, and I'll see you in the next one. Method overloading exercise part 2. In this lecture, we will continue practicing examples using method overloading. For this, we will write a program that demonstrates the overloading of a method called concatenate, which will concatenate strings in different ways depending on the parameters passed. Well, concatenation is basically reading from an input. Okay, so to start, we will define two overloaded versions of the concatenate method. The first version will take two string parameters, s1 and s2, and return their concatenation. This simply means combining the two strings by appending s2 to the end of s1. The second version of the concatenate method will take three parameters, two strings, s1 and s2, and a separator string. This method will return a new string that is the result of concatenating s1, followed by the separator, and then s2. Let's begin creating this program by opening IntelliJ and creating a class named concatenation strings. Inside this class, we create a main method to serve as an entry point for our program. Next, we implement method overloading by defining the two concatenate methods. The first concatenate method is defined to accept the two string parameters, s1 and s2. Inside the method, it simply returns the result of concatenating s1 and s2 using plus operator, which appends s2 to s1 and creates a new string. This method allows us to combine two strings into one. The second concatenate method accepts three parameters, s1, s2, and a separator string. This method returns a new string that combines s1, the separator, and s2 in that order. The plus operator is used again to concatenate the strings, adding the separator between s1 and s2. This version of the method allows us to create a combined strings with a separator inserted between the two strings. Now we call these overloaded methods in the main method to see how they work. We use system.out.println to print the result of each method call. First, we call the version of concatenate that takes two parameters. We pass nixwhere as the first argument and company as the second argument. This method calls combines the two strings without any separator, resulting in the output nixwhere company, which is then printed to the console. By the way, nixwhere company is something I just made up, so you could make up any company of your choice. Next, we call the version of concatenate that takes three parameters. We pass nixwhere as the first argument, company as the second argument, and dash dash or double hyphen as the separator. This method combines the two strings with the separator placed between them, resulting in the output, which is nixwhere dash dash company, and that will be printed on your console. When we run the program, we see this output. Concatenation without separator, nixwhere company, and then concatenation with separator, nixwhere dash dash company. This shows how the Java compiler differentiates between overloaded methods based on the number of parameters passed to them. I hope this example helps clarify the concept of method overloading in Java. Method overloading exercise part 3. In this lecture, we will continue practicing method overloading with more examples. This time, we will write a program in Java that converts lengths between centimeters, feet, and inches. The program will include two overloaded methods named convert, which will handle the conversion based on the parameters passed to them. To start, we define two versions of the convert method. The first method accepts one parameter, length, and converts it from centimeters to feet. The second method accepts two parameters, length as a double and unit as the char or character. Depending on the value of the unit, this method will either convert feet to inches or inches to centimeters. If the unit value is neither f nor I, it will return 0. Let's get started by creating the program in IntelliJ. We will create a class named length converter. That's the name we picked, and add a main method inside this class. Now we will implement the method overloading. The first version of the convert method takes a single parameter, length, of type double. Inside this method, we perform the conversion by dividing the length in centimeters by 30.48, as there are 30.48 centimeters in 1 foot, right? Yes. Okay, simple math. Okay, the method then returns the result as a double. This allows us to easily convert any length from centimeters to feet. Next, we create a second version of the convert method, which takes two parameters, a double length and a char unit. This method determines which conversion to perform based on the value of the unit. If the unit is f, it converts the length from feet to inches by multiplying the length by 12. Since there are 12 inches in 1 foot. Yep. If the unit is I, it converts the length from inches to centimeters by multiplying the length by 2.54. And since 1 inch is equal to 2.5 centimeters. If the unit value is neither f nor I, the method returns 0. Yes. Now we will call these overloaded methods in the main method. We use system.out.println to display the result. First, we call the method that converts centimeters to feet by passing the value 10. This method returns the converted value, which is then concatenated with a string and printed to the console. Concatenation again is read from somewhere. The output shows the conversion result in feet. Next, we call the second convert method with two arguments, 10 and f. This method checks the value of the unit. Since the value is f, it converts the length from feet to inches. The result is then printed to the console, displaying the converted values in inches. Finally, we call the second convert method, again with the arguments 10 and I. This time the method checks the value of the unit. Since the value is I, it converts the length from inches to centimeters. The result is printed to the console showing the conversion result in centimeters. Beautiful. So when we run the program, we get this output. 10 centimeters is equivalent to 0.32808 feet. 10 feet is equivalent to 120 inches. 10 inches is equivalent to 25.4 centimeters. This shows how method overloading allows us to use the same method name for different tasks based on the parameters passed. So I hope this example helps you better understand method overloading again in Java. I'm providing as many examples as possible. So thank you for your attention. I'll see you in the next lecture. Method overloading exercise, part 4. In this lecture, we'll continue practicing examples using method overloading in Java. Now this time we'll create a program that converts seconds to minutes and also minutes to hours. Sweet. To achieve this, we will define two methods with the same name, and we'll call it time convert, but with different parameters configurations. The first method will accept a single parameter, int integer space seconds, while the second method will be a non-parametric method that simply calls the first method and returns its string value. Let's begin by creating the program. In IntelliJ, we start by creating a class named TimeConverter and add a main method inside this class. We will then implement method overloading for our TimeConvert methods. First, we create the parametric TimeConvert method using public static string TimeConvert parentheses int integer seconds parentheses close. Inside the method, we declare an integer variable named calculateMinutes that stores the calculated number of minutes by dividing the input seconds by 60. This operation helps to convert seconds into full minutes. Next, we create another integer variable named remaining seconds to capture any remaining seconds that do not make a full minute. For example, if we convert 70 seconds into minutes, we will get 1 minute and the remaining will be what? 10 seconds. Yes, that will be captured by this variable. The remaining seconds are calculated by using the modulus operator, which is percentage, which returns the remainder when seconds is divided by 60. We then return a string that combines calculated minutes and remaining seconds, separated by M and S. The output will be formatted as XMYS, where X represents the number of minutes and Y represents the number of seconds. Yep. Next, we create the second overloaded method using public static string TimeConvert and parentheses open close. This non-parametric method calls the parametric TimeConvert method with a hard-coded value of 12350 as the argument. The Java compiler automatically recognizes this as a call to parametric version of the method. The value is passed to the second parameter in parametric method, which then calculates the minutes and remaining seconds and returns the formatted string. The non-parametric method receives this string and then returns it. In the main method, we call the non-parametric TimeConvert method and store the return value in a string variable named result. We then print the result using the println method. When we run the program, it will display the result in minutes and seconds. To extend the program to also calculate hours, we modify the parametric TimeConvert method. We introduce an integer variable named calculateHours that stores the calculated number of hours by dividing the total minutes by 60. Additionally, we create another integer variable named remaining minutes to capture any remaining minutes that do not make complete hour. This is done using the modulus operator percentage to find the remainder when minutes are divided by 60. We then update the return statement to include calculate hours and concatenate H to represent hours, minutes, seconds, right? The final output for an input be something like 3 hours, 25 minutes, and 50 seconds. Beautiful. Method overloading exercise part 5. In this lecture, we will continue practicing examples using method overloading in Java. This time, we will create a program that calculates and displays the mileage and speed of a car. We will use a class named, we call it car, that contains 3 overloaded methods, all named car functions, with a return type of string. The first method will calculate car's mileage based on the distance traveled and the amount of fuel consumed, and then return a string displaying the result. The second method will calculate the car speed based on the distance traveled and the time taken, returning a string with the result. The third method will call both of the first 2 methods and combine their results with a line break in between, returning a string that displays both the mileage and the speed. Nice, right? Okay, let's get started by creating this program. In IntelliJ, we create a class file named and we'll call it car and add main method to this class. We then proceed to implement method overloading. And for that, the first method is defined as public static string car function, parentheses, double distance, comma, double fuel, and close it with parentheses. Inside this method, we calculate the mileage by dividing the distance by the fuel. The result of this calculation is concatenated with the string mileage to display the output, followed by kilometers by liters to indicate the units. The method then returns this concatenated string. This method is responsible for calculating and displaying the mileage of a car based on the given distance and fuel consumption. Next, we create the second method, public static string car functions, double distance, comma, int for integer, time, and close the parentheses. This method calculates the speed by dividing the distance by the time. The result is concatenated with the string speed and followed by kilometers per hour to indicate the units. The method then returns this string, displaying the speed of the car based on the given distance and time taken. The third method is defined as public static string car function and parentheses closed. This method does not take any parameters inside its body. It calls the first car functions method with arguments 100 for distance and 5.0 for fuel to calculate the mileage. It then concatenates the result with a new line character represented by backslash lowercase n to separate it from the next result. The method then calls the second car function method with arguments 200 for distance and 2 for time to calculate the speed. The result of this second call is concatenated with the first result, creating a combined strings that displays both the mileage and speed results. To show how these methods work, we call the third method from the main method. We create a string variable named result and assign it the return value of the car function method call. Since we are not passing any parameters, the Java compiler recognizes that we are calling the non-parametric version of the overloaded method. This method in turn calls the other two car function methods internally, concatenating their results. The resulting string is then stored in the result variable. Finally, we use system.out.println and then parentheses result variable inside of it and close the parentheses to print the value of result variable to the console. So when we run the program, the output displays as follow. It will be mileage 20.0 kilometers per liter. Next line will be speed 100 kilometers per hour. So you see we covering both by the liters or fuel or by the time. I'll see you in the next lecture. Method overloading continues with exercise part 6. In this lecture, we'll continue practicing examples using method overloading in Java. This time, we will create a program that stores and retrieves information about the person using overloaded method. We will have a class named, let's say, person, with 3 overloaded methods, all named person info. The first method will store personal information, including the person's name, age, and address. The second method will store professional information such as profession, company, and experience, and then both sets of information will be returned as strings and displayed in a specific format. The third method will combine both personal and professional information by calling the other two methods and returning the combined result as a single string. All right, perfect. Let's begin by creating the program. In IntelliJ, we create a class file named person and add a main method to it. We then implement method overloading by defining 3 different person info methods. The first method, public static string personal info parentheses string name integer age string address and close it with parentheses. Accepts three parameters, a string parameter name representing the person's name, an integer or int parameter age representing their age, and a string parameter address representing their address. Inside the method, we construct and return a string that includes this information formatted perfectly. The string includes person information, followed by the person's name, age, and address, each on its new own line. To format the output, we use \n to insert line breaks, and plus operator concatenates the string parts. The second overloaded method, public static string person info parentheses string profession, comma string company, comma integer experience, and close it with parentheses. Now these takes three parameters as well. A string parameter profession representing the person's profession, another string parameters company representing the company they work for, and an integer parameter experience representing their years of experience. This method also constructs and returns a formatted string containing their personal information. Now the output includes the person's profession, company, and experience, each on a new line with appropriate labels and formatting using \n and the plus sign. Let's move on to the third overloaded method, which is public static string person info and parentheses open close. Is a non-parametric method that calls both of the other two person info methods. It first calls the first person info method with the value John, name, 35, age, and New York, address, and then calls the second person info method with the value IT, the profession, Nixware, the company, and 15 as years of experience. The method concatenates the result of these two calls, separating them with a new line character using \n and then returns the combined string. In the main method, we only need to call the non-parametric person info method, as it internally calls the other two methods. We create a string variable named getInfo and assign it the value returned by the call to personInfo. Then we use system.out.println and with the parentheses of getInfo inside of it to print the combined string of personal and professional information to the console. So when we run the program, the output displays the person's complete information formatted such as person information, name is John, age is 35 years, address is New York, profession is IT, company Nixware, and experience 15 years. You see each one of that information is in its own line and formatted perfectly. Method overloading exercise part 7. In this lecture, we will dive into a more complex example by creating a Java program that calculates the age of a person in terms of years, months, and days from their birth date to the current date. The program will also find how old a person will be on a future date and determine their age at a specific event such as marriage, important milestones, etc. Additionally, it will convert the age to various units like total years, months, or days. Nice. Okay, let's begin. Let's first understand the formula for calculating age. To determine a person's age in years, months, and days, we find the differences between their birth year, month, and day, and the current year, month, and day. The formula for finding the difference in years is years equal current year minus birth year. For months, it is calculated as months equal current month minus birth month. And for days, it is days equal current day minus birthday. To convert the total age difference into days, we use the formula age in days equal parentheses years times 365, close the parentheses, and then use plus operator, and then again opening parentheses, months times 31, close the parentheses, then plus operator again, or sign plus, then days. This provides a total difference in days. Once we have the total days, we convert them back to years, months, and days using these formulas. And those are for years, we calculate it using y equal d divided by 365, where d is the total days and 365 is the total number of days in a year, right? To get the remaining months from the years, we use m equal parentheses d minus y times 365, close it with parentheses, and divided by 30, where 30 is the average number of days in a month. Finally, for the remaining days, we use d equal, start with parentheses, d minus y times 365 minus m times 30, and close it with parentheses. Now let's create this program in IntelliJ. We start by creating a class file named age and defining the main method. Our program will include three overloaded methods named findAge. The first method calculates the difference between the birth date and the current date, converting everything into days. The second method converts these days into years, months, and days. The third method ensures that the values are positive, converting any negative values to positive using multiplication by -1. So the first method, public static int integer find age, parentheses open, integer birth year, comma, integer current year, comma, integer birth month, comma, integer current month, comma, integer birthday, comma, integer current day, and close it and close the parentheses. This takes six parameters, right? Birth year, birth month, birth day, and current day. Now inside the method, we calculate the differences as follows. Integer years equal birth year minus current year, and then semicolon. Integer months equal birth month minus current month. Then we have integer days equal birthday minus current day. We then convert these values into total days using integer age in days equal parentheses year times 365, close the parentheses, plus opening parentheses months times 31, closing parentheses, plus days, and return age in days. The second method, public static integer find age, parentheses integer age value, integer y, integer m, and char for characters ch, close the parentheses, takes four parameters: age value, total number of days, y for years, m for months, and ch, a character indicating whether to convert to years, months, or days. Now using if-else condition, the method checks the value of ch and performs conversions accordingly. If ch is y, we calculate age value divided by 365, right, to get the number of years. If ch is m, we use age minus y times 365 as a whole within the parentheses and divided that by 30 to get months. If ch is d, we use age value minus y times 365 minus m times 30 and put this whole equation in parentheses to get the days. The method returns the converted value. The third method, public static integer find age, opening parentheses, integer check negative, closing parentheses. Now this takes one parameter. It checks if check negative is less than 0. If true, it -1 multiplies check negative to convert it to a positive value and then returns the result. The main method we first called the find age method with parameters representing a person's birth date and the current date to get the total days of age. We store this value in a variable called total days. Next, we use this total days value in the second find age method to convert it into years, storing the result in get years. We then call the second method again with total days and get years to get the months, storing it in get months. Finally, we call the second method again to get the days, using total days, get years, and get month. To print the result, we use system.out.println, right? And then we'll put that all the variables starting with parentheses get years plus double quote years, double quote close plus get month plus months plus get days plus days, and we'll close it with parentheses. After running the program, we see the output 30 years, 6 months, 17 days. Excellent. Now I am very hopeful that you have the great understanding of using overloaded methods in Java. In this lecture, we will discuss about switch statement in Java. We already learned about if then else, ladder if then else, and nested if then else conditions in detail, and also practiced some of their exercises in previous lectures. I think you should have now a better idea of how to control the flow of Java program, right? Now we come forward and discuss another important control statement, which is the switch statement, as I said earlier. So, the switch statement in Java is used as a control structure to execute one of several branches of code based on the value of an expression. It provides a way to handle multiple cases or conditions in a more efficient and readable way compared to using a series of if-else statements. The switch statement has gone through many enhancements since Java 8, but we will be looking at traditional switch statement to start. Now we see that the syntax for the switch statement, we start with the keyword switch. That's followed by the value we want to check in parentheses, followed by the opening curly braces, which starts to switch code blocks. And then there's the closing curly braces. Within the curly braces, there are some new keywords we haven't seen before: case, break, and default. The case keyword is used with the switch statement for comparison. The switch value case A essentially means in the case that value equals A, execute this code. If it doesn't, then move on to check the next case. The break keyword tells us which statement to terminate any further checks. The break statement is optional in Switch, and we will talk about it more shortly. So here's the default keyword indicates that this code should be executed if none of the preceding conditions are met. Now we will see the comparison of switch and if then else statement. So the if then else statement and the switch statement are both used to control the flow of execution in a Java program. But there are some key differences between the two, like expression type. The expression in a if-else statement can be of any type, including integer, float, double, or even an object, while the expression in a switch statement must be of primitive data type such as int, char, or short, or a wrapper class such as integer character or short. All right, let's talk about multiple condition. With an if-else statement, you can write multiple conditions to handle different cases. While with a switch statement, you can handle multiple cases, but only one expression is evaluated and compared to each of the case value. Then readability. The switch statement can be more readable when handling multiple cases compared to a series of if-else statements, especially when dealing with a large number of cases. All right, let's talk about performance. The performance of a switch statement is generally faster than an if-else statement, especially when dealing with a large number of cases. All right, there are several advantages of using the switch statement in Java over the traditional if-else statements. Those are starting with readability. Switch statements can make code more readable, especially when dealing with a large number of conditions, by grouping the conditions together in a clear and concise way. And another advantage is it's a cleaner code. Switch statements can help to make code more organized and easier to maintain by separating the conditions and their associated code blocks into distinct sections. Another one is easy to use. The switch statement is easy to use and requires less typing compared to if-else statements. Also, better handling of multiple cases as another advantage. The switch statement is especially useful when dealing with multiple cases, as it provides a simple and readable way to handle each case without the need for nested if else statement. Another advantage of switch is better type safety. The switch statement only allows for certain data types as expressions, whereas if else statements can accept any expression, which can lead to type mismatch errors. All right, another one, better error handling. The switch statement provides the default case, which can be used to handle unexpected cases, providing a way to catch potential errors. Overall, the switch statement can greatly improve the readability, performance, and maintainability of your code, and it is especially useful when dealing with multiple cases. While the switch statement has several advantages, it also has some limitation like limited data types. The switch statement only support a limited number of data types as expressions, including byte, short, integer, and char or character values. If you need to use a different data type, you will need to use if-else statement instead. Also, another one is no range checks. The switch statement does not allow for range checks, which can be performed using if-else statements. If you need to check whether a value is within a certain range, you will need to use if-else statement instead. Also, no use of expression. The switch statement does not allow for expressions to be used as cases, only constant values. This can limit its flexibility and compared to if-else statements, which can accept any expression. Also, it does not have support for null values. The switch statement does not support null values expressions, which can cause issues if you need to handle null values in your code. Then there is unpredictable behavior. The switch statement can have unpredictable behavior if a break statement is omitted from the end of a case block, causing execution to fall through to the next case. This can be a source of bugs and should be avoided. Another disadvantage is no short circuit evaluation. The switch statement does not provide short circuit evaluation, meaning that all the cases are evaluated even if a match is found. This can lead to a decrease in performance, especially when dealing with large number of cases. I think now you understand basic syntax and also understand the comparison between switch and if then else statement. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will practice some switch exercises. We already learned about the switch statement's basic syntax and the comparison between switch and if then else statements, right? Now we see one example using both if then else and switch statements. So we write a program to determine the day of the week based on the value of the day. If day is 1, the output should be Monday. If the day is 2, the output should be Tuesday. And if the day is 3, the output should be what? Wednesday, and so on. If the value of the day is not one of these three values, the output should be invalid. Now let's start creating this program. Of course, for this, open IntelliJ. Here we create a new project named Switch. Then inside this project, create class file named mySwitchStatements. Then create a main method inside this class by writing shortcut PSVM. Now first we create this example using an if then else statement. And we create the same example using the switch statement to see a clear picture of their differences. For this, we define an integer variable day with the value 3. Then we write if parentheses day equal to 1, open curly braces, system dot out dot print line, parentheses double quote Monday, semicolon close curly brace. This line of code checks if the condition day equals to 1 is true. The code inside the curly braces will be executed and prints the string Monday to the console using the system dot out dot print line statement. Then next write else if parentheses a day equal to 2 open curly brace system dot out dot print line parentheses double quote Tuesday semicolon close curly brace. It is used when the previous if condition is false and a new condition needs to be checked. In this case, the else if block checks if the value of the variable day is equal to 2. If the condition day equals to 2 is true, the code inside curly braces will be executed and prints the string Tuesday to the console using the system.out.println statement. The next write else if parentheses day equal to 3 open curly brace system.out.println parentheses double quote Wednesday semicolon close curly brace. It is used when the previous else if condition is false and a new condition needs to be checked. In this case, the else if block checks if the value of variable day is equal to 3. If the condition day equals to 3 is true, the code inside the curly braces will be executed and prints the string Wednesday to the console using the system.out.println statement. All right, the next write else open curly brace. Inside this write system.out.println parentheses double quote invalid day semicolon close curly brace. It is used when catch all previous conditions are false. In this case, the code inside the curly braces of else condition will be executed and prints the string invalid day to the console using the system.out.println statement. Now run it. Here you can see output that is Wednesday. Because the integer variable value is 3, as a result, the third condition that day equals 3 became true. Now we create same example using switch statement. Alright, for this we create separate class with the name mySwitchStatement1 and create a main method inside this class by writing shortcut PSVM. Now we declare integer variable day with a value of 3. Then using switch statement that starts with the keyword switch followed by an expression in parentheses day variable. The expression day is evaluated and compared to each of the case value within the switch statement. Now we first create case by writing case 1 colon then inside case write system dot out dot println parentheses double quote Monday semicolon then break statement and semicolon. So the first case statement checks if the value of day is equal to 1. If the condition is true, the code inside the curly braces will be executed. The code inside the first case statement is a call to the system.out.println method, which prints the string Monday to the console. Then break statement is used to exit the switch statement. If the code for the matching case has been executed, now we create second case by writing case 2 colon then inside case write system dot out dot println parentheses double quote Tuesday semicolon then break statement and semicolon. So the second case statement check if the value of the day is equal to 2. If the condition is true, the code inside the curly braces will be executed. The code inside the first case statement is a call to the system.out.println method, which prints the strings Tuesday to this console. Then break statement is used to exit the switch statement if the code for the matching case has been executed. Now we create third case by writing case 3 colon then inside case write system.out.println parentheses double quote Wednesday semicolon then break statement and semicolon. So the second case statement checks if the value of day is equal to 3. Now, if the condition is true, the code inside the curly braces will be executed. The code inside the first case statement is called to the system.out.println method, which prints the string Wednesday to the console. Then break statement is used to exit the switch statement if the code for matching case has been executed. Yep. Then we write default statement. So the default is used as a catch-all case when none of the previous conditions are true. The code inside the curly braces will be executed. The code inside the default statement is a call to the statement.out.println method, which prints the string invalid day to the console. Now run it. Here you can see the output that is Wednesday because the case 3 value is 3. As a result, the third case that equals 3 became true. All right, folks, I hope you learned something useful. And as always, I'll see you in the next one. In this lecture, we'll practice some switch exercises. We already learned about the switch statement's basic syntax and the comparison between switch and if then else statements. Now we see an example using switch statement. So we write a program to determine to find the size, uses a switch statement to check the value of number and assigns a corresponding value to size based on the matching case. If the value of number is 29, the size is set to small. If the value is 42, the size is set to medium. And if the value is 44, the size is set to large. If the value is 48, 49, or 50, the size is set to extra large. If the value doesn't match any of these cases, the size is set to unknown. Now let's start creating this program. For this, open IntelliJ. Here we create a class file named MySwitchStatement2. Then create a main method inside this MySwitchStatement2 class by writing shortcut PSVM. Now first we write int integer number equal 49 semicolon. Here we declare an integer variable named number and initialize it with the value 49. Then write string size semicolon. Here we declare a string variable named size. Then we start a switch statement that will compare the value of number with several cases by writing switch parentheses number curly brace. Now we start creating cases. For this we write case 29 colon size equals small semicolon then break semicolon. This case will run if the value of number is equal to 29. If the case matches, set the value of size to small and break statement finish the switch statement. Then create next case by writing case 42 colon size equal medium semicolon then break semicolon. This case will run if the value of number is equal to 42. If the case matches, set the value of size to medium and break statement finish the switch statement. Then create next case by writing case 44 colon size equal large semicolon and then break semicolon. This case will run if the value of number is equal 44. If the case matches, set the value of size to large and break statement. Finish the switch statement. Now we define a case that will run if the value of number is equal to 48, 49, or 50. If the case matches, set the value of size to extra large. For this, we write case 48 colon space case 49 colon space case 50 colon, then write size equal extra large semicolon, then break semicolon. This case will run if the value of number is equal to 48, 49, or 50. If the case matches, set the value of size to extra large and break statement. Finish the switch statement. It's actually a shortcut to check multiple cases. We are testing for 48 or 49 or 50. And if any of those are true, the case will run. Then we define a default case that will run if the value of number doesn't match any of the cases above. If the default case matches, set the value of the size to unknown. If this, we write default colon case 49, then write size equal unknown semicolon, then break semicolon. Then close the switch statement by writing closing curly brace. After the closing switch statement, write system.out.println parentheses double quote size colon plus size semicolon. The purpose of this line of code is to display the result of the switch statement to the console by printing the value of the size variable. Now the plus operator is used to concatenate the string size with the value of the size variable to create a complete string that is then printed to the console. Now we run the program. Here is the output that is size extra large because of the value of number is 49, which matches the case 49. All right, I hope you learned something useful in this lecture, folks, and I'll see you in the next one. In this lecture, we will see the difference between traditional and enhanced updating of switch statement. So the switch statement has seen quite a few updates through the years. We're going to explore some of the new features of the switch statement. You may have noticed already that IntelliJ has been trying to get our attention. The switch keyword is highlighted. If we hover over our mouse, that IntelliJ tells us we can replace the switch statement with the enhanced switch. So let's do it. Let's select the replacement enhanced switch statement. So the switch statement has been transformed by IntelliJ. Let's look at these statements side by side. We already introduced you to the switch statement and the syntax that's been used since Java's beginning. This is shown on the left side of this slide. Since JDK 9, the switch has been undergoing enhancements, but to keep it backward compatible, Java has introduced new syntax for this, which is shown on the right side of this slide. When we compare these two statements, the first thing we notice is that the colon after each case label has been replaced with the arrow token, as shown here. There are no breaks in the enhanced switch statement. The enhanced statement doesn't require them. Also notice that it's replaced the multiple case labels. We had a case 48, case 49, and case 50 with a comma delimited list of the values. If we see in the traditional switch, we only declare the size variable, and then inside the cases assign it value. But in the enhanced switch, the string size variable is assigned directly to the switch statement when any case runs. And then the string value inside the switch statement assigns a value to the size variable. Maybe you will agree with me that this new code is easier to read, right? And for beginners, it comes with more control in place to prevent coding errors. You will see the traditional switch statement in code written before Java 14. So this is a fairly new feature in Java. For this reason, it's important to be familiar with both versions. Which one you see used is really dependent on your development and production environments. If your code needs to be backward compatible with earlier versions of Java, then stick to the traditional switch. So let's get back to the code. So let's go over the traditional way of using a switch case statement in an expression, followed by the enhanced switch way. Prior to the enhanced statement, if you wanted the switch statement to return a value, you used a method that returned value. So let's do that. The first thing we'll do is make a new method that takes a string as its single parameter and also returns a string. Let's do that. Public static string, get days opening parentheses, string day name closing parentheses, and curly braces. So we have a new method called getDays, which takes a single string parameters called day name and returns a string value. This is going to be returned as a string. First 3 days of the week, Sunday, Monday, and Tuesday. Then return second and 3 days of the week for the Wednesday, Thursday, and Friday, and then return string last day of the week for the Saturday. So the idea is that this method will receive a day of the week and then return a string representing which part of the week that day is in. And we can use a switch statement to do that. And we can do it in a few ways. But let's look at the traditional way first. I'm going to type this code in, and then we'll talk about it afterwards. Now write switch parentheses, day name, curly braces, case double quote, Sunday, colon. Case double quote, Monday, colon. Case double quote, Tuesday, colon. Return double quote, first 3 days of the week, semicolon. Case double quote, Wednesday, colon. Case double quote, Thursday, colon. Case double quote, Friday, colon. Return double quote, second 3 days of the week, semicolon. Case double quote, Saturday, colon. Return double quote, last day of the week, semicolon. After closing a switch curly brace, write return double quote, nothing, semicolon. Now we are using a string for our switch and case values. The string was one of the few data types you can use with the switch statement. You can see those cases. We surround our test values in double quotes, indicating these are string values. What's really different here is that we are not using a break, but instead we are using a return statement. This works like a break since the code will exit out of both the switch statement and the method at this point. There is no chance to fall through the switch, so we also don't need a default label in this instance. since if the day isn't found, the code will just fall through to the last statement. If we get string nothing back from this method, it means the day was invalid. Now let's go to the main method and call the getDay method. Here we create a string variable with value Tuesday. For this, we write string day equal double quote Tuesday semicolon. Then we write system.out.println parentheses day plus double quote is the plus get days parentheses day double parentheses semicolon. Here we call a method named getDays and pass the day variable as an argument, and concatenate the day variable and the result of the day gets method with the string that describes the relationship with string is the and print the concatenated string to the console using the system.out.println method. Now we run it. See the second output, that is Tuesday, is the first 3 days of the week. Now we will change the day variable to Saturday. Now we will run that again. And here we get Saturday is the last day of the week. Now the enhanced switch case statement gives us another option. First, let's change the switch case statement to enhanced switch. We'll do that what we did before, hovering over the switch keyword and selecting the option to replace with switch expression. As you can see, this preferred a similar transformation on our code, but there is one notable difference. Notice that this code has the return keyword before the switch keyword. This enhancement was previewed in JDK 12 and 13, which experienced improvements due to the previews and became standard in JDK 14. But it's pretty new. Here it's very important to note that this switch statement is really an expression, meaning it resolves to a single value and can be assigned to a variable, or in this example, returned from the method. Let's consider this code side by side. There are some important differences. So again, we can see that the multiple case keywords have been removed in favor of comma delimited list, and the colon is replaced with an arrow token. Let's look at the right side of the arrow token. It's just a string literal. This isn't a statement at all. This kind only complies because we are using it as an expression, meaning we are using the result. In this case, we are simply returning the result from the method, but we could just as easily have assigned it to the local variable. The other important difference is this default label. When the enhanced switch is an expression, meaning it returns a value, and then a default label is required under most conditions. We will be talking about the exception to this rule later. Now test these statements out in code. First, let's rerun our code with this newly formatted method. And to their surprise, it still works. What happens if we leave the default case? This is an interesting comment. IntelliJ doesn't give us a warning, but if we try to run that, we get an exception. The switch expression does not cover all possible input values, so you should always include a default label in the switch expression. All right, folks, I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will practice some enhanced switch statement exercises. We already discussed comparisons between traditional and enhanced switch statements. Now we will develop an example using the enhanced switch statement. For this, we write a program to check a person's level, given an integer number, and then it returns the person's expertise level using a switch statement. Now let's start creating this program. For this, open IntelliJ. Here we create a class file named enhanced switch. Then create a main method inside this enhanced switch class by write shortcut psvm. Now we write string level string semicolon. Here we declare a string variable named level string. Then write int integer level equal 3 semicolon. Here we declare an integer variable named level and initialize it with the value 3. We use the newer syntax for the switch because we want to assign the result of this switch to our level string variable. Let's do this with writing level string equals switch, opening parentheses, level, closing parentheses, and opening curly brace. Case 1, return type double quotes beginner semicolon, closing curly brace semicolon. So we have now handled case 1, which is beginner of the value of level 1. We are going to return beginner from this switch expression and assign it to the variable day of level string. And because we are assigning this switch statement to a variable, we put a semicolon after the switch closing brace, as you can see here. And here we are using the error token instead of a colon, and simply putting the value that's supposed to be returned on the right side of that token. The enhanced switch doesn't have break statements. And if all we are doing it returning a value, we can do it without using curly braces around this code. Now creates other cases by writing case 2, return type double quotes, intermediate semicolon. Case 3, return types double quotes, expert semicolon. Now let's add default case. We have said that anything that isn't 1, 2, or 3 should return failed to learn. So let's add a default return type double quotes, failed to learn semicolon. Next, we'll print that information out in this method after the switch expression. System.out.print line opening parentheses day plus double quotes your level is colon plus level string closing parentheses semicolon. Here we print out the level of the person, and then we print the text that came back from our switch expression. Now we run it. Here you can see the output, that is, your level is expert. In this lecture, we will practice some more exercises using enhanced switch statement. For this, we write a program to check whether given alphabets are vowels or consonants. So our aim to determine whether a given character represented by the variable ch of type char is a vowel or a consonant. For this, we use enhanced switch expression to check the value of ch. If ch is a vowel, program assigns the string value vowel to the type variable. If ch is not a vowel, the program assigns the string value consonant to the type variable. Finally, the program prints the value of the type to the console. Now, let's start creating this program. For this, open IntelliJ. Here we create a class file named enhanced switch 2. Then create a main method inside the enhanced switch 2 class by write shortcut PSVM. Now we write string type semicolon. Here we declare a string variable named type. Then write ch equals single quote z semicolon. Here we declare a character variable named ch and initialize it with the value z. Now we use the newer syntax for the switch because we want to assign the result of the switch to our type variable. Let's do this with the writing type equals switch, opening parentheses, ch, closing parentheses, and opening curly braces. Here we will create multiple cases that we have only one return value if one of them becomes true. In the enhanced switch, if you want to create multiple cases on a single line, we use the case keyword only once and then give it multiple values, separating them using a comma between them. Now we write use a single quote small alphabet, comma single quote alphabet, e comma single quote small alphabet, I comma single quote small alphabet, O comma single quote small alphabet, U comma single quote capital A, comma single quote capital E, comma single quote I, comma single quote capital O, comma single quote capital U, return type double quotes vowel semicolon. So we are going to return vowel from this switch expression and assign it to the variable type. And because we are assigning this switch statement to a variable, we put a semicolon after the switch closing brace. As you can see here, and here's we are using the token instead of a colon and simply putting the value that's supposed to be returned to the right side of that token. The enhanced switch doesn't have break statement. And if all we are doing is returning a value, we can do it without using curly braces and around this code. Now let's add default case. we have said that anything that isn't vowel should return consonant. So let's add default return type double quotes consonant semicolon. Next, we'll print that information out in this method after the switch expression. System.out.print ln for line, opening parentheses, double quotes. This is a plus type, closing parentheses, semicolon. Here we print out the given alphabet is vowel or consonant, leading with given string. Now we run it. Here we can see the output that is, this is a consonant. So when the program executes, the switch expression is evaluated. Based on the value of CH, if CH matches any of the cases of any value of first case, the corresponding string value is returned by the case expression, which is then assigned to type. If CH does not match any of the cases, the default case is executed, and consonant string is returned by the default expression, which is then assigned to type. So here the value of ch variable is z. So default case matches the consonant string value is returned by the case expression, which is assigned to type variable. Finally, the program prints. This is a consonant to the console using the system.out.println method. Now we will create code block of default case. For this, we remove the default case and then again write default. A return type opening curly braces. String response equals double quotes consonant semicolon. Return response semicolon. This kind of method tries to return a string using the data that was passed to the method, and the string is consonant. But IntelliJ is flagging that line's response as an error return outside of enclosing switch expression. That's kind of hard to understand. But the fact is that if you are going to use a code block like this in a switch expression, we need a new keyword. We need to use yield and not return. So let's change our code and see if that works. Yield response semicolon. The word yield is a new keyword introduced for the switch expression to return a value back. So let's run. Here we get the same result as previous. In Java, yield is a keyword introduced in Java 14 and is used in conjunction with the new switch statement. Yield is used to specify the value that should be returned by a switch expression, and it works similarly to the return keyword. On the other hand, the switch statement in Java is used to execute different actions based on different conditions. It evaluates an expression and compares the value of expression against different cases. If the expression matches any of the cases, the corresponding action is executed. While both yield and switch statements can be used to control program flow based on different conditions, they have different purposes. The switch statement is used for conditional branching, while yield is used for returning values in a new switch statement. In other words, yield is a new feature introduced to enhance the functionality of the switch statement. All right, now we will see another example. So we write a program to find the area of an ellipse, the area of trapezoid, and the area of parallelogram. Now, first we talk about ellipse, trapezoid, and parallelogram. So an ellipse is a closed curved geometric shape that resembles a stretched or squashed circle. It's a conic section formed by the intersection of a plane and a cone, where the plane is not parallel to the base of the cone. An ellipse has two focal points, which are equidistant from the center of the ellipse. The major axis of an ellipse is the longest diameter, while the minor axis is the shortest diameter perpendicular to the major axis. Area of an ellipse formula is area equal pi multiply a multiply b, where a and b are the lengths of the semi-major and semi-minor axes. Ellipses are widely used in mathematics, physics, and engineering, including in the field of optics, astronomy, and celestial mechanics. Then trapezoid. So trapezoid is a quadrilateral with at least one pair of parallel sides. In other words, it is a four-sided polygon with one set of parallel sides. The parallel sides are called the bases of the trapezoid, and non-parallel sides are called the legs. The height of the trapezoid is the perpendicular distance between the two bases. The area of trapezoid formula is area equal parentheses a plus b multiply h divided by 2, where a and b are the lengths of the two parallel sides and h is the height of the trapezoid. Trapezoids are commonly used in geometry and engineering to calculate areas and volumes of various shapes. Then parallelogram. So a parallelogram is a four-sided polygon with opposite sides parallel and congruent, equal in length to each other. The opposite angles of a parallelogram are also congruent. The adjacent angles of a parallelogram are supplementary, meaning they add up to 180 degrees. The diagonals of a parallelogram bisect each other, meaning they divide each other into two parts. All right, the area of parallelogram is area equal base multiply height, where the base is the length of one of the parallel sides, and the height is the perpendicular distance between the parallel sides. The parallelograms are used in geometry and trigonometry, as well as in various fields of engineering and physics. They are common in architecture and construction, where they are used in the design of walls, roofs, and floors. They are also used in mechanics, where they represent the forces acting on a rigid body in equilibrium. Now let's start creating this program. For this, we create a class file named enhance switch 3. Then create a main method inside this enhance switch 3 class by writing shortcut PSVM. Now we are declaring several variables to store the input value and results of an area calculation. For this, we write string shape equal double quote ellipse semicolon. The variable shape is a string that represents the shape of which we want to calculate the area. Then we write double major x's equal 11, comma minor x's equal 16, semicolon. The variables major x's and minor x's represents the major and minor x's respectively of the ellipse. Then write double top base equals 0, bottom base equals 0, comma height equals 0, semicolon. The variable top base and bottom base represents the top and bottom bases, respectively, of course, of the trapezoid, and the variable height represents the height of the trapezoid. All right, then we write double base equals 0, comma height para equals 0, semicolon. The variable base and the height para represents the base and height, respectively, of the parallelogram. Then write a double area result semicolon. Finally, the area result variable will store the area of the shape that we are calculating. Now we use the newer syntax of the switch because we want to assign the result of this switch to our area result variable. Let's do this switch with writing area result equals switch, opening parentheses, shape, closing parentheses, and opening curly brace. Now we create first case by writing case double quote ellipse return type 3.14 multiply major x's multiply minor x's semicolon. In this case, when the value of shape is ellipse, the program will calculate the area of an ellipse using this formula, where major x's and minor x's are the length of the major and minor axes of the ellipse, respectively. The calculated result will be returned and assigned to the variable result. Because we are assigning this switch statement to a variable, we put a semicolon after the switch closing brace, as you can see here. Then we create a second case by writing case double quote trapezoid return type double open parentheses top base plus bottom base close parentheses divided by 2 close parentheses multiply height semicolon. In this case, when the value of shape is trapezoid, the program will calculate the area of trapezoid using this formula. Here the expression first calculates the average of the top and bottom bases, that is the parallel side, and then multiplies the result with the height to get the area of trapezoid. Then calculated result will be returned and assigned to the variable result. Then create second case by writing case double quote parallelogram return type base multiply height para semicolon. In this case, when the value of shape is parallelogram, in this case the code is calculating the area parallelogram using this formula. Then calculated result will be returned and assigned to the variable result. Now let's add default case. We have said that anything that isn't match of these three shapes should return 0. So write default return type 0 semicolon. Next, we will print that area result in this method after the switch expression. System.out.print line opening parentheses shape plus double quote colon plus area result closing parentheses semicolon. This line of code prints the output of the program to the console. The output consists of the name of the shape that was computed, followed by a colon and a shape, and then the value of the computed area. The name of the shape is stored in the shape variable, while the value of the computer area is stored in the area result variable. Now run it. Here is the output after a successful run. It calculates the area of an ellipse because the shape variable has the value ellipse, which matches the first case. It then returns the calculated result restored in the area result variable. Alright, now we will calculate the area of parallelogram. For this, first we change the value of the shape variable to parallelogram. Given the value 0 to the variables of ellipse that are major x's and minor x's, then we given value to the parallelogram variable that are base equal 11 and height para equal 14. Now run it. Here the output after a successful run. It calculates the area of parallelogram because the shape variable has the value parallelogram, which matches the third case. It's then returned the calculated result stored in the area result variable. Now we will see another example. So we write a program that takes a username as an input and returns a corresponding password for the user. So for this, we'll create a parametric method, and inside this method, we use enhanced switch statement to match the username with the predefined password. If the username is matched, the corresponding password is returned. If the username is not matched, the switch statement goes to the default case, where an error message is assigned to the password variable, and the control flow is transferred back to the caller method using the yield keyword. All right, now let's start creating this program. For this, we create a class file named enhanced-switch4. Then create a main method inside the enhanced-switch4 class by write shortcut.psvm. Then write public static string get password parentheses string username curly brace. We define a static method named get password with the string input parameters username. This method returns a string value. Then we write string password semicolon. Here we declare a string variable named password. Now we use the newer syntax for the switch because we want to assign the result of this switch to our password variable. Let's do this with writing password equals switch, opening parentheses, username, closing parentheses, and opening curly brace. Now we create first case by writing case double quote doe return type double quote A123 semicolon. This case checks if the value of the username string variable is equal to the string value doe. If the condition is true, then the statement inside case is executed, which returns the password for the user with their username doe and stored value A123 in the password variable. Because we are assigning this switch statement to a variable, we put a semicolon after the switch closing brace, as you can see here. All right, then we create second case by writing case double quote John return type double quote F143 semicolon. This case checks if the value of the username string variable is equal to the string value John. If the condition is true, then the statement inside case is executed, which returns the password for the user with the username John and stored value F143 in the password variable. You got that, right? Okay, let's do the same thing with the third one. By writing case double quote Jane, return double quote B122. just the random number of the password I'm picking, semicolon. This case checks if the value of the username string variable is equal to the string value Jane. Again, if the condition is true, then the statement inside is executed, and then return the password for the user with the username Jane and the stored value of the password, which is B122. All right, now let's add a default case. We have said that anything that isn't match of these three username, then it should return string, and that is invalid username. Now here we will create code block of default case. For this we write a default return type opening curly brace. String password equals double quote invalid username semicolon. Yield password semicolon. So in this code block, the default case is executed when none of the previous case matches the value of username. In this case, the variable password is assigned the string value invalid username. Then the yield statement is used to return the value of the password as a result of the switch statement. The outside of switch statement, we write return password semicolon. Here the return value of the password from the method. All right, now we call this method in the main method. For this, we first go into the main method and first we declare a string variable named username and initialize it with the value John. For this, we write string username equal double quote John semicolon. Then we call the get password method and passes in the username variable as an argument to retrieve the password for the value John as username, and to store the return result of this method we use as a string variable password. So we write string password equal get password parentheses username semicolon. All right, remember that these two password variables with the same name are not related to each other because they were created in two separate methods and they cannot be overwritten. If they were created in the same method, the IntelliJ would display an error. These variables are also called local variables. All right, finally, it prints out the username and password variable to the console using the println method of the system.out object. The output will display the username and password values separated by a colon. For this, we write system.out.println parentheses username plus double quote colon plus password semicolon. Now we are running it. Here is the output after a successful run. That is John colon F1 to 43. Because the string variable username is set to John, it is passed a parameter to the method, and the username variable is used as an expression in the switch, which matches with cases and the value matches with the second case. And then switch returns the value of the second case and stored as in the password variable. Then the method returns this password variable value, which we print in the main method using println object. I hope, folks, you learned something useful in this long lecture, I must say, and I will see you in the next one. In this lecture, we will talk about nested switch statement in Java. In the previous lectures, we already discussed basic switch concepts and practiced some of their examples. Now we will see more advanced concept of it, that is nested switch. So in simple words, a switch statement inside another switch statement is called a nested switch. We use nested switch statements in Java to handle complex situations where we need to check multiple conditions. A nested switch statement allows us to choose a specific case based on multiple conditions, which can simplify our code and make it more readable. Nested switch statements can be useful in situations where we need to evaluate different combinations of conditions. For example, if we want to calculate the grade for a student based on their score in two exams, we could use a nested switch statement to evaluate each possible combination of exam scores and assign a grade accordingly. This can be much more efficient way than using a long series of if then else statements or multiple levels of nested if statements. Now we will see its syntax in Java. Here you can see its syntax. The outer switch statement starts with the keyword switch and is followed by an expression, parenthesis, expression 1, in this case inside the parentheses. The expression is evaluated to determine which case to execute. After the expression, there are multiple case statements. Each case statement has a value, parenthesis value 1 and value 4 in this case, that is compared to the expression. If the value matches, the code block following the case statement is executed. In the code block, for the first case statement, parenthesis value 1, there is another switch statement nested inside it. This second switch statement also has an expression, parenthesis expression 2, and multiple case statements, parenthesis value 2 and value 3, just like the outer switch statement. Depending on the value of the expression 2, one of the case statements, parenthesis value 2 or value 3, is executed, and its corresponding code block is executed. If the value of expression 2 does not match any of the case statements, the default code block is executed. After the nested switch statement, there is a break statement that exits the code block for the first case statement, parenthesis value 1. Without the break statement, execution would fall through to the next case statement. The remaining case statements, parenthesis value 4 and parenthesis default, follow the same syntax as the first case statement, and their corresponding code blocks are executed if their values match the expression or if no other cases match. There are many benefits to using nested switch statements in Java, such as improves readability. By breaking down complex logic into smaller, more manageable blocks, nested switch statements can make your code more readable and easier to understand. This can make it easier for other developers to maintain and extend your code. Simplifies complex logic. When you have complex logic that involves multiple conditions, nested switch statements can be an efficient way to simplify the code. By evaluating each condition separately, you can avoid writing long, complex if-else statements. Reduces code duplication. If you have multiple switch statements with some shared conditions, you can use a nested switch statement to avoid code duplication. This can make your code more efficient and easier to maintain. Improves performance. Switch statements are generally faster than if-else statements, and using nested switch statements can help you take advantage of this performance boost. By reducing the number of conditional checks that need to be performed, you can improve the speed and efficiency of your code, more modular code. By breaking down your code into smaller blocks, nested switch statements can make your code more modular and easier to maintain. This can help you make changes more easily and reduce the risk of introducing bugs. While the nested switch statement has several advantages, it also has some limitations, like can become difficult to read. While nested switch statements can help to simplify complex logic if they are used excessively or improperly, they can make the code difficult to read and understand. This can make it harder for other developers to maintain and extend your code, can lead to code duplication. While nested switch statements can help to reduce code duplication in some cases, they can also lead to additional code duplication if used improperly. This can make your code harder to maintain and can increase the risk of introducing bugs. May not be the most efficient approach. While switch statements can be faster than if-else statements, using nested switch statements may not always be the most efficient approach. In some cases, other approaches such as polymorphism or conditional expressions may be faster or more efficient. Limited to a single data type. Switch statements are limited to a single data type, which means that you cannot use them to evaluate complex or composite data types. This can limit their usefulness in certain situations. Limited to a small number of conditions. While switch statements can be useful For evaluating a small number of conditions, they can become unwieldy and difficult to manage if used to evaluate a large number of conditions. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we will talk about nested switch statement in Java. We already discussed a basic nested switch statement concepts in previous lectures, as well as their benefits and limitations. Now we will practice some examples using nested switch statements. Now start with simpler program. For this, we write a program to evaluate the values of two integer variables x and y using nested switch statements and print a message based on their values. If x is equal to 1, the code evaluates y and prints a message based on its value. If x is equal to 2, the code evaluates y and prints a message based on its value. And if y is not equal to either 2 or 3, it prints a default message. The code demonstrates the use of nested switch statements in Java. Now let's start creating this program. For this, open IntelliJ. Here we create a class file named traditional switch example. Then create a main method inside this traditional switch example class by write shortcut PSVM. Now we write int x is equal to 2, comma y is equal to 3, semicolon. Here declare two integer variables x and y and assign them the values 2 and 3 respectively. Then write switch open parenthesis x close parenthesis curly brace. Here we use a switch statement to evaluate the value of x. Then we create first case by writing case 1 colon. If value of x is 1, then this case executes. Then we use nested switch statement inside the case 1 by writing switch open parenthesis y close parenthesis curly brace. So if x is equal to 1, execute the code inside the nested switch statement, which evaluates the value of y. Now we create cases for nested switch statement. For this we write case 2. System.out.println parenthesis double, quote x is 1 and y is 2 semicolon, break semicolon. Case 3, system.out.println parenthesis double, quote x is 1 and y is 3 semicolon, break semicolon. Here if x is equal to 1, the inner switch statement evaluates the value of y and checks whether it is equal to 2 or 3. If y is equal to 2, the code prints the message x is 1 and y is 2. If y is equal to 3, the code prints the message x is 1 and y is 3. Finally, this break statement is used to exit the inner switch statement. Then we write break outside of nested switch curly brace. This break statement is also used to exit the outer switch statement. Now we will create second case for the outer switch statement. For this we write case 2 colon. Here if value of x is 2, then this case executes. Then we use another nested switch statement inside the case 2 by writing switch open parenthesis y close parenthesis curly brace. So if x is equal to 2, execute the code inside the nested switch statement, which evaluates the value of y. Now we create cases for this nested switch statement. For this we write case 2, system.out.println parenthesis double, quote x is 2 and y is 2 semicolon, break semicolon. Case 3, system.out.println parenthesis double quote x is 2 and y is 3 semicolon, break semicolon. Here, if x is equal to 2, the inner switch statement evaluates the value of y and checks whether it is equal to 2 or 3. If y is equal to 2, the code prints the message x is 2 and y is 2. If y is equal to 3, the code prints the message x is 2 and y is 3. Finally, this break statement is used to exit the second inner switch statement. Then we write break outside of nested switch curly brace. This break statement is also used to exit the outer switch statement. In this program, we use one outer and two nested switch statements. We already discussed the default case is optional. You may use or not. It depends on you or on program problem statement. Now run it, and here is the output after it has been successfully run. That is x is 2 and y is 3, because here x variable is equal to 2 and y is equal to 3. So first, the variable x value successfully matches the case 2 of the outer switch, and then the variable y value successfully matches the case 3 inside the second nested switch. Now we will see another example. For this, we write a program that takes values for branch and year and prints the list of elective courses using switch statements. So the first case is for the first year, and it prints two courses, Advanced English and Algebra. The second case is for the second year, and depending on the value of branch, it prints different sets of elective courses. If the branch is CSE or CCE, it prints Machine Learning and Big Data. If the branch is ECE, it prints Antenna Engineering. If none of the cases match, it prints Optimization. Now let's start creating this program. For this, we create a class file named traditional switch example2. Then create a main method inside this traditional switch example2 class by write shortcut PSVM. Now write string branch is equal to double quote CSE semicolon. Here we initialize a string variable named branch to the value CSE. The value of branch is later used in a nested switch statement to determine which elective courses to print based on the student's branch of study. Then we write int year is equal to 2 semicolon. Here we initialize an integer variable named year to the value 2. The value of year is later used in a switch statement to determine which elective courses to print based on the year of study. So here we evaluate two variables, a string variable branch and an integer variable year. The code prints the elective courses for each year of study based on the value of the variable year and the branch of study specified in the branch variable. Then write switch, open parenthesis year, close parenthesis curly brace. Here we use a switch statement to evaluate the value of year. Now we create first case by writing case 1 colon system dot out dot println parenthesis double quote elective courses colon advanced English comma algebra semicolon break semicolon. So here the switch statement uses the value of the variable year to determine if the value of year is 1, then the program will print the message elective courses advanced English algebra using the println method statement. After executing the println method statement, the break statement is used to exit the switch block and continue with the rest of the program. If the value of year is not 1, then the program will move on to the next case in the switch statement. So now we create a second case by writing case 2. This case will run when the value of the year variable is 2. Now we create a nested switch, and there are cases inside this case. For this, we write switch, open parenthesis branch, close parenthesis curly brace, case double quote, CSE, colon case double quote, CCE, colon system dot out dot println, parenthesis double quote, elective courses, colon machine learning, comma, big data, semicolon, break semicolon. So the second case in the outer switch statement. It checks if the value of year is 2, the program will move to the inner switch statement to determine which elective courses to print based on the student's branch of study. In this case, the inner switch statement checks if the value of branch is either CSE or CCE. If the value of branch matches either of these two cases, then the program will print the message elective courses, machine learning, big data using the println statement. The break statement is used to exit the inner switch block and continue with the rest of the program. If the value of branch does not match either of these two cases, then the program will move on to the next case in the inner switch statement. Then we create other case for inner or nested switch statement. For this, we write case double quote ECE colon system dot out dot print ln parenthesis double quote elective courses colon antenna engineering semicolon break semicolon. Here it checks if the value of year is 2, and then it checks if the value of branch is ECE. If the value of branch matches, then the program will print the message elective courses, antenna engineering, using the println statement. Then we add default case in the nested switch statement by writing default colon system dot out dot print ln parenthesis double quote elective courses colon optimization semicolon break semicolon. If none of the cases within the inner switch statement match the value of branch, then the program will execute the default case. In this case, the program will print the message elective courses optimization using the println statement. The break statement is used to exit the inner switch block and continue with the rest of the program. Now run it. And here is the output after it has been successfully run. That is elective courses, machine learning, big data, because here branch variable is equal to CSE and year variable is equal to 2. So first, the variable year value successfully matches the case 2 of the outer switch, and then the variable branch value successfully matches the case CSE inside the first case of nested switch. Now we will see another example. For this, we write a program to select the pizza based on its size and toppings. First select the size and then select the toppings. So the program takes in two characters representing the size and toppings of the pizza and uses nested switch statements to output the appropriate message based on the combination of size and toppings. If an invalid size or topping is entered, the program will output an error message. The program will use three sizes: S for small, M for medium, and L for large. And then we use three toppings: P for pepperoni topping, C for cheese topping, and V for vegetable topping. Now let's start creating this program. For this, we create a class file named traditional switch example 3. Then create a main method inside this traditional switch example 3 class by write shortcut PSVM. Now write char size is equal to single quote L, comma toppings is equal to single quote C, semicolon. Here two character variables named size and toppings are declared and initialized with the values L and C respectively. These variables will be used later in nested switch statements to determine the appropriate message to output based on the combination of pizza size and toppings. The character L represents a large pizza size and C represents a cheese topping. Then write switch, open parenthesis size, close parenthesis, curly brace. Here we use a switch statement to evaluate the value of size. Then we create first case by writing case single quote S colon. If value of size is S, then this case executes. Then we use nested switch statement inside the case S by writing switch open parenthesis toppings close parenthesis curly brace. So if size is equal to S, execute the code inside the nested switch statement, which evaluates the value of toppings. Now we create cases for nested switch statement. For this, we write case single quote P colon system dot out dot println parenthesis double quote small pizza with pepperoni topping semicolon break semicolon case single quote C colon system dot out as dot println parenthesis double quote small pizza with cheese topping semicolon break semicolon case single quote V colon system dot out dot println parenthesis double quote small pizza with vegetable topping semicolon break semicolon. Here the outer switch statement is based on the value of the size variable, which is of type char. The inner switch statement is based on the value of the toppings variable, which is also of type char. When size is s, that is small pizza, the program will enter the inner switch statement and execute the code block corresponding to the value of toppings. In this case, if toppings are P, the program will output the message small pizza with pepperoni topping. If toppings are C, the program will output the message small pizza with cheese topping. If toppings are V, the program will output the message small pizza with vegetable topping. Now add default case by writing default colon curly braces system dot out dot print ln parenthesis double quote invalid topping semicolon break semicolon. So if toppings are not P, C, or V, the program will execute the default case, which outputs the message invalid topping. The break statement is used to exit the inner switch statement. Then we write break outside of nested switch curly brace. This break statement is also used to exit the outer switch statement. Now we will create second case for the outer switch statement. For this we write case single quote m colon. Here if value of size is m, then this case executes. Then we use second nested switch statement inside the case m by writing switch open parenthesis toppings close parenthesis curly brace. So if size is equal to s, execute the code inside the nested switch statement, which evaluates the value of toppings. Now we create cases for second nested switch statement. For this we write case single quote P colon system dot out dot print ln parenthesis double quote medium pizza with pepperoni topping semicolon break semicolon case single quote C colon system dot out dot print ln parenthesis double quote medium pizza with cheese topping semicolon break semicolon case single quote V colon system dot out dot print ln parenthesis double quote medium pizza with the vegetable topping semicolon break semicolon. Now add default case by writing default colon curly braces system dot out dot print ln parenthesis double quote invalid topping semicolon break semicolon. So if toppings are not P, C, or V, the program will execute the default case, which outputs the message invalid topping. The break statement is used to exit the second inner switch statement. Then we write break outside of second nested switch curly brace. This break statement is also used to exit the outer switch statement. Now we will create third case for the outer switch statement. For this we write case single quote L colon. Here if value of size is L, then this case executes. Then we use second nested switch statement inside the case L by writing switch open parenthesis toppings close parenthesis curly brace. So if size is equal to S, execute the code inside the nested switch statement, which evaluates the value of toppings. Now we create cases for third nested switch statement. For this we write case single quote P colon system dot out dot print ln parenthesis double quote large pizza with pepperoni topping semicolon break semicolon case single quote C colon system dot out dot print ln parenthesis double quote large pizza with cheese topping semicolon break semicolon case single quote V colon system dot out dot print ln parenthesis double quote large pizza with vegetable topping semicolon break semicolon. Now add default case by writing default colon curly braces system dot out dot print ln parenthesis double quote invalid topping semicolon break semicolon. So if toppings are not P, C, or V, the program will execute the default case, which outputs the message invalid topping. The break statement is used to exit the third inner switch statement. Then we write break outside a third nested switch curly brace. This break statement is also used to exit the outer switch statement. Finally, we add default case for outer switch statement by writing default colon curly braces, system.out.print, ln parenthesis, double quote invalid pizza, size semicolon, break semicolon. So if pizza size is not SM or L, the program will execute the default case, which outputs the message invalid pizza size. The break statement is used to exit the outer switch statement. Now run it, and here is the output after it has been successfully run. That is large pizza with the cheese topping, because here size variable is equal to L and toppings is equal to C. So first, the variable size value successfully matches the third case L of the outer switch. And then the variable topping value successfully matches the case C inside the third nested switch. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In this lecture, we're going to move on now to talk about the introduction to loop statements in Java. Looping is a very common need in programming because it allows us to execute code multiple times. So there are several looping statements in Java. These statements will continue to execute a block of code repetitively until a condition or some set of conditions is met. In this section of the course, we'll be looking at three loop statements. These are for loop, while loop, and do while loop. So the for loop is probably the most common and the one we'll look at first. The for loop is used when we know how many times we need to execute a block of code. It includes setup to initialize variables, checker loop expression, and update code, which often includes incrementing an iteration variable. Then while. The while that might seem simpler because it will just continue to execute code until its loop expression becomes false. So the while loop is used when we don't know how many times we need to execute a block of code, and it continues to execute until the condition becomes false. Then do while. So do while loop is like the one loop, except that it will always execute the code once, regardless of whether the loop condition is true or false, and then continue looping until that expression is false. There are several advantages of using the loop statements in Java. Some of them are like reusability. Loops allow you to execute a block of code repeatedly without having to copy and paste the same code multiple times. This makes your code more efficient, organized, and easier to maintain. Efficiency. Loops help in reducing the amount of code that needs to be written and processed, which can result in better performance and faster execution time. Flexibility. Loops provide the flexibility to execute a block of code repeatedly based on different conditions, such as a fixed number of times or until a specific condition is met. This makes it easy to handle complex scenarios and implement complex algorithms. Scalability. Loops can be used to process large data sets, such as arrays and lists, in an efficient and scalable manner, which is important for developing applications that handle big data. Improved code readability. Loops can make your code more readable and easier to understand, as they can help to reduce the amount of code that needs to be written and increase the level of abstraction in your code. Loops are an important feature in Java and other programming languages, but they do have some potential limitations in Java, including performance. Depending on how they're implemented, loops can sometimes be less efficient than other approaches for solving a particular problem. This is because loops can require a lot of processing power and memory to execute, especially when dealing with large data sets. Infinite loops. If the condition specified in a loop is not set up correctly, it can result infinite loop, which can cause the program to hang or crash. This can be a major problem if the program is running on a critical system or processing large amounts of data. Complexity. Loops can make the code more complex and difficult to understand, especially if they are nested or used in conjunction with other control structures, like if-else statements or switch statements. Maintenance. Loops can be difficult to maintain, especially if they are used in a large and complex program. Changes to the code can have unintended consequences, and it can be difficult to test and debug loops that are nested or have complex conditions. Code readability. While loops can improve code readability by reducing the amount of code that needs to be written, they can also make the code more difficult to read and understand if they are used excessively or inappropriately. Now we discuss for loop syntax. The for statement is also called the for loop because it loops something over and over again until the condition is met. When I say repeatedly loops, I mean it's processing a certain amount of code, a code block, in other words, the given number of times or until a particular condition is satisfied. The basic structure for statements and declarations is divided into three parts. These are declared in parentheses after the for keyword and are separated by semicolons. These parts are all optional and consist of initialization, condition, increment, or decrement. Initialization. This part is executed only once before the loop starts. It is used to initialize the loop counter variable to a starting value. Condition. This part is evaluated at the beginning of each iteration of the loop. If the condition is true, the loop will execute. Otherwise, it will terminate. Increment or decrement. This part is executed at the end of each iteration of the loop. It is used to increment or decrement the loop counter variable by a fixed value. For example, if we want to display a count from 0 to 9 using for loop, for this we use for loop statement and in the parenthesis. The first part is initialization. Here, the loop counter variable I is initialized to 0 using the statement int I is equal to 0, semicolon. This statement is executed only once, at the beginning of the loop. Then second part, condition. Here the loop will continue to execute as long as I is less than 10. The condition I less than 10 is evaluated at the beginning of each iteration of the loop. Then third part, increment or decrement. Here we use increment because the value incremented by 1 from 0 to less than 10. So the loop counter variable I is incremented by 1 at the end of each iteration using the statement I++. To create block of loop, use the open and close curly braces. Inside the loop block, the system.out.println method is used to print the value of I at each iteration of the loop. The loop will execute 10 times with the loop counter variable I taking on the values 0 through 9. Note that in Java, the curly braces that delimit the block of code inside a loop or any other control structure are not optional. However, there is an exception when there is only one statement inside the loop, in which case the curly braces can be omitted. However, if there is only one statement inside the loop block, the curly braces can be omitted. In our for loop example, the code prints the numbers 0 through 9, but with the loop block containing only a single statement, if the curly braces omitted from this loop block. This syntax is allowed in Java, but it can make the code less clear and harder to read, especially if the loop block contains more than one statement. In summary, while the curly braces that delimit the block of code inside a loop are generally required in Java, they can be omitted if there is only one statement inside the loop block. However, it is generally recommended to always include the curly braces to make the code clearer and easier to read. Now we discuss while loop syntax. The while loop has one part that is condition. So the condition part of the while loop is a Boolean expression that is evaluated before each iteration of the loop. If the condition is true, the loop will execute. Otherwise, it will terminate. The condition can be any expression that returns a Boolean value. Now we use the same example as we used for the for loop. Here is the code. As previously stated, the while loop has only one component, which is the condition. So the initiation is made before the while loop, as you can see. Then while loop statement and inside the parenthesis use condition that the loop will execute repeatedly as long as the condition I less than 10 is true. The code within the loop will execute repeatedly until the condition is false. The increment or decrement of the loop counter variable, that is I, is usually done within the loop. Now we discussed do-while loop syntax. It is same as the while loop, but the main difference between while and do-while loops in Java is that the while loop checks the loop condition at the beginning of the loop before executing the loop body, while the do-while loop checks the loop condition at the end of the loop after executing the loop body at least once. So the keyword do starts the do-while loop block. The block of code that should be executed repeatedly is enclosed in curly braces. The keyword while is followed by a condition that is evaluated at the end of each iteration. If the condition is true, the loop will continue to execute the block of code. Otherwise, the loop will terminate. And there is a semicolon at the end of loop syntax. Here you can see an example. In this code, the do-while loop will execute at least once because the loop condition is checked at the end of the loop. The loop body will print the value of I to the console, starting with 1 and then increment the value of I by 1. However, since the loop condition is I greater than 5 and I start with a value of 1, the loop condition is immediately false, and the loop terminates after executing the loop body only once. The loop terminates because I is not greater than 5. Therefore, the loop body is executed only once, and the value of I is never greater than 5. I hope you learned something useful in this lecture as well, and I'll see you in the next one. In the previous lecture, we discussed the introduction of loops and their types, and we also discussed their syntax. In this lecture, we will talk about for loop. So, the for loop is probably the most common and the one we'll look at first. The for loop is used when we know how many times we need to execute a block of code. It includes setup to initialize variables, checker loop expression, and update code, which often includes incrementing an iteration variable. The for statement is also called the for loop because it loops something over and over again until the condition is met. When I say repeatedly loops, I mean it's processing a certain amount of code, a code block. In other words, the given number of times or until a particular condition is satisfied. Now start with a simpler example using for loop. So we write a program to print numbers from 1 to 5 using a for loop. Now let's start creating this program. For this, open and tell ij. Here we create a class file named for loop. Then create a main method inside this for loop class by write shortcut psvm. In the main method, we write for open parenthesis int I equals 1 semicolon, I less than equals to 5 semicolon, I plus plus close parenthesis, curly braces. Then inside the loop body write system dot out dot, print ln parenthesis I. So here loop starts with initializing a variable I to 1, that is int I equal 1. Then loop condition is checked. Since I is less than or equal to 5, the condition I less than or equal to 5 is true, and the loop body is executed. Then increment the value by 1 using I++. Then a loop body consists of a single statement that prints the value of I to the console using system.out.println parenthesis I. Now we run it. Here is the output after a successful run. That is 1 to 5. In this case, I is 1, so the first output is 1. Then loop updates the value of I using the I++ statement. This adds 1 to the current value of I, making it 2. Then loop condition is checked again. Since I is less than or equal to 5, the condition I less than equal 5 is true, and the loop body is executed again. Then loop body prints the value of I to the console. In this case, I is 2, so the output is 2. Then loop updates the value of I again using the I++ statement. This adds 1 to the current value of I, making it 3. Then loop condition is checked again. Since I is less than or equal to 5, the condition I less than equal 5 is true, and the loop body is executed again. Then loop body prints the value of I to the console. In this case, I is 3, so the output is 3. Then a loop updates the value of I again using the I++. This adds 1 to the current value of I, making it 4. Then loop condition is checked again. Since I is less than or equal to 5, the condition I less than equal 5 is true, and the loop body is executed again. Then loop body prints the value of I to the console. In this case, I is 4, so the output is 4. Then loop updates the value of I again using the I++ statement. This adds 1 to the current value of I, making it 5. Then loop condition is checked again. Since I is less than or equal to 5, the condition I less than or equals to 5 is true, and the loop body is executed again. Then loop body prints the value of I to the console. In this case, I is 5, so the output is 5. Then a loop updates the value of I again using the I++ statement. This adds 1 to the current value of I, making it 6. Then loop condition is checked again. Since I is now greater than 5, the condition I less than equal 5 is false, and the loop exits. Now we see another example using the for loop. So we write a program that iterates from 1 to 10 and prints each number to the console except for 5. If the loop encounters the number 8, it should immediately exit. Now let's start creating this program. Here we create another class file named for loop1. Then create a main method inside this for loop1 class by write shortcut PSVM. In the main method we write for open parenthesis int I equals 1 semicolon I less than or equal to 10 semicolon I plus plus close parenthesis curly braces. So here, loop starts with initializing a variable I to 1, that is int I equal 1. Then loop condition is checked. Since I is less than or equal to 10, the condition I less than or equals to 10 is true, and the loop body is executed. Then increment the value by 1 using I++. Then inside the loop body write if parenthesis I equal 5 curly braces continues semicolon. Here the if statement is checked to see if the condition is true. In this case, the condition is whether I is equal to 5. If the condition is true, the continue statement is executed, which immediately skips the rest of the current iteration of the loop and jumps to the next iteration. In other words, it bypasses any statements in the loop body that come after the continue statement. If the condition is false, the continue statement is not executed and the program proceeds to the next statement after the if statement. So continue statement allows the program to skip over certain iterations of a loop based on a specific condition. Then write else if parenthesis I equal 8 curly braces break semicolon. The else if statement is checked to see if the condition is true. In this case, the condition is whether I is equal to 8. If the condition is true, the break statement is executed, which immediately exits the loop, even if the loop condition has not yet been met. This means that the program will skip over any remaining iterations of the loop and continue with the next statement after the loop. If the condition is false, the else if statement is not executed, and the program proceeds to the next statement after the loop or to the next statement in the loop body, if any. We already discussed break statement in switch statement lectures. Then outside of these conditions, we write system.out.println parenthesis I semicolon. Now we run it. Here is the output after a successful run. So here you can see that 5, 9, and 10 numbers are not printed. Because in this example, when the loop runs first time, the variable I is initialized with 1. Then loop condition is checked. Since I is less than or equal to 10, the condition I less than or equals to 10 is true, and the loop body is executed. Then loop body checks if I is equal to 5. Since it is not, the else if statement is checked. Since I is not equal to 8, the else if statement is not executed, and the program proceeds to the next statement. Then loop body prints the value of I to the console using the print statement. In this case, I is 1, so the output is 1. Then loop updates the value of I using the I++ statement. This adds 1 to the current value of I, making it 2. Then a loop condition is checked again. Since I is still less than or equal to 10, the condition I less than or equals to 10 is true, and the loop body is executed again. Then a loop body checks if I is equal to 5. Since it is not, the else if statement is checked. Since I is not equal to 8, the else if statement is not executed, and the program proceeds to the next statement. Then loop body prints the value of I to the console. In this case, I is 2, so the output is 2. Then loop updates the value of I again using the I++ statement. This adds 1 to the current value of I, making it 3. The loop condition is checked again. Since I is still less than or equal to 10, the condition I less than or equals to 10 is true, and the loop body is executed again. Then loop body checks if I is equal to 5. Since it is not, the else if statement is checked. Since I is not equal to 8, the else if statement is not executed, and the program proceeds to the next statement. Then loop body prints the value of I to the console. In this case, I is 3, so the output is 3. Steps 4, 6, and 7 are repeated for each subsequent iteration of the loop, with the output being 4, 6, 7. But when I is equal to 5, the if statement is executed, and the continue statement is executed, which skip over remaining iterations of the loop and continue with the next statement after the loop. Same way when I is equal to 8, the else if statement is executed, and the break statement is executed, which immediately exits the loop. Then the loop is finished, and therefore the final output shows 1, 2, 3, 4, 6, and 7. Now we'll look at a slightly more complicated example that makes use of the for loop. So we write a program to check whether the given number is prime or not. Now first we discuss what prime number is and how to find them. So prime numbers are a special type of whole numbers that have exactly two factors, 1 and themselves. This means that they cannot be divided evenly by any other positive integer except for 1 and the number itself. For example, 2 is a prime number because its only factors are 1 and 2. Similarly, 3, 5, 7, 11, 13, 17, 19, 23, 29, and 31 are prime numbers because they only have two factors. As you can see there, it lists the prime numbers of 1000. For instance, the number 7 cannot be divided by any number other than 1. That will produce a whole number, so it's a prime number. 7 divided by 1 is 7, and 7 divided by 7 is 1, which are both whole numbers. But any other number will result in a decimal number, whereas 9 can be divided by 3, which equals a whole number, and therefore it's not a prime number. The number 1 is not considered as a prime number, but the number 2 is. However, any other number divisible by 2 is not a prime number. That's a super simplified explanation for those of you who hate math. Don't worry, I'm not going to ask you to create the prime number method on your own. Prime numbers are used in computer science to generate random numbers and in various algorithms for optimization and search. Moreover, prime numbers are also used in various areas of mathematics, such as algebra, geometry, and calculus. For instance, prime numbers appear in the study of polynomial equations, elliptic curves, and number fields. I think now you better understand what a prime number is. Now we discuss how to find them. So, there are many ways to find a given number is prime or not. Divide the given number by 2. Take the first half of given number and start dividing it from 2 to last half number. If any one number divides the given number completely, then it's not prime number. Otherwise, it's prime number. Now let's create this program. First, we create a class file named find prime numbers, and then inside it create main method using shortcut PSVM. We're going to create is prime method before we do anything else. First, let's create the method using public static boolean is prime opening parentheses int whole number closing parentheses curly braces return true semicolon. So it will be returning a boolean from this method. True if the number passed, which is the parameter, is a prime number, and false if it is not. So the parameter name is whole number, and I have used this is prime as the method name. Because this method is not really operable, we'll just return true. Let's next add some simple test cases to our main method. We'll test the number 0, and here's a decent opportunity to use the ternary operator. If the number is prime, the text will say a prime number, and if the number is not prime, the text will say not a prime number. I'm going to main method. Now write system.out.println, opening parentheses, double quotes, 0 is plus opening parentheses, is prime opening parentheses, 0 closing parentheses, question mark, double quotes, colon, double quotes, not closing parentheses plus double quotes, a prime number closing parentheses, semicolon. So you can see we're calling the method here, asking at the number 0 in this line. And this is making the call to the is prime method from the first operand of the ternary operator, which uses the question mark and colon. We concatenate an empty string, but if it's false, we'll slip in the word, not in the text. Because I was prime method right now always returns true. When this code be run, it will indicate that all numbers are prime numbers. First, we'll check if the number is less than or equal to 2 with if-then statement. If it's less than or equal to 2, we want to return false if the number is negative 0 or 1 because these are not prime numbers. If the number is 2, however, we want to return true because 2 is a prime number. So we can do this by returning the value that will be returned from the Boolean expression a whole number equals 2 using the double equal sign here, the equality operator. Now we write if opening parentheses a whole number less than or equal to 2 closing parentheses opening curly brace. Return opening parentheses whole number equals to 2 closing parentheses semicolon. So now let's see where we're at and run that with our test case. Here you can see the output that 0 is a prime number. So you remember to set up a for loop. We need a starting point, a condition to stop at, and a way to increment the variable that we're checking. So let's have this for loop. For open parentheses, int divisor equals 2 semicolon, divisor less than a whole number semicolon, divisor plus plus closing parentheses, curly braces. We create a variable called a divisor. This is the number we'll be dividing the whole number by. We'll keep flipping if the device is less than whole number. If we used less than or equal there instead of less than, then would have the condition that whole number would be divided by itself at the end, and it would then say that the number was not prime, which would be wrong. So make sure this is just a less than symbol by itself, and then we'll increment by 1 each time, so the postfix operator will do the job for that. Now thinking about the number 8, that's the whole number. For example, we'll be looping from 2 to 7, incrementing by 1 each time. And what do we want to check each time? All we want to know if the whole number is evenly divisible by that loop variable, which we're calling divisor. What operator can we do this with? The remainder operator will modulus operator, whatever you like to call it. Let's add that code. If opening parentheses whole number modulus divisor equals 0, closing parentheses curly braces, return false semicolon. Here we have an if statement that checks if the whole number is divisible by the loop parameter, which we're calling divisor. If our whole number can be evenly divisible by any number other than itself, so that is any number between 2 and 1 less than its value, then that means the whole number can't be a prime number. In other words, we've had a number that evenly divides into a whole number, which means whole number isn't prime. We start with 2 because everything is divisible by 1. So starting with 1 would give us false positives. But notice that every even number will return a false on the first iteration of the loop. So that's pretty efficient. But it also said that we're just putting a return in that if code block. This will exit the loop at that moment when the condition is true, breaking out of the loop and exiting the entire method returning false. Now to test, we first add more cases. For this, we go into the main method and write system.out.println opening parentheses double quotes. One is plus opening parentheses is prime opening parentheses 1 closing parentheses question mark double quotes colon double quotes not closing parentheses plus double quotes a prime number closing parentheses semicolon. Now copy and paste this line many times and now change their values that are 2, 3, 8, 17, and 21. Now run it. Here you see the output that 0, 1, 8, and 21 are not prime numbers, and 2, 3, and 17 are prime numbers. There are other ways we could program this, but this is a pretty easy way to get your answer and get out of the loop and subsequently the method. When you're using loops, it's a good idea to see if there are any ways to cut down on iterations, especially if the code block that's being executed is complex or creating a lot of variables. One minor thing we could do is change the code to iterate over fewer values. We could use the halfway mark for a number as the maximum value. Let's make those two minor changes, changing less than or equal to the whole number to a whole number divided by 2. So think about why this is more efficient for a minute. And what should still work? Anything that is divisible by the smallest number 2 will also be divisible by that whole number divided by 2. So checking numbers greater than half the whole number is really just wasted effort. Now run it. Now you can see that gives us the same results. I hope you learned something useful in this lecture as well, and I'll see you in the next one.